Hello and welcome to Devfest 2020. I'm Jason Titus, VP of Engineering at Google, joining you from my home in California. Each year, we at Google truly feel the anticipation for Devfest. It's a one-of-a-kind series of developer conferences, and we're glad you can join us and the local developers within your community. Your local Devfest event this weekend is one of hundreds taking place all around the world right at this moment. And what makes Devfest truly unique is that it's run by volunteer community organizers on a mission to help other local developers grow and share a passion for Google technologies. Now, 2020 has been a year of radical change for people across the globe. But when difficult times came about, developers within this community came together online to plan a virtual DevFest where each local chapter can participate, helping each other teach and learn when we need to connect the most. And these connections can be so important. I can remember the first developer conferences I went to, where I met people who were already doing the kinds of things I dreamed of doing. They had started companies, built products, and I got to hear the stories of what had worked and what had gone wrong. And we hope that all of you will get to have similar experiences at Devfest this year. At Google, we've always believed that we are only successful when all of our users are successful. While Google and its products may plant a seed, it's developers like yourself who make the seeds grow and thrive. This community of developers has shown us firsthand how you're using technology to help each other during times of need. Let me introduce you to my teammate David to share with you some great examples. Welcome, David.
Hi, Jason. Thank you. And welcome everybody to this year's DevFest season. I'm David McLaughlin, Director of Developer Ecosystems at Google. So I've been with DevFest since the very first year in 2010, when I was able to join a large percentage of them. Back then, they were a series of targeted events in just a handful of countries. In the years since then, we've had massive growth to countries all over the world. While I really do miss being able to join many of you in person this year, I'm happy to be able to continue the celebration of developers and tech in a new virtual format and bring people together to learn and to share what we're all building. Over the years, it's been great to see the apps and the solutions the broader community has built with the support of their local GDG chapters. We now have thousands and thousands of developers who are working to address real-world problems in their local communities. Particularly during the challenging times of COVID, I'm impressed by how much your work has made people's lives better. There's a few recent examples that truly stand out to me. Community developers from GDG West Sweden recently worked with the Swedish government to create Hack the Crisis, an event focused on designing, testing, and executing ideas in response to recent challenges. One of the finalists, named Remote and Gigs, helped modernize the Swedish government's employment website to match job seekers with remote work. Nearby in Romania, GDG groups organized a hackathon, gathering 270 different mentors and students from across 8 different countries. The hackathon brought together developers to save lives, to save communities, and to save businesses. Some of the winners included an online platform that connected volunteers with nonprofits across the region, a system to help doctors work with each other and to ease online consultations, and a personal assistant for health and nutrition tracking. Another cool app that they developed was Risk Alert, an app that alerts emergency rooms that a patient with a very rare disease is about to arrive so that the hospital can prepare for any special needs. In Asia, GDG Tainan initiated the Mask Inventory Map at the start of COVID-19, which crowdsources mask inventory from local store data, combining it with the Google Maps API. The project was so popular that it caught the attention of Taiwan's government, inspiring them to publish public data APIs on mask inventory managed by the government. Taiwan's digital minister has since encouraged the GDG Tainan chapter to create more than 100 different apps to help the local community. In India, GDG Cloud Pune used machine learning with TensorFlow and GCP to help their community with an app that remotely analyzes dental health and helps patients book at-home dental services. They've had over 300 trained images so far, and the developer community is working with local universities to gather more than 50,000 dental images to improve the application. In the Middle East, the region's largest International Women's Day event was held in April in Turkey by multiple GDG groups working together. They had over 2,500 attendees to the event, which included a raffle for online courses and talks in artificial intelligence and data mining. The event helped women across the community and across the region learn and apply their skills. And of course, here in the United States, the GDG Memphis chapter has joined GiveCamp, where software developers in the area donate their skills for nonprofits, as well as helping kids learn to code on the weekends. These are just a small sample of the ways that Google Developer Group chapters and communities like yours all over the world are learning together and giving back what they've learned to really help people's lives everywhere be better. I encourage all of you to continue, be in community with your fellow developers. Think about how can you use the skills and the tech that you're learning this weekend at DevFest, as well as the networks and the communities that you form, the new friends that you make. How do you combine all of these to make a difference in your own area? Now let's take a look at a really inspiring story from Uganda. It shows how a community member started learning about machine learning and ended up building a really nifty app using TensorFlow that detects diseases in plants and helps farmers reduce crop devastation. Take a look.
Growing up in the city, I never expected to work in agriculture. But when fall armyworm attacked, it affected us all. Since its arrival in 2016, this crop pest has caused massive devastation. I've met farmers who have lost everything.
Tubadde tukozesako ddagala okulaba nti akako kulya ki kasooli naye akantu ako tekayinza kumalawo obulwadde obwo.
So I wanted to use my skills as a software developer to help. At a Google Study Jam, we taught ourselves TensorFlow. We started by building an Android app on top of an open source API. The app allows farmers to spot infestations early, far beyond the capability of human eyes, and suggest an effective treatment. When I was younger, I didn't know what I wanted to do, but then I discovered app development, and I was excited to show people something they never thought possible. Machine learning gives us the advantage against fall armyworm, ultimately saving harvests and reducing pesticides.
Kunkyusizaamu kubanga taata oba jjajja teyalina ennyumba y'ebbaati. N'ebbaati nazimba ennyumba yange nga tetoonya, tulina essuubi ne tufuna embeera ennungi mu kulima.
We are just getting started, and there are so many other sectors like health and education that machine learning could really improve. Farming is a crucial aspect of life in Uganda, and I feel proud I'm part of a team driving to ensure our culture can continue.
Earlier, you saw a beautiful inspirational video about how machine learning and Android were used to create an app to detect crop diseases. So for Devfest, I wanted to get together a few of my friends from Google and beyond to show you how you could get started in building something just like that from scratch in a few minutes. We'll build an Android app and a web app. So to get started with Android, let's see what Chet can teach us.
I want to create an app that's able to recognize information about plants. It's going to need camera functionality as well as machine learning inference. Let's see what that looks like in code. The app is written in Kotlin and uses Camera X to take the pictures and MLKit for on-device machine learning analysis. The core functionality is in Take Photo, where we take a picture, analyze it, and display the results. First, we call Take Picture on a Camera X image capture object that was created earlier. One of the parameters is a callback object, which has this on-capture success function. We get the received image into the format we need for MLKit, then we create an image labeler object and process the image. When this succeeds, we receive a collection of image labels, which we turn into text strings and display a toast with the results. Let's see what the demo looks like. So we'll take a picture and it says, I see an insect and a plant. So that was pretty easy, rigging up Camera X and MLKit to detect arbitrary objects in the camera view. But the results were pretty generic because the dataset didn't have enough information about our domain. So let's dig a little deeper.
Okay, let's go deeper. Now we need a model for something very specific, detecting diseases in bean plants instead of cassava. Let's explore how to build it. On this guide, we'll use some of the great TensorFlow tooling available. Let's start with Colab. You can understand Colab as a cloud-hosted development tool. We will do all our coding on it, and you will not need to install anything on your machine. Let's start with a new notebook. Let's just turn the title to beans. We will need to install some packages that we're going to use later. These packages are not installed on your machine. They are on a cloud machine that was created for your Colab. Nice, it finished installing the packages. Let's download the data and do some visualization to understand how our data is separated. Perfect. We download the data. Let's take a look on some of the images so we can have a better understanding of what we are doing here. Here they are. These are some of the images that will be used for training our model later. Now we have the data. We need to create a model. We are not going to create one from scratch. We are going to use a technique called transfer learning. TensorFlow Hub is a repository for TensorFlow models. You can find all kinds of models here. Let's start with this one. Let's go back to our Colab. Let's define a model handle. Nice. Now we have the data and the base model. How can we do transfer learning? To do that, we are going to use one of the tooling that I mentioned before called Model Maker. Model Maker makes your life way easier when you need to do transfer learning. Let's create the spec for our base model. Let's create our training variables here using the dataset beans that we've just seen. And now we're going to put everything together with Model Maker by defining a model with the training data and the spec that we got from TensorFlow Hub. This will take a couple of minutes. It finished training. And as you can see here, our accuracy is at 87%. Of course, let's evaluate the model with some data you didn't see yet and see how good it is. Nice, 95%.
The TensorFlow Lite model Gus just created contains all the metadata Android Studio needs to recognize it and automatically build classes for it. To get started, you can update your build.gradle file to include the following TensorFlow Lite dependencies. Then, you'll want to import your generated TF-Lite file into the ML folder of your project. Let's check out the details of our imported model. From here, we can see an example of how to use the model in our app. Let's move over to the main activity class to take advantage of it. Inside of our image capture callback, here on line number 78, we create an instance of our model. Next, we use it to process the captured image here on line number 84. And finally, here on lines 92 through 98, we display the results of consuming the output inside of a toast message. Let's run our app. Now, instead of telling us it's looking at a leaf or a plant, it can actually tell us if it's looking at a bean leaf and give a diagnosis. Sweet.
So this concept works, but it's very much a raw demo. What if we want to make this a more successful app? Well, we probably need to add services like authentication so our users can sign in, analytics and A/B testing so we can find out how our users are really interacting with our app, some crash reporting or performance monitoring, and an easy way to save our users' data to the cloud. Luckily, that's where Firebase comes in. Now, the new and improved Firebase plugin in Android Studio makes this simple. I'll start by adding some analytics so I can find out exactly how our users are interacting with our app. And the plugin does most of the work to get the library integrated into my project. Now that I've done that, well, we can get an instance of the library up here, and then we can log what kind of results we're getting from MLKit. And then once we've done that, there's a lot of ways to get at this data. It'll start showing up here in the Firebase dashboard, but I find one really fun way of viewing this data is to use Stream View, which kind of gives you a real-timey sample of what kinds of analytics results we're seeing. Looks like I've already recorded several of these select content events, and I can dig into these event properties and see what kinds of results our users are getting, and I could start using that information to maybe refine my MLKit model or A/B test different alternatives. Firebase helps you build better apps, and analytics is just the tip of the proverbial iceberg. Maybe we could let our users upload their own pictures and store them in the cloud using cloud storage for Firebase. There's so many possibilities.
This is a sample app, but if we were to productize this, it's important to keep in mind how our AI design decisions impact our users. For instance, we need to consider if and/or how it makes sense to display confidence intervals to help your users interpret the ML model output. Or say how you design the onboarding experience sets user expectations for the capabilities and limitations of your ML-based app, which is vital to app adoption and engagement. For more guidance on AI design decisions, check out the People Plus AI Guidebook at pair.withgoogle.com/guidebook. This use case focuses on plant diseases, but for other use cases where our ML-based predictions intersect with people or communities, we absolutely need to think about responsible AI themes like privacy and fairness, which you can learn more about at tensorflow.org/resources/responsible-AI.
And don't forget about the web. I built a PWA that can be installed across all your users' platforms. It combines the web camera with TensorFlow.js, and by integrating machine learning, we can make an amazing experience that runs across all browsers. Now let's take a look. We have our standard project layout with a HTML file, a manifest, and a service worker to make it a PWA. We have some styles to make it look good, and our data folder that contains our TensorFlow configuration and trained model that we're going to use in the app. Now to the heart of the project. Let's go back to the HTML file and see what's happening. We're also loading a webcam object. This is just a class that wraps some boilerplate logic to make it easier to pass camera data from getUserMedia to TensorFlow. And now let's dive into our app logic in index.js. So I'm just going to use Chrome and the debugger here. And this is only so you can kind of see how easy it is to integrate machine learning into your application. So let's get started by clicking the classify button, get the machine learning gears into action, and immediately we break into the TensorFlow tidy function. This is just there to help you kind of clean up any of the memory that TensorFlow uses whilst it makes a prediction. We get our image from the web camera, and then we pass our image back into the machine learning algorithm to make it a prediction. And once we've got a prediction, we access the data, and then we can use that data to update the user interface kind of based on any application logic that we want. And that's pretty much it.
Great. So now you have the platform for building a real app. With the tooling from Android Studio, the APIs from CameraX, Jetpack, MLKit, Colab, TensorFlow, Firebase, Chrome, and Google Cloud, you have a lot of things that just work better together. This isn't a finished project by any means, just a proof of concept for how a minimum viable product with a roadmap to completion can be put together using Google's developer tools and APIs.
You might also want to open source this project too, so developers can suggest improvements, optimizations, and even additional features by filing an issue or sending a pull request. It's a great way to get your hard work in front of even more people. We'd love to help you with this, and you can learn more about the process at opensource.guide/startingaproject. Indeed, we've already open sourced the bean disease sample we discussed in this video, so you can have a great place to start.
Thanks, Pooja. And as you mentioned, open sourcing a project is a great way to make it grow and inspire people to adopt and extend it. If you want to learn more about what you've seen in this video, please visit us at developers.google.com.
Hi, developers. My name is Annie Jean-Baptiste, and I'm the head of product inclusion at Google. The demo you just saw shows how Google's products can come together to create an amazing app. But what about product inclusion? You may be wondering, well, what is product inclusion and why is it important? At Google, we believe that giving power to new voices is the core of innovation. When we bring an inclusive lens to the product design process, we amplify underrepresented voices and allow all users to feel seen and validated in the moments that matter for them. We look beyond ourselves and seek out diverse voices to shape the products that we build. We also believe that we have a responsibility not to disappoint our users, no matter who they are, what they look like, how much money they make, who they love, how old they are, or anything that makes them them. And when we make difference the new normal, we will usher in new opportunities to grow our business by earning the love of all of our users. So whether you're 1 or 105 years old, live in a city or a remote village, on Wi-Fi or cellular service, Google is there for you to make sure you have the answers you need when you need them. Product inclusion is exactly what it sounds like, bringing an inclusive lens throughout the entire product design process to create more inclusive products for our users. And so when you're developing your own apps, I challenge you to incorporate the principles of product inclusion into the design process, because we believe that you can do well and do good by being intentional about including underrepresented voices at key points in the product design process. Remember, those closest to the problem are also closest to the solution. You can learn more about product inclusion at Google by visiting accelerate.withgoogle.com. Thanks.
Hi, everyone. My name is Jen Cole, and I'm the Global Developer Communities Program Manager at Google. Now it's time to meet and hear from your local developers. So what can you expect next from your local Devfest? We'll have technical talks, breakout sessions, networking opportunities, and more. These sessions will cover a variety of technologies, such as Android, Google Cloud Platform, machine learning with TensorFlow, web, Firebase, Google Assistant, and Flutter, with speakers from Google, women tech makers, Google developer experts, and your local community. Be sure to claim your badge for participating in Devfest 2020 by going to google.dev/devfest2020. You can earn even more badges by mastering different Google technologies available on developers.google.com/learn. As a reminder, one of the most important parts of Devfest is providing an inclusive and harassment-free experience for everyone. As an active participant of Devfest, today, we can all agree to treat everyone with respect and to speak up if we see or experience harassment of any kind. Together, we can create an environment that is welcoming and inclusive to everyone with us here today. Follow @GDG on Twitter for highlights from Devfest around the world, and try out the Devfest AR filter and avatar. Share what you're learning or your favorite part about the event on social media with #Devfest. And lastly, don't forget community is all about getting to know one another. Use the virtual breakout rooms and chat feature to connect with other developers near you with shared interests. We hope you enjoyed Devfest 2020.
Hi everyone, this is Maciek from GFT Poland, and we are delighted to be sponsoring this fantastic event and supporting the GCP community in Poland. We are part of GFT Group with engineers in 15 countries across the globe, and in Poland we are a team of 900 people in Poznań, Łódź, Warsaw, and now also in Krakow. We specialize in delivery of complex software solutions for global clients in finance, insurance, industry, and other sectors. And we are especially proud of our strong cloud capabilities, both in software development and infrastructure, including some cutting-edge stuff such as multi-cloud solutions. We foster strong partnerships with all leading cloud providers, including Google, of course, and put strong emphasis on skill and career growth in the cloud, for example, through our internal cloud community. And today you will hear some of this with Maciek, head of our AI community, and two technical leads, Kamil and Konrad. They will talk about some really cool stuff about using AI and machine learning in the cloud, and also API management using Google's APG platform. We hope you enjoy the talk, and check us out at gft.com/pl, and of course on our social media channels on Facebook and LinkedIn. Have a great day.
Okay, so welcome to our Devfest. This year is 9th time we are organizing it in Poland. And I would like to say at first about GG history. It was established almost 11 years ago. It, in the years, transformed into Google Developers Group. And now, as you can see, we are quite big community that is in direct contact with Google engineers and helps community grow and learn. We are trying to inspire developers everywhere. GG Worldwide is in 139 countries. As you can see this official map, we are almost everywhere. We have almost 1,000 chapters in different cities. So if you are trying to do something for the community, it's a great place to start. Look in your city in the Meetup or ggcommunity.dev webpage. This year's edition is brought to you by few chapters. We are in Poland over 10,000 members strong in Meetup, and we organize over 250 events during our time in GDG. This is our fantastic team that brought you this experience. I would like you to give them a welcome and thank you, because without them we couldn't have made it. So thank you guys, I really appreciate it, and I hope this was great experience for you. And of course, talking about people who help, we are very thankful for our community partners, because community is all we care about. So building that is really important for us. We also had a great help for our media partners. So Judgeon IT, Segfault, for programmers, Android Compile, and Programista Magazine, thank you very much for sharing a word about our conference. We also had help from a few sponsors. One of them was Droids on Roids, a mobile app company from Wrocław that is really engaged in local communities, and JetBrains, who sponsored free licenses for the products for people who will be attending our conference. But our ultimate sponsor is GFT. It's also a company that specializes in very interesting cloud projects. And this really the people you call when you have really hard time to figure out your cloud infrastructure, your mobile infrastructure, anything that they can do everything. So thank you very much, GFD, for sponsoring this event. And as I said, there's a giveaway, free personal subscription for 1 year for people who RSVP'd in our GG community platform in our event. So if you hadn't done that, that's a great moment to do it. Hello, we have our first speaker at the web track, Sergey. Are you ready to give your talk?
Yes, sure.
I cannot hear you.
Oh my god. What's wrong?
Can you hear Sergey?
Can you hear me? Yes. People say yes.
Did you start sharing the screen?
No. Yes.
Okay. Okay, it's great.
So can you see
So
my screen?
without further delay, let's let Sergey talk about his. Yeah, it's great, Sergey. Sorry, you can start.
Okay. Hi everybody, my name is Sergey, and today I want to talk with you about code reviews. I work at Skyeng. We are the largest online English language school in Europe. Our stack consists mostly from PHP, Angular, Node.js, and all our developers work remotely. We have about 40 remote teams, and I work in mobile backend. We make backend for all our mobile applications. And today I want to tell you how we optimize the code review process in our team. How did we ensure that our requests are easily and quickly approved, but at the same time the quality of the review didn't drop. Code review is mandatory in our team. At least 2 people review the requests. So it made sense for us to optimize it, because code review is fairly a significant part of our work. So how does a code review usually looks like? You have coded something, then submit changes as a pull request and assign a reviewer. The reviewer comes. If they don't like something, they give you a feedback and request changes to fix something. If you agree with them, you make corrections, then send these fixes for a second review. Then if everything is okay, you get an approval and merge happens. It sounds simple, but in reality, the review process can become painful for both of you, for the author of the pull request and the reviewer. One thinks, they will always reject my code, while the other, on the contrary, receives a kilometer-long pull request with thousands of lines of changes. And often the reviewer is confused, because it will take a lot of time to read the code completely to understand these changes. And here we have a dilemma. Either sit and dive into the code, while still chances high that the reviewer will surely miss something. Or quickly look through the changes, approve, and that's it. Or you can also simply reject, saying that I don't understand anything, redo. So it turns out that there is an obvious rule. The larger the pull request is, the less benefit it will be from its review. A lot of time will be spent, but there will be a minimum of real benefit. How to avoid such situations, how to make pull requests easier and more understandable for the reviewer, and is the problem only in the number of lines in the request, or in something else, or maybe there are more fundamental reasons? Let's imagine that you have a task to implement a new feature in a project. However, the pull request we are working on may contain different categories of changes. What could be there? Of course, there will be some new code in it, because you have a task to add a new code. But while working on a new feature, you may notice that some code needs to be refactored beforehand. Or with this new functionality, duplication appears, and you discovered some new abstraction that you didn't notice before. So the pull request may also contain some refactoring. Or you suddenly found that the code you are using has a bug inside, and you decide to fix it right here because it actually relates to your task. So let's think about what the final pull request could look like. I think that when the reviewer sees such a request, they will be very upset. Here we have 3,000 lines of changes in 36 files, and all of this is collected in one commit. Beautiful. Here the reviewer has only 2 options. Either approve immediately or immediately reject. There is no point in trying to review to understand something here. It's just a waste of time. And all of this because the author of the pull request mixed in a bunch of different categories of changes. What are these categories? Let's make a little categorization of what categories of changes one can find in a regular pull request. The first is features or functional changes when we add new behavior to the system or change an existing one. Structural refactoring is what usually we mean by refactoring. These are changes in classes, interfaces, methods, some kind of movements between classes. Simple refactoring here, I mean changes that can be made with your IDE, just in several keystrokes. For example, extracting variables, method, constants, simplifying conditions. Here we don't change the structure of a system. We improve readability of the code. Renaming and moving classes. Such changes when, while working on feature, we decide to reorganize namespaces, move classes, or rename something. Removal of unused code. I think it's obvious, and code style formatting. For example, somewhere we decided to switch to auto-wiring, somewhere we removed unnecessary comments or doc blocks, stuff like that. So here we have 6 main categories of changes that can be found in a pull request. It's very important to understand here that each of these categories is reviewed in a different way, and the reviewer will focus on different things when considering them. We can say that each category involves its own review strategy. Features, the reviewer will evaluate the fulfillment of business requirements and the design of the final solution. During the review, we pay attention to whether the problem has been solved, whether the feature has been completed, and how well it is. Whether a successful solution has been chosen or it can be somehow improved. Structural refactoring. Here, during the review, we will check for backward compatibility. Nothing that will break in general, and that the code has become better, but the behavior of the system hasn't changed. Simple refactoring. Again, the difference with the previous point is that all these changes can be made automatically through the IDE. In the simple refactoring, we just improve the readability of the code. There are no structural changes here. If we extract, for example, a private method or rename a variable, then the structure of the system will not change. Once again, here we are improving readability. Renaming and moving classes. Obviously, the reviewer checks that the namespace structure has become better and the classes are better named. Removing unused code, we check backward compatibility, but this category differs a bit from the structural refactoring because this code has been removed. We cannot just open IDE and click through its usages. And code style and formatting, nothing special for the reviewer. Actually, such things should be checked automatically with the linter, for example. Now we see that different categories of changes require different review approaches. Somewhere you just need to see if the readability of the code has been improved, and somewhere you need to dive into the problem, evaluate the design of the system. Therefore, the amount of time and effort spent on the review will differ. Features and functional changes usually take the most time to review, because here we have changes in the domain logic. This is where we share information about the domain. The reviewer looks to see if the business problem is solved, checks the proposed solution. Structural refactoring consumes much less time than features, but there can be suggestions and disagreements how exactly the code should be organized. And you can see that all other categories are in 99% instant improve and merge. Simple refactoring, the code is more readable, approve. The class has been moved to a better namespace, approve. Unused code was removed, of course approve. And code style and formatting, yes, we approve. So it turns out that if we want to make the reviewer's life easier, then it would be better to send these changes from different categories in different pull requests. But okay, what happens if we mix several categories in one pull request? Then it will be difficult for the reviewer to keep several strategies in mind at the same time. And most likely the reviewer will spend more time on the pull request than it is necessary. Besides, because of this, they may still miss something. Moreover, if the pull request contains different kinds of categories of changes, then for any fix in any category, the reviewer will have to revise all categories again. For example, you have mixed structural refactoring and feature. Even if the refactoring is done well, but there is a problem with the implementation of the functionality, for example, the business requirements hasn't been met, then after all the fixes, the reviewer will have to look at the entire pull request from the very beginning. Both refactoring and feature need to be reviewed again. This way, the reviewer spends more time on the pull request. Instead of, for example, immediately merging a separate pull request with refactoring, the reviewer should review the entire code again. Let us consider what are the biggest pain for the reviewer, the worst mixes of categories in one pull request. Functional changes and any refactoring we have already discussed this case. This mixture forces the reviewer to have several strategies in mind. Even if the refactoring is done well, we will not be able to merge those changes until the feature is approved. Renaming and moving a class and its refactoring. Here we are faced with Git, which doesn't always understand these changes correctly. I mean large scale changes when many lines change. When you refactor a class and then you move it somewhere or rename, Git doesn't think of it as a move. Instead, Git interprets these changes as deleting the first one class and creating another. This can lead to confusion during the review when the author of the code is asked why they wrote this ugly class, while in reality the code was just moved from one place to another. But it is Git and we have to live with this problem, so we have to adapt and make such changes in a separate pull request. And one more pain for the reviewer is a mixture of any mechanical changes and human-made changes. By mechanical changes, I mean any code formatting done by the IDE or some code generation. Often this is a lot of changes that do not correspond to the effort. For example, we apply a new code style and get 3,000 lines of changes. And if we mix these changes with any functional changes or with any refactoring, with any changes made by a person, we will force the reviewer to mentally classify these changes. This is a machine change and I can skip it, or this is change made by a person and I should review it. So the reviewer will spend a lot of extra time checking it. So okay, this was theory. Now let's consider an example where we have a hard to review pull request and we will try to make it easy to review. Imagine that we have some kind of library, a client, and we need to add a method to gracefully close the connection. Wait until all current requests are completed and close the connection. This task is quite simple and, for example, we decide to give it as onboarding to a new developer. And the expected solution looks like this. There are 7 lines of PHP code here. So you're given the task and after a while you receive a notification that you are a reviewer. You naively think to see these 7 lines, but you open the pull request and see this. We have here div with 100 lines, 7 commits, and 4 modified files. So how is that? Well, 100 lines actually not so many, and we didn't reject the request. And try to figure out what is inside, why it has changes in 4 files. We are lucky that the request contains at least 6 commits, and by them we can understand the logic of the author. Okay, we look through the commits and we see that here we have a mix of everything. We have refactoring with a separate with extracting a class. We have moving classes to a new namespace. We have formatting and code style and the feature itself. the problem with such a request is that even if the feature itself is small, we have 7 lines here, and we as a reviewer have no questions about it, then there is still 90-line div left, and one way or another we will have to review it if we want to merge this request. We will have to review what kind of refactoring was there, whether it was successful. Then adding a new namespace and moving several classes to it. We need to see that after these changes, the design of the application got better. And the rest of the div was code style and formatting. And of course, we don't need to review it, but the problem here is that this request mixes machine changes and personal manual changes. We read the code as text, and with such a mixture, it will not work just to open the div on GitHub and read the changes with our eyes. It will be not clear this change was made automatically through IDE or it was made by a person, by the author. So we find that a pull request that seems to solve the simplest problem will be extremely hard to review. How can we fix the situation? How we can make the reviewer's life easier and for the author of the request to ensure that his changes are accepted? The simplest answer is to do only what was needed in the task. The task was to add a new method, we added it, and that's it, sent to the reviewer. But this is not always possible. Sometimes you first need to refactor something, change namespaces, remove duplication, and in such situations, it is better to do separate actions in their own branches and create separate pull requests for each of them. Okay, let's look at our example. We have 7 commits here. The first 2 commits relate to refactoring. First, we extract a class and then move several classes to the new namespace. It would be possible to combine these 2 commits into one pull request, but here, unfortunately, we will encounter Git problem, which detects moving a file with a bunch of changes, not as moving, but as deleting file and creating a new one. Therefore, we make separate pull requests for each refactoring. The first refactoring is extracting the class. Here we have only 2 files and 60-line div. The reviewer only needs to check changes in the design of the system. Did the code get better after this refactoring? And if everything is okay, we approve and merge. The next request is also refactoring. We are moving 2 classes into new namespaces. 3 files are changed, 6 lines. Such a pull request is very easy to review. We are looking at the new namespace. It got better, approve and merge. Then the code style and formatting commits from the original request can be merged into a one pull request. Here we have div with 30 lines, 2 files change, automatically approve and merge. And the next commit finally solves the business problem. We now have a separate pull request with functional changes with a feature. Now, here the reviewer can focus only on that specific task and check the proposed solution. The pull request is small with div of 11 lines, and it is easy to review. Now, instead of having one difficult to review request, we have 4 very simple requests, each of which is based on the previous one. They are easy to review, and by the way, in small requests there are much more chances to get feedback and improve something. Here you can argue that yes, all of this of course sounds good and interesting, but it looks disconnected from the real life, right? When we sit down to implement some new feature, we rarely know beforehand that here we'll have refactoring, here we will move classes, and then once the existing code is clean and nice, we will code something new. It's unlikely that we will create branches and then make such ideal pull requests before writing the code. So what should the workflow look like? And when should we branch our changes and form this pull request structure? I proceed from the fact that in our daily work we make atomic commits, each of which solves some of its own separate subtasks within the one our big task, a feature we are working on. At first we didn't care about the branches, pull requests, we just make atomic commits for each change. Then we have finished with the task, we look after the fact at the resulting commit history. We look at them and try to clean them, to put them in order. I mean, if, for example, somewhere we cleaned up the code, dog blocks or, I don't know, some small improvements, they can be moved up in the commit history. And this can be made with interactive rebase. Now, once we cleaned up the history, we need to sell our changes to reviewer. So it is better to optimize and reduce the number of changes in each request. When the reviewer comes to our request, it will be easy for them to review and thus to approve. Why should we care about the reviewer? Why should we make their lives easier? Because we don't want to endlessly suffer from merge conflicts. When our colleagues' pull requests will be much nicer and more enjoyable for review, they will be merged, but our several thousand lines of code pull requests will stay in review for weeks while we pull new commits and endlessly merge them into the request. So we look at our chain of commits, we see that on some of them we can create a branch with the changes from one category, and that's it. Create a new branch on this commit, push it, and make a separate pull request. In Git, it will look like this. We start from one feature branch, and then we end with several branches, each of which is a continuation of the previous one, and each contains changes only from one category. So the main toolkit here with which you can rewrite the history of commits is interactive rebase. So to summarize everything, one rule of thumb can be drawn. Don't create huge pull requests with mixed categories. The larger the pull request is, the more difficult it is for the reviewer to understand proposed changes. Most likely, a huge pull request with hundreds of lines of code will be just rejected. Instead, it is better and more efficient to break such pull requests into small logical parts. If, for example, everything is okay with refactoring, but functional changes require fixes, then the refactoring can be safely merged so that you and the reviewer can focus on the feature without looking through the entire code from the very beginning. And the rest of the team can also pull an already merged refactoring. The code has already become better. And finally, a checklist that we use in our team. Before creating a pull request, optimize your code for reading. Code is read much more often than it is written. Describe the proposed changes to provide the necessary context for understanding them. Your code, your div, is some kind of content. That's what you changed. And the request description is the context. That's why you made these changes. Code doesn't just exist on its own, yes, in vacuum. It solves the problem. And the description of the request should reflect the problem that your pull request is solving. And always check your code before creating a pull request. And do it like, you know, it's someone else's code. Sometimes it helps you to find something you have missed. This will reduce the likelihood of your pull request being rejected and this number of fixes and reviews. And maybe right now you think that, you know, I'm a crazy guy, that I'm offering you something weird. Splitting requests into different categories, making the reviewers' life easier. You may say that all of this should be relevant for open source, I don't know, for contributing to some framework. But at my work, we make pull requests with thousands of lines and no one complains. We have tasks, we have deadlines, and we write code without bugs. Why do I need all of this? Okay, if at your job it is normal for you to create pull requests with thousands of lines of code, then most likely the review looks like this. It's just formal and useless. You can safely throw it away from your workflow and actually nothing will change. But let's think a little about why do we do code reviews? Why, when the code is already written and the task actually is solved, we still spend our time and time of our colleagues to read the code? And the first thing that comes to my mind is finding bugs. Like we go through every line of code and try to find bug in it. Not really, that's not what makes the code review useful and interesting. And focusing on bugs during code review is not a good strategy. The point here is that in the review we only see some small snippets of code. Here we can catch, I don't know, syntactic things or possible calls of methods on null, but we hardly find some serious bugs that will occur only when our system works as a whole. So why do we need code review? I think that code reviews are used for several purposes, which are more important than finding bugs. The first one is knowledge sharing and search for better solutions. And these points look really more interesting than searching for bugs, because these things improve the team. They increase the skills of the developers, both technical and you also increase knowledge about the domain. We can say that code review is the place where we discuss code with our teammates. Code review is a small chance we have to discuss some specific change in the code. We often communicate and reason in abstractions, but at code review we go down to the implementation and discuss how we are going to apply these abstractions in practice. Here we can share knowledge about the domain in form of code. That for this part of the domain logic we already have a solution, and it sits here. That for such a problem there is a more suitable technical solution, and with such implementation we may face these and these problems. Yes, at code review we may not find some bugs, but we will get better solutions, and the whole team will also grow and evolve due to the fact that we constantly share knowledge. How it looks like? You worked on something, and once you are done, you submit a pull request, and you think that, well, that's great, that's the best I can do. Yes, and in 5 minutes you start receiving notifications from GitHub with comments, review comments to your code. And the first thing you think that, what's wrong here? What they didn't like in this beautiful code? And then you read the comments where, in most cases, everything is clearly described and explained how to make your definitely best solution even better, how it can be more improved. Or maybe your pull request was rejected because it was fundamentally wrong. Sometimes, yes, it happens. Often each of us in the team is usually good at something. The important thing here is that through communication and discussion of the code, we become better. For example, I'm not good at security, unlike my colleague who will point me that I can't pass arguments in this way, that they should be escaped before. And for me, this will be a new knowledge. And we have already improved solution together. And now I know that. Moreover, this knowledge for me is not just some kind of information in a vacuum, but already with an example in a specific task in a specific implementation in this code. And these kind of things, sharing knowledge and finding better solutions, they're very difficult to do in huge pull requests with divs of thousands of lines where all kinds of changes are mixed. As a reviewer, you simply don't want to give any valuable feedback in such pull request. And it's much easier when we have small requests that solves one specific logical problem. For example, we have a pull request with only refactoring changes. Thus, the whole team can sit, discuss the proposed improvements without any distractions. Having a request with a div which refers only to a feature, we can easily discuss this proposed solution, whether it solves the problem, whether it is architecturally successful, and no noise in the form of refactoring, formatting fixes, bug fixes, and so on will distract us. And using this approach with dividing your pull requests into different categories, you not only speed up the code review process, your requests are merged faster, tasks are closed faster, you also improve the quality of the review because the team provides better feedback, which leads to better code and the growth of you as a developer. And in the long run, this splitting requests approach will have its benefits. Here you and the project and the business will only win as a result. Thank you. I'm done.
Thank you so much, Sergey, for the great speech. If there's any questions, we can do a Q&A session.
Yes.
Okay.
No questions.
Okay, thank you so much for the great presentation.
Thank you.
And now we will be welcoming our next speaker within 2 minutes. Hello, Wilson. Feel free to start your speech. And
Right,
welcome
thanks.
to Devfest.
Thanks, Fatima. Hi, everyone. So, yeah, my name is Wilson Mendes. I'm talking actually from Australia. I'm originally Brazilian. Yeah, it's a long story, but yeah, my name is Wilson Mendes. I'm Google Developer Expert in Web Technologies, Microsoft MVP and Developer Technologies. And yeah, that's my handle at the bottom. If you want to talk to me in any social network, that's the same handle everywhere. So, Will Mendes Neto. And today I'll be talking about something really cool, Microfrontends, and more specifically, Microfrontends in Angular apps. Some of the techniques I'll be sharing today can be used in any library or framework for frontend that you like, but the concepts are quite simple or they are available for everyone. So, right? Let's start the party. So yeah, a few things that I'm doing in my free time. One of the things that I published a free book talking about node bots. If you never work with node bots, don't worry. If I work with, don't worry as well. This book is starting from scratch until things and middle term and advanced. So just access the link, decrease the price to 0. If you want to pay me a coffee, it's fine. If not, that's okay. That's the content I'm sharing for the community, and enjoy it. And yeah, that's me. This crazy person is totally me. I'm currently working at a company called Atlassian. So if you either use some of the products that we'll be building for years, such as Jira, Bitbucket, Confluence, Trello, or any other from toolset, yeah, I'll be working that. So I'm working a few improvements from the media platform that we have, and also for the front end, back end, and a bunch of stuff. So yeah, keep have a look, keep tuned. Few things are coming, and we have open positions in case you want to apply. Just ping me after. Also, another thing, since we started pandemic, we know that we are not having more in-person conference or events or meetups, right? That's a real scenario that we're facing right now. It's really cool to share things and try to get more people and share for a community in a better way. Create this YouTube channel called Code Quick Tips. So every week I'm sharing something really cool about web in general. It can be front end, back end, a specific thing for performance or Docker improvements and so on and so forth. So web is a platform and it's really powerful. So feel free to connect that and take a look. Let's start our talk right now. So yeah, starting with the really truth. Sometimes the ugly truth, sometimes something that happens. That is, companies have legacy code in production. Yeah, that's true. If you never realize that, that's your time. And why this happens? Usually when we start a company, when we start a product, we start with an MVP. So we start the idea to validate the product with the minimum valuable as possible. So we don't need to do some over engineering. We don't need to add things that the user won't buy. And usually because of that, we have monolith code. And sometimes with the years, the code base starts to increase and get bigger. And we have a highly coupled code. And sometimes even something happened in the middle of the process. During the years, you have some architectural erosion or some of the decisions, they just goes with the wind, and you have mix of layers, for example. Those are some of the scenarios that I've been facing during those micro front-end migrations, but we have quite a few. We have a bunch of them, actually. And looks like you're playing the game, but in the wrong way. Every time that you feel that you're doing something, it's really painful. You just realize that you're being the dinosaur trying to jump a rope. You're doing that, it's working, but nah, it's not like that. So yeah, web apps are evolving, and also our applications, right? As an example, a few years ago, we started with the micro asterisk way. This came from a simple idea that, like, we have the macro applications like monoliths and massive servers, but we started to realize that something was really painful during this process. Like if you want to add a new feature, you need to cover the whole application, which sometimes it's not that easy. There is a lot of logic, the business logic, or even code that is there for years and people barely know how to change. And to avoid that, you start to think in micro ways, like a puzzle. I have a puzzle with 100 pieces, and you start with the first one, and you start to connect all the pieces until you have the whole puzzle solved. With a micro, it's like that. So more than how easy to upgrade, it's how easy to delete that in case you need. Code is commodity, so sometimes your code will be dead. Another truth, real truth. Think in the micro concepts. We have a lot of pieces, a lot of blocks, like I was mentioned before. You have like boxes with a piece of code. That can be a JavaScript, that can be a Golang, can be a Ruby or Python or any other language that you like. And you have microservices. That's a really, really well done concept. Micro frameworks. And with the idea that like the idea of micro can be for anything. So micro, whatever. And with that, micro frontend as well, because why not? But the first question is, okay, what is micro frontend? There's some misconceptions around the word and around the concept, around the architecture itself. Is that a tool? Maybe I need to use that library with the other library. I'm doing micro frontend. Or even something else. Maybe it's a framework. And there are a few companies like OpenTable who already opened the framework to create micro frontends. So is that a framework that I need to use something really specific or what? No, is that a technique? We're using several architectural patterns to create something that we call as micro frontend. And talking about architecture, since micro frontend is architectural pattern, how to solve those problems, right? We start in the top level and we go to in a top-bottom approach. One of the ideas is create piece by piece and doing step by step, like baby steps. So evolution is a good way to think about it. Or even better, evolutionary architecture, if you want to give names. That will be crucial for your journey. There will be massive help for your team during this process or for your code base if you think about it. Again, everything came for this single phrase. First do it, then do it right, then do it better. There's a concept that came from a few years ago. I think that came from 80s actually. But the idea is the development cycle. It's totally based on the development cycle. First you do, make it work, and make it better. We should always keep improving our code base. As an example, we have this application. We have this amazing website called website.com, and we have this page, right? In this page, we have different pieces of code, different components. And those components, each component is calling a different endpoint. For example, the green box is calling the items endpoint, the yellow box is calling gallery, and the red one is calling the about one. The problem with that is that we are calling 3 different endpoints. The green one was solved with success, the red one was solved with failure, and the yellow one is still waiting, so it's still pending. That means that you need to solve how your component will be handling errors, success, pending, like showing the user that something's loading. For example, you can use a skeleton for that. That's a quite neat approach. But there are different ways. And how can you do to avoid your page to be broken? And it's still on the concept of monolith. So you have a massive code base. They can be a repository, for example. And in your project, you have team 1, 2, and 3. They are all sharing resources. And resources in that case can be your code in the front end, can be your code in the back end, or even your database if you like, or even something else. Can be even more advanced than this. But the idea is when you have the monolith, you're probably sharing resources. That means that any other team can break your page. Any other team can break your page as well. You can break the page for other team, and so on and so forth. So it's really hard to track. Also, with the web evolution and web became now as a platform, shared components is love. totally amazing. So you can go and you can share components that can be used in different devices, can be used in different approaches, and that's amazing. So components, how it should be, plug and play. In this example, when you came back, we have now the items list component, we have the about component, and the gallery component, right? Keep in mind that since the web now is all about components, we also think that we have a page with a component, and this page is using different components as a composition for it to be built, which is amazing. So that means that since you have a component, that can be reused in other places, like a menu, for example, or even a footer or header, or a gallery, if you like. In Angular apps, you can use a concept for containers. Containers will be your masterpiece of code. It can be the master of your page, the main page, and the content which came from somewhere, can be from an API, or it can be for something else, will be added inside the page. So you have a menu, you have the header, you have a footer, and the main content will be added and will be replaced for this layout container. That's an example, and that's really a good one. So you can have different layouts for admin areas, for the website area, or for any other piece that you can have. So that's a really good way to evolve applications. And now that you have different components and pages are components, you have layout containers for it, you can now split the page between teams. So you have the page one, and you have all the tracks. You can really track everything that the page is using. So the page one is using database, is using a database, an API, and a front end. The page two as well. Maybe the page three doesn't need the database because it's doing something else. Maybe just a front end page just to be rendered, and that's all. So in that case, you have all the tracks page by page. And thinking in web architecture right now, in Angular apps, you have this definition. You have components, you have a page, which is a composition of components, and you have the routing, which is a top level definition for which page component will be rendered at that case. For example, when you go to a home for your application, you'll be rendering the home page component, which is composed for a lot of different components. And yeah, everything's a component. That's amazing. That can be used for any place, anywhere, anytime. And other benefits of that is you have a small scope. So since you have a component which is just covering that piece, for example, that component for the page home, it's just covering things that are available at home. You are also defining boundaries with that. So home doesn't need to know about payments. If you work in e-commerce, for example, that's amazing. That's massive. You also don't need to have an object with a lot of different informations like payment information, credit card information, or any other thing that's not related to home. That means that you don't have a lot of listeners to a page. That's also performance. And every component is plug and play. And when I'm talking about plug and play, I'm talking about this. You don't need to worry about. It's a component. You need to plug it and it should work as expected. So yeah, before we were splitting between pages, and now we're splitting also between teams, because why not? So you have this definition shared across teams. So we have a team that will be covering an experience in a homepage, another team which will be covering an experience in payment, and so on and so forth. Or you can have a shared experience between those pages, which will be another team as well. So it's totally up to the company, up to the developers to realize what's the best approach for it. A few of the impacts that we have with this approach is, one, ownership. Each team can do whatever they want based on the priorities and based on the business value that you have with that. For example, if your homepage is getting slower, you don't need to change all the code for your application. You can change the code only for a homepage. Maybe you need to change a language you're using, your API, or maybe you need to change the cache that you're using for your homepage. And you can change only for homepage, not the cache for the whole application. With that, you have flexibility. So it's up to the team to experiment new things. So you can be innovating as much as you want. And you also, when doing this, you don't need to do an all or nothing approach. You can migrate page by page. Why and how? Why? Because you don't need to break the whole application. That's a real scenario. You can break that if you try this all or nothing approach. You're not validating everything that you're doing. So, and go to production like that's not a good approach. So piece by piece and think progressive rollout and all the techniques that can help you to measure the errors, for example, the user conversion between the current version of your application and the new one are quite good. A way to use that, an architecture pattern to use, is called strangle pattern. So think that you have now a tree. Your tree has 5 branches, but one of the branches needs to be cut out. Because if you don't do that, it became to get your tree a really bad infection. So you cut that out and become a new one. A new one will be created by that. So you can go piece by piece, remove the old ones and add the new ones. And more than this, can I use Microfrontends as a PWA application or a web application using React, Angular, Vue, or any other framework library that I want to? Yes, you can. And also you can have those scenarios when during your migration. Keep in mind that Microfrontends, when you started, you're probably doing some migration between technology A, from technology A to technology B. So scenarios like that can happen, but shouldn't be happen that much. That's one thing that I need to discuss before starting migration. Why? Think that now you have your header as a React component, your content as an Angular component, and something in the middle of your header is using jQuery. You have 3 different ways to deal with your DOM. And also, you're loading 3 different frameworks and libraries to solve the same problem. You need to share resources between them, because when you click on something in the menu that's a React component, the Angular component, the Angular region should be updated as well. When you do that, it's a good approach to don't use more than 2 frameworks, the old one that you're trying to remove and the new one that you want to go, and also have a deadline for it. So after 3 months, when we do the whole migration, we'll be killing the old framework and using the new one, so that you don't have any issue with memory leaks or something related. And you don't have that. Think that if you have a lot of different frameworks and you have these memory leaks, at the end, your page will be broken. Eventually, your page will be broken and your users won't be able to use that. Back to the scenario of e-commerce, this is a massive issue. You'll be losing money. Your company will be losing money. You have a lot of headache to solve that in production. And how can you do that? Let's think first. Few concerns with that approach. First one, bundle size. As soon as you try to migrate from technology to another, you probably can see some bundle size increases or decreases because you'll be running with 2 frameworks. How can you solve that? Things that you need to keep in mind. So probably add a bundle size validation during this process is a good one. Also add a bundle size validation that gives your developer a good feedback, not after merge, but before that on the pull requests. So the developer can be notified that the bundle increased 10%, and they need to work on that. Different approaches for that to be solved. One of them is loading your components using async ports. First time to first render can be increased also because your bundle increased. So the browsers are now downloading a file which is even bigger, which would take more time to be rendered. And prefetch content. So even before you go to that page, you already have something loaded, or the DNS can be already connected, which gives you and saves you some time. Other technique that it goes without saying is that one that's showing how to invalidate your file. That's something that's already available in any browser. For example, this talk from Chrome Dev Summit 2017 from Sam Sakon is showing an idea. If you have a home page and you have a specific bundle for that home page, and you're deploying only that new version from the home page, all the other content for the other pages will be cached in your browser. So the browser won't go to your CDN and try to download that again because you have the cache. Or you have something between the CDN, you have pre-cache or something. So something like that. In any case, you won't be charged for that file. And your browser will be loading only what's required, only what's new. If you have a monolith and you have a massive bundle, every time that you do a deployment, you need to download the whole application, which costs for your company and even worse, costs for your users. Now thinking about the routing solution, at top level, even before Angular. So you have two stacks, and the old one and the new one. And you have the routing solution, which will be, during this process, you have your browsers, and your browsers will go to your routing solution. And this routing will check, hey, I migrate only home page. The user is going to the home page. Yes. So I'll send him to the new stack. The user is not going to home page. So I'm sending him to the old one. And with that, you can do some different approaches like progressive rollouts to validate that. Okay, I'm sending 10% of the users for the new homepage, and I'll keep tracking the user conversion or the error rates, and keep improving, keep increasing. 10% goes to 20, go to 30, and so on and so forth until it goes to 100%. And when you have all your users going to the new page, you can kill the old one. And specifically about the route solution, you have different approaches to that. You have a solution on server side and a solution on the client side. For the server side, you can use Nginx, for example, as an open source approach, an open source tool for it. And if you don't have a DevOps team, for example, or if you don't want to care about it, you just want to use it, you want a plug-and-play solution, you can use Akamai. Akamai is really amazing for this type of work. It's a really, really well-done platform. So feel free to use it. There are several ones, but I have some good experience for those two. So those are my suggestions. For client-side routing, we also have single SPA, which is a library just for routing. So you can check, you can do the same definition and check, hey, in this piece in your DOM, I can render only Angular, and all the rest I can render React. So with that, you can have the scenario with the migration scenario when you have two applications that you have a new one. And also, if you want to do this, try to use async import as much as you can. For example, you have this import, use the new page component, and calling that using async import. And when it's solved, you get the new page component and add your experimental feature. Also, make sure that you're tracking when something goes wrong. Here, I'm adding console.log, where you can send that for a platform that you have for logs, for example, so that you can track that. And even better, if something goes wrong because a CDN is failing or something, you can work in advance. As another example of things that you can use feature toggles. So you can turn on and turn off your features. One of the packages that you can use for that is one called feature toggle servers. And the way to use is like that. So moving that code to this one, you can check if the feature flag is turned on. That means that that user can use a new page, for example. You can load the new component. Otherwise, you can keep loading the current one. And yeah, a demo is quite neat. So let me come here and open Visual Code. So when we go to, let me just open application. The name of the application is Nginx Microfrontends, and let me close that. The way that that's working is, okay, you have the page, you have the application, and you have the common components and the layouts. So every page has a layout. For example, if you go to checkout page components, let me close that. If you go to checkout page component, you can see that you have a selector, you have an HTML, and you have the styles for it. Those files will, on bundle time, will be moved to another CDN, so you can parallelize things. You have your CSS, which is here is nothing, and you have a component. This component will be added in another page. So you have pages and you have components. And here, when we go to the checkout page component, that's the content. Let's see how it goes. So what we do, we go to our package.json and we check the scripts, and when we run npm use, right, and we run npm start, it will be opening an application. It will take some time because it will be loading everything. It will check everything that needs, and we're doing the bundle. But during this process, we can see that we have this module. We have this module with everything. So every page is loaded as a module. You can load them asynchronously as well. So you have a lot of benefits on that. And you have the routing. So you can also have feature toggles in your routing as well. And when you go back to the browser, and localhost 42, see the page. So we can go to one page to another page, and we have everything that we need. For the user, this will be transparent, but for us, every page will be a component, which is quite nice. Also, one step further of it, monorepos. Since you have page components and you want to go to different repositories, and you also want to use something master and push forward, that means that every time you change something in your component, you'll be updating the whole application, or all dependencies at least. So you won't be in the weird scenario that updated the header and updating the home, but the other pages are outdated. That can be an issue. That can be even a security issue. So monorepos can solve that. And why monorepos? It's not really well organized. All the toolings are well defined. There is a lot of tasks that I need to worry about. Also, there's a lot of traceability between those packages, and all the dependencies are well available, so well defined, and you can track that across projects. Also, Angular Workspace can be a good solution as well. If you want to use a monorepo application like NX, you can use Angular CLI. It solves all those problems, so we don't need to worry about them. But if you want to move forward using a modern development way, you can also use NX. And the way to run is like that. As soon as you have NX installed, you can run the build only for the affected dependencies for that component. For example, if you update a header, maybe you don't need to change the admin administration area, since you change the header only for the home page or for the website. So you can run on the build for those ones, you can run the tests only for those ones, and you can run the end-to-end tests for those ones. Okay, this can potentially create new problems. At the first time, you probably won't see them, but as soon as your monorepo keeps growing, you see that quite easy. Okay, the main goal for the whole thing, for all the changes that we have in architecture, is make things easy to deploy. Decrease the time that you change something for your local machine and send that to production. That means that we need to keep in mind always release early and release often, right? So you need to have confidence to do that, not just I changed something in my machine, I can send it to production because I can. You need to have all the tooling to give you confidence to do that. A proper test architecture and a proper pipeline will help in that, but can be even more and probably will be even more. You also can have this scenario. With all that, you can still have the scenario monorepo world. How come? If you go to Babel repository, you can see like that. So Babel is using monorepo. And you can see those pull requests in master, and they are broken. How that can happen? To solve that, we have a guy called LandKey. LandKey will be solving a really good problem that we have in Babel and all the repositories, for example. If you go here, you have different pull requests, right? Which got merged in different time. Let's say they open a pull request 3 days ago, another person, another developer open a pull request today. He merged something today, open today and merged today. But my pull request is green. When he merged, it doesn't get updated and didn't have any code conflicts, but it got something broken when it got merged after his. So we have LandKey to solve that. So that LandKey will be the responsible to run all the tests, all the pipeline, and publish a new version. How that works. Think that now you have the master branch, you have a queue that we call LandKey queue, and you have 6 pull requests. All of them are green, but they got merged in different moments. So you have a queue using a first in, first out approach. And at the moment, the first one added in the queue was the number 2, and the second pull request added in the queue was the number 5, and the third one was the number 1. At the time, all of them were green, but when it goes to the queue, they run all the pipeline against master to make sure that everything's working. So you can check that the 2 after merge got okay, the 5 got green, but the 1 after all those 2 changes got merged, and the one when got changed in master, it got broken. That one of the scenarios that happened in Babel, for example. With LandKey, this will be different. As soon as the number 1, the pull request number 1 got broken, it won't be merged. It will be removed, moved back to the pull request, and the developer will get a notification say, hey, something's wrong, please rebase and check those errors. So you can work in advance even before you go to any environment, pre-test, test, pre-production, or even production. This is massive, and your master won't get any chunk, any issue, any trash. Also, a few things that will happen during this process is metrics. And talking about metrics, the first thing that I can tell you is try to add as much metrics as you can. But if you want to add, think always in the user, not in the technology. If you want to track how much your loop is taking to run, you need to check how your user is waiting for 3 seconds to get logged in. And with that, you can have a lot of different information. That is one for APIs, a mix between the API and the front end. So you can have CPU utilization, memory usage. Memory usage is actually a good one because it can avoid memory leaks. So if you got 1.5 gigs or something like that, if you got one of the values that's not good for your application, you can raise an issue. You can raise even a performance degradation in production and work in advance. And yeah, we spoke about rotate solutions and we defined everything for the front end. But what about the back end? Because the front end is still related to the back end, right? What if the API goes down? Or what if the API is still working as expected, but they have optional attributes? Also, we'll talk about Angular, right? So what if your type is not that assertive? Let me give you an example. So you have your API, call it the endpoint number 1, 2, 3, 4, which is returning location. But the type for the API endpoint is like that. So if you go here, you see the location has a question mark, which means that it's optional. So then the payload can have location or not. And if you have it, you use this type. Also listing. Listing can be there or not. And if it is there, should have this type. This is an issue. Because if your component is not ready for this, you can have a scenario when you have location and you have listing, and your component is waiting for both to be there, not optionally be there. That means that your page can be broken. If your component try to load one of those, try to use one of those informations, and they're not there, thinking about it, that's the real image that we see. Or you can receive a call for something that's happening in production. So yeah, a quick recap. First, thinking architecture. Always thinking architecture before move on. Second, start with small steps. Don't try to do all and nothing approach. That probably will give you more headaches than benefits. Third, thinking a migration plan. If you want to move on, you need to have metrics, you need to have a rollout projection, and you need to have proper toolings for it. Fourth, define a routing solution. That can be a good one, independently if you're using a server side, a client side, or a mix of both. And fourth, monorepos can help you. So you have different approaches. You can use Angular Workspace, or you can use NX or any other monorepo technique or a monorepo package that you like. If you want to know more about the demo that I showed you, folks, that's the link. So Nginx Microfrontend pages, that's my GitHub as well. So feel free to fork or just raise an issue, open a pull request, so go crazy with that. So yeah, that was my talk. I hope you folks enjoyed as much as I am. Thanks so much for everything and for being tuned. And yeah, see you folks.
Thank you for great presentation, Wilson. I will put the link to your repository in the comments so everyone can just click the link. Maybe they didn't catch it in the few seconds that you showed it. We have a few moments for the chat. So if anyone have any questions to Wilson, maybe I will start. Did you try to study some microfrontends pages in the wild, in the World Wide Web? And if yes, what is your favorite one? Like the one that inspired you?
The one that, sorry, can you repeat that, please? The first got cut a little bit.
Yeah, did you study other companies' microfrontends? And did any one of them inspire you?
Right. So I saw a few of them. One of the Denza, that's a company from Europe. Also, we are doing that in Atlassian and few of the projects that we have, like Confluence and Jira. And even before that, there are a few companies here in Australia that have been worked with that we are doing. For example, we have a company here called Domain.com, which is using this approach. I really love the idea to have the Kotlin, the pages from the monolith, and have things working independently. That means you have your proper pipeline and your team has all the ownership that can go. Of course, there are some drawbacks on it, but the benefits are huge. One of the main benefits that I can see is that you don't have any blockers, and also your deployment won't be a big deal like it was before when you were talking about monolith. You don't need to have a day to do it, or you have all the confidences, you know all the boundaries for that page exactly. So you can add the test for it, you can have all the test architecture for it, all the toolings that are provided, and really
That That is game changing. Okay, so thank you, Wilson. We'll have the next speaker, but I really enjoy your presentation.
Thank you very much. See you next year. Yeah, cut me in. And just one last point. Thanks everyone who are here. Thanks UGC Poland. And if you want to know more or get the links, I'll also be sharing them on my Twitter @WilmedZnito. And yeah, thanks everyone.
Hello, Dmitry. Now we'll be watching your presentation about server as function with HTTP 4K. Thank you.
Thank you. So yeah, I'm Dmitry, and this is, as you can guess, presentation about HTTP 4K and server as a function. To just clarify things, I can start with mentioning this paper where the whole idea of server as a function comes from, as far as I know. And this was written by Marius Eriksson at Twitter, and it was like basically describing what they had in Scala. I'll show a bit about it later. So let's just move on. So what they did based on this paper is basically this like framework or library Finagle. And using similar ideas, some guys wrote it. Finagle is open source. And using similar ideas, like some guys created, Ivan and David created HTTP4K for Kotlin, but simplifying some of the ideas. We'll see more details later. HTTP4K is also open source. It's on GitHub. If you look at the history on GitHub, you can see that it was under development since 2017 by David Denton and Ivan Sanchez. And I'm not going to go into many more slides. I'd rather show actual kind of code. And to explore the whole idea of server as a function, HTTP4K, I'll use as an example the game of tic-tac-toe. So it will be, to be clear, it will be just like two players playing on the same screen, basically. So it's nothing sophisticated. And it will be this kind of architecture, relatively simple. So there will be like two, like front end and back end. So front end receives a GET request from a browser, sends a GET or POST to backend, backend sends back some JSON, and frontend sends the HTML back to the browser. So that's like the whole idea. And obviously I'll use IntelliJ and Kotlin for that. And yeah, but let's just move on to actual coding. So this is IntelliJ idea, so this is hello world, so let's just run it. Yeah, so this works. And to illustrate the core concept in HTTP4K and what it means to be server as a function, there is a thing of HTTP handler. In HTTP4K, it's a type alias, but basically what it means is that it receives a request, which is a immutable object, and it sends back a response. So that's the minimal kind of hello world we can write. So let's say if we have body, we say hello world. Maybe this kind of world. So that's how you do a minimal hello world in HTTP4K. Obviously, this is just a function in Kotlin. If we go to the source code, this is literally just a function. So it doesn't do anything. So what we need to do, we need to plug it into some server. And HTTP4K doesn't invent the wheel, so it just integrates with lots of different Java servers. So in this case, we can do Apache server, and then we can start the thing. So that's now an actual hello world. So if we run it, it starts up. So basically, HTTP4K plugs in this Lambda closure into Apache server and runs it. So and there is a thread which is keeps running in the background. That's why the process doesn't stop. So now we should be able to do curl, basically, to do something like HTTP localhost 1234. And we can see that's our outgoing request from curl, and that's what we get back, and we get back hello world. So that's the hello world server. This is all kind of fine, but it would be nice to write the same client in Kotlin as well. And to do this, what we can do define HTTP client. And that's another core concept, is that client and server, they have exactly the same interface. So HTTP client is also HTTP handler. And it kind of makes sense because HTTP client also gets a request and sends back a response. So in this case, we can do the same HTTP localhost. And let's have an import. This is going to be a response. So we can specify type explicitly. So that's a response. And if we print it, we should get back hello world again. Now from Kotlin. And so we get this kind of hello world. So the important thing here is that this handler is the same type. Request is the same type in both cases, and response is also the same type. So that's like one of the most important ideas, that client and server, they're kind of the same, so they're interchangeable. So if you know design patterns, in a way, client is a proxy design pattern for the server. That's why they're the same thing. So yeah, this is how you can do hello world from HTTP. So this is slightly silly example, because if we do foo, it's still going to work because our server like always says hello world. Maybe we want to define some kind of routine, and in HTTP you can do it with this function called routes. And then we can say, let's say hello, and then there is a small DSL bind get to, and then I just pasted the same thing. So if I run this now, it should be 404 because foo is not handled by this server. So now we get 404. So if I fix it to hello, like that, that's going to work. Yeah. So another simple thing we can try, instead of hello world, maybe we specify name like Bob. And here we'll make it more generic. Let's say there will be a name. So it will be name, and here we can extract queries from the request. So request is an immutable object inside HTTP. So if I jump to the source code, that's what it is. It has like setters, getters, but setters, they don't modify the object. So here we can extract name, and now we should see hello Bob. So yeah, so this works. And there is an obvious thing. What if we forget to specify name, right? So what's going to happen here? And the answer is that this is a nullable string. So in Kotlin, this is a nullable string, and it will be just null. And one thing let's say we want it to be required field, so we can say name is required, and this error is thrown an exception in Kotlin. If we run it, like in our code, we're not catching any exceptions at all. And so, but we still kind of get a response 500. Server didn't blow up completely. And what happens is that Apache server catches our exception for us and so on. So we could handle it ourselves. And for this, there is it would be nice just to handle our own errors and not like show stack traces to end users, basically. So for this, there is another, like the second important concept of filters as server is a function. So there is a thing called filter, and we can define filter like that. Filter is just a function which, if we go to source code, it takes handler and returns another handler. So it's like a wrap around handlers. So I can say there is a handler and we just return it. So that's the simplest filter, it doesn't do anything. Then we can have a wrapper handler, which is going to be, again, just a handler, and it takes a request and it calls the original handler with that request. And then we return wrapper handler. So still it's like not much going on. This is not useful really, but so we can now do a hatch around our handler, and if it fails, we can return response, let's say with some different status, like I'm a teapot, right? And that's how the filter works. So now we can plug it in into our server. We can say our routes with filter, and just run this, and we should we should get this now because we're not specifying name. The error is thrown, right? And we catch in here and returning the status. So there are more built-in filters. It's not only, so for example, like one useful thing for development, built-in filters in HTTP in the core module. This is print request and response. And then we can chain filters, but in reality it's just composition. So it's like the type of this, so if we call this filters, the type is still just singular filter. It's not a list of filters, it's just a function composing things. So this also should be called probably catch all. We probably should use filters here, like plural filters. And in terms of catch all, there is also built-in one, but it's easy to write your own, as you have seen. So we don't necessarily need all of that. If I run this now, we should see output from print request and response. So we can see this is our get. this is our 500, and then at the end we kind of print it again in this println. So yeah. And we now have catch-all, so it does print stack traces by default, but it doesn't matter. So also to mention the difference compared to Finagle, so in Finagle, it's not called, it's way more generic, so there is no HTTP handler. It's called service. So if we do type ls, let's say Finagle service, and it takes a request and reply type arguments. So it doesn't have to be just HTTP, and it takes, it's also a kind of function which takes a request and returns a future of reply. And to be clear, this is not Java features, they have their own. And like that's the main difference. An HTTP handler is literally taking request, return, response. Here it's a future, so it's like more flexible, but on the other hand, it will complicate all your code basically, even if you don't care about the synchronicity and so on. And then there is Finagle filter, which is configured kind of similar. So it takes a request, but also takes a service and returns a future of response. So again, it's more complicated type signature. So the idea is that you get a request, you modify it somehow, then you pass it into the service, and then service gives you a response, and then you maybe modify response, and then you return a future of response, reply. So yeah, you can see it's a bit more complicated. So, but that's the difference. So in HTTP we have seen filter is just handler returning handler. So again, simpler, no futures, and so on. So that's like extended hello world in HTTP4K. So now let's move on to actual tic-tac-toe thing. So what we need, so what we can do, what server as a function really means is that these roots thing we can extract into a function called new backend. And this is really our server in this function. Then I'll inline a few things. So I'll inline this, maybe format a bit, filters like that. And so we basically we create a new backend with these filters. We plug it into the server, and we started. Don't need a client for now. So that's going to be our backend for the server. And like one of the interesting aspects of HTTP is that it's super easy to test because of the simplicity of whole concept. So what we can do, we can write backend tests and say test get game state. And here we literally just create a function, and that's our backend. So we don't need special infrastructure, no special magic, nothing. It's just a function. So we can call it here and can do get, and let's say we want something like a game. So like we're test driving it now, basically. I think IntelliJ is wrong when highlights it. So, and then we can write a function or something like expect OK. And this will be our test function, which says the status of the response, it's an extension function, should equal OK. Status OK, and then we return this, which is our response. So basically we get here back a response. And then we want something like we can get body of the response, and we can assert it would be like game JSON. Like that's not what we expect, but just for now, I'll do it this way. So we can see a failing assertion. So yeah, it fails because we don't handle the game root at all. So what we want here is game. Then we don't really care about like the name request. So I'll just drop this. So it will be super simple. And here we want some JSON. And here we come into the point where like we should define game. So I'll define it as a data class with a bunch of moves, or list of moves, where move will be also a data class containing X and Y. And the player who made the move. The player. And player is going to be an enum. It can be X, Y, X or 0. O. So that's the whole idea of the game. By default, it's going to be empty list. And we kind of want to return game here. So let's just do minimal thing and do toString and see how that fails. So now we kind of expect it not to equal to the JSON. So yeah, that's what we get. So we expected some JSON, but got toString of the games. And at this point, like what you would probably normally do, you can write a function to JSON, and you convert your domain object, which is the game, into JSON. yeah, it's totally doable, but in HTTP4K there is like a slightly better way. Well, like there is a different way to do it using lenses, which is a concept of functional programming. So we can define game lens as body, and then we can do auto game to, and we need a special import over there. So what's going on here is that we importing this extension function from package Jackson, and it will know how through reflection how to automatically convert game into Jackson and back. So lens is basically like a getter and setter, an object which can do getting and setting. So it has two functions, extract and inject. There's like two essential things. What we want now is to inject. So we want to inject a value of game, and that's just creating a new game for simplicity, kind of to not overcomplicate things. And then we injecting game into response, and these are going to return us a response. So if I run this is like the whole setting things into response. So now what we get this kind of JSON back, which makes sense. So it's like an empty array of moves. If I paste it in, that should pass now. So yeah, the test works now. So that's good. So the next step, maybe you could write one more test to say, let's say maybe players take turns on each move. So it will be like you click on the screen, but and the game decides like, is it X or so players take turns on each move. And at the end, yeah, let's maybe have a couple calls to, let's say, game. They're going to be maybe post. And it will be something like that. X will be 0, and they will be passed as a parameters. Maybe it's not ideal, but for simplicity still. It could be probably inside of body, and could be JSON as a coordinate object or something, but I'll go for like the simple thing for now. And then so we make two moves, we expect OK responses, and then we get the game, and we assert again some game JSON, which shouldn't be an empty game anymore. So that's like the next assertion, and that's how like we're test driving the implementation. So now it says method not allowed on the first move, and the reason is that we have get bound to game, but we need a separate thing for post. It's a different method. So here, what we want, basically, we want response. Well, let's leave it as OK. And what we want is to get those X and Y out of request. And we can do something what we did before, like with the name, for example, doing like X and then do it to int and so on. But we can use lens again, for example, just to show lenses again. So this time it will be coming from query. We can say it's int and it's required, and it's called X, and the same thing for Y. And here we can go like X lens, and instead of inject, now we extract from request, and we get back literally what we want. So if we specify type explicitly, it's going to be int, no question mark. If there is no int, the lens will throw an exception. So that's how we can extract X and Y here. And then what we want, so, well, we can run this in the first place and to see if we get to the next failure, that would be the right thing to do. So yeah, now we moved on to this failure, so we want back some moves. So what we want, basically, we want to update game. In the first place, this should probably be, well, let's call this game. Should probably be here. And at this point, this whole function becomes kind of an object, because if you imagine this is a field of an object, and that's the game, and what we want is probably to update the game, and we do something like that. So make move will be a function on the game which will return a new instance of the game. And so this way game will like keep being immutable. So something like that. That's the idea. And well, if we run this, it's gonna blow up because there is no to do. And at this point, yeah, so it throws an exception here. And at this point it becomes kind of interesting, because what we've been doing so far, we were kind of test driving the whole implementation from backend tests. But now it's like it's up to how to implement game and moves. So in real world, like I would suggest to write game tests, so test the main objects on their own, basically, and do some kind of implementation here. Yeah, so write more tests without HTTP layer. But because this is not the point, I'm not going to do it. I'll just like type the implementation of the game, basically. So what we want a new game on each move, and we want basically the same moves plus a new move at X and Y, and we want to decide who's the next player, like the game figures out who's the next player. And to do this, we can say if moves. Basically, we look at the last move, and if the last move player is not X, player X, then it was null or it was player O, and so we are switching. So the next one is player X if it wasn't. Otherwise, it's player O, and that's it. Maybe we can have imports. And also, we might want for later to have a winner, which will be a player or null. So null means there is no winner right now. And we can define this function. So basically, on construction of the game, this function will figure out if there is a winner. And to do that, what we can do, we can go through all players, so values, and find player. And then we can check if moves contain, so it's like we can check the first row. If there was like the same player made moves on the first row, to do this, we can go from 0 to 2 and generate moves. So it will be the first row, so X will be the thing we're iterating over, and 0 is the first line, and this is the current player. So this is the first row we're checking, and then obviously we have 2 more rows. It's 3 by 3. And then we have, well, let's do this way. Then we have columns, so we just swap X and Y. And then we will have one diagonal and the other one. Hopefully that should work. And then if there is a winner, so if it's not null, then we don't make a move. So that's like the whole return this. So that's the whole logic of the game. Quite sophisticated, but I mean, maybe not. We can also do this thing. Oh, let me undo that. It also might be good to pass game as an argument. So this function is configurable initial game. So I'll run the test now, and we should hopefully get some JSON out after making moves. Like, interestingly enough, now if we look at the test, they both fail, and this one is failing because we added one more field. So in this case, we could probably just like copy paste the new JSON into here. But in this case, the JSON is way bigger, so we have the option of like copy pasting it in. Or there is like another thing we could do. We could use game lengths again. So we could say maybe extract from response to the game, and we're literally gonna get back a game object. So we'll have moves, list of, and all the moves, the 2 moves that we made 0, 1 was player X. So this might be a better option. And the same thing we can do here. So we can say game lengths, and instead of extract, you can use invoke function. And in Kotlin, there is operator overloading. So instead of invoke, we can just drop the whole thing to this, and that should be equal to an empty game. So the test should pass now. Yeah, so that's, I guess, like the minimal version of the backend. And now maybe good time to move on to front end and to have something actually visual working. I'll move this a bit down there. So what we have now, we have a backend, and we want a front end, something like similar. So I'll copy paste this, say front end. It will also be a function which like returns just an HTTP handler. Probably also will have something similar to that. Paste this for now. And instead of game, it's, let's say, on getting the just root, it will return some HTML. So for now, I'll just say body, some HTML. And now the interesting question is how we're gonna like actually plug it in. Like in real world, this would be in a different jar file, but for simplicity, let's then start them in the same process. And so the interesting thing is that frontend needs to talk to backend. So we could literally just extract this into variable and pass it directly, but like it should talk, like in real world, it would talk over the network. So we should define backend client here. And as previously, we can use like HTTP, and we can then pass backend clients directly into the front end. Very specific type signature, and this HTTP is fine. And then, yeah, we can do something like that, just basically server on a different port. And then maybe it's nice to println started on HTTP 8080. That's going to be a front end. So the only thing is that this backend, it needs to know about the actual like URL of the backend, unless we want to like hard code it some. So what we can do, we can use this filter, set base URI from, and we specify URL, and then we kind of wrap our client with this filter, and this filter will always add a specific like base URI to all of our requests. So it will be HTTP localhost 1234. So that's like backend base URL. All right. So that's like roughly how things are going to be set up. So this was kind of just plugging things together. So let's write some front-end tests and have something similar like get game state. So what we can do now, because it's all a function again, we can just create front end, and now we have choice. We can make front end talk via HTTP like network, or we can just directly create new backend literally with an empty game. And this is how you can make everything really configurable, because everything is a function, so it's all easy to do. So basically, that's why the same signature for client and server is useful, because now we like interchangeably can replace, is it network or is it a memory interaction between front end and back end. What we want here, we just want to get this, and we expect OK, and then we get back a response again. And this time I'll use something slightly different for asserting on the response content. So there is this annotation for JUnit, which allows you to add additional things like extensions, and we can do approval test, which is part of HTTP4K testing module. So this approval test thing extension, what it does is that now in test functions we can add additional argument approver, and the approver can say like with approver you can do approving messages. So I'll show in a second how it works exactly. For approval testing, it's also known like it didn't run the front end. It's also known as snapshot testing, golden master, but I think approval is the best name for it. So now this bit worked because we implemented it over here. So this route works, but it returns some HTML. Now the approval is failing, and what it says, no approved content found. What it means is that it created the file in resources, which is named after the test class and test function, and it has extension .actual. If we look at it, it's basically what we returned, and that's the actual output. And we can rename this file to approved, and this means we approve this output, so the current output is correct, and that will make the test pass now. So yeah, now the test pass, and that's the idea of approval tests. So now if we modify our implementation of the front end, it will now fail, because it will say, well, I don't know how to, it doesn't match what I expect, right? So now what we want in the front end is maybe some template rendering. So to be clear, also, you don't have to do front end in HTTP. You can do front end in whatever you use, like Node with TypeScript, right? But just I'm showing because you can. So that's used for rendering. There is a handlebars integration. Handle templates. And there is this one. So I'll use src test because everything is in test for simplicity. And that will be HTML renderer. And what we want here, we want to use HTML renderer to, that's just to invoke game view. We will have an object which represents how game is viewed in HTML, and it has to extend this marker interface view model. And what we need here, we need to create basically a file called game view HBS. This HBS stands for handlebar, and I'll cheat a little bit. I'll just paste this here, and let's say something hello. So now, hopefully, when I run this, we will call renderer. It will, by the name of this class, it will find this render, and it will render HTML. So now the approval test is failing again. It will look like approvals is failing because it's not what we expected. So we have two files again. If we diff them, it says this is what it was actual. That makes sense, and this is what it was approved. And it's like, okay, this is fine. We can basically paste it into approved and delete actual, and this will make the test pass. Also, like at this point, it might be worth trying to like run in the actual thing because we never really looked at it in the real world. If it's working, it's all been kind of just in tests. Maybe we should do that. Local host 8080. Okay, this works. Minimal front end. And the next thing we might want to do in the front end cell test passing is do something again similar to how players move. And to do that, we might have something similar to the backend really. So we can have front end doing maybe 2 gets. It's also not ideal to have a get, but it will be simpler for now. And I also use paths. I don't have to do that, but just to show some functionality, basically. And then we do the same thing of approving front end. So very similar to how we tested backend. We just do 2 moves in the front end like this. We don't have these endpoints yet. And then we check the approved content for the state of the game. From this now, it should fail because we don't even have this game endpoint at all. So it's like it says it's 404. So this should be easy. We have game, and to extract X and Y from the path, there is this kind of syntax HTTP supports. Like you don't have to use it really, but just showing that there are different ways to get things from the request. And here we can say path X, and this is going to be X. We don't really like, well, I won't check that it's an int or not. Yeah, and then what we want to pass this to the backend. So we want to call backend, and for backend we want to post it to game. And it was like X equals X and Y or Y. That's the backend move we make, and that, so it's essentially just calling this function here. Right? So we post into there, and then we want to return something to render for the browser. So we want to do something like that, and we could like extract it into function and call it directly, or we could use this like more HTTP way to say see other and say header location, and browser will automatically redirect to this to the root. So now let's see how test works. So now the problem we get is that our client in the test doesn't follow redirects, and to do that, so it says like 303 result means see other. So it didn't really follow redirect. So to do that, we can wrap our clients in this filter, which is filter which lets it follow redirects. So now we should get an actual output here. And again, so there is still no approved content. What we can do is just run this command and approve whatever content we have. The test will pass, and we can check what we approved. So, well, we approved this thing, so I probably should render something more meaningful right now. And also I'll do it like relatively quickly. So what we want to render, we want an actual game. So the thing we didn't do here is that the game view should come from the backend as well. So it's like if we do backend and we do get, we want to get a game from here. And it will be a JSON, but luckily we have a length, so we can just extract it and we get back a game. That's really convenient. So it's an actual game object, and we can just use it here to maybe convert game to view. That we can create an extension function which will return a game view. Game view should probably have a visual thing, something like rows. That's like one way to do it. So it will be rows, and then there will be a cell view. It should be data class, and that should be doing it in the wrong place. So in the game view, we probably want something like rows. Then we want a winner as a string, the winner, and then we also want a cell view, which will be kind of similar with X and Y. And maybe a player who made the move at this point. That's the idea, and if we do rows here, we can do basically just a loop, X and Y. That's X, Y, like nested loops. That here we'll have want to return a cell view with the X and Y and the current player, where the current player is a string or empty thing. So we like, it's not the best way, but we can see moves, find move with its X, which is equals to current X, and Y equals to current Y. Then we get a player name there. We got a player, and for the winner, it will be just the winner on the game with name. That's our view, and obviously we need to update handlebars with something a bit more real. So it will be just to show things side by side. So it'll be inside handlebars. This is just how handlebars work. Inside handlebars, the context will be the game view object. So we iterate over rows, then like that's a nested loop, and then we get to cell view object. So that's why we can check player. We have X and Y for these moves and so on. So if we run this, it should render what we expect, and things should just work, hopefully. So I'll just quickly look at the differences. So this is our initial state, and this is after 2 moves. So we see X and O. I'm not going to prove just because we can, I think, just run things and see if they work. To save time, let's just try if it actually works. Let's refresh. Now that's the game. So if I click here, the thing we didn't implement was so what happened, just clicked and it went to the move 0-2, and I think we didn't implement the bit. I'll close this. Didn't implement the moves. So this is supposed to be move, not game. That was the wrong thing. And I guess that's an example where if you don't test it via HTML, things can go wrong. So the problem was that template had a different route that's like in tests and the front end. So I'll go back to what it was. Oh yeah, so new game. So if I move, it's going to be X and O, something like that. So X wins now, and if I click, it doesn't move anymore. Like it's obviously just a toy example, because to start a new game, you need to restart the server. So this is definitely work in progress. Maybe let's try and make O win this time. So yeah, O wins. And obviously there is also no message if it's a draw and so on, but I guess it like gives an idea of how things work in HTTP. So just to give a quick overview of what we had. So we basically had backend and front end. Front end was as a function with these kind of 2 endpoints. Then there was this kind of view of the game in HTML, like objects back in it. Then we had backend, which also had just 2 endpoints to get and update the game. It had a bunch of lenses, which were kind of reused between backend and frontend, and then our domain classes. So ideally, like, we shouldn't be writing obviously in one file. It should be split in, at least in 3, like backend, frontend, domain. And we had a very similar thing in tests. So if I collapse everything, we were like frontend tests, backend tests, and game tests. And they also like had quite a few similarities. Like, I did this kind of on purpose. So yeah, so that's what we did. So going back to actual slides, so what I showed is basically just the concept. In HTTPK, there is way more stuff in a sense that there are more other modules with integrations. Like, there are more filters even in core module. There are integration with more HTML clients. There are integrations with more servers, and integration with other libraries, other template engines, and so on. Also, there is, like, as you've seen, support for approval tests. This whole like design makes it easy to write contract tests for external services, write fakes, do record replay becomes really easy, and there is support for that. You can also do chaos testing and so on. So yeah, there is way more stuff, and there are more modules. I mostly was showing just the core module. Also to mention, HTTPK is minimal. It's like core module has no external dependencies pretty much, except for Kotlin. So if you remember anything from this talk, that please make sure this is the thing, that client and server can have the same type signature, it's the same interface, and it makes lots of things much, much easier. That's the whole idea about like server as a function. My opinion. So what I showed is the HTTP handler takes a mutable request, returns a mutable response, and there is a filter wrapped around it. That's pretty much all. So as a design decision, keep it simple, test everything, prefer libraries over frameworks. And as the next things you can do, you can watch presentation by David and Ivan Kotlin Conf. If you just search on YouTube, they have this presentation, more recent one on YouTube. You can obviously just look at the website, right? It's open source. Look at the source code. There are examples. And on Kotlin links, like there is HTTPK channel. So people are very friendly and helpful there. And everything I showed is on this URL. You can find all the links. So this is it. Thank you for watching.
Thank you for a great speech. And here we go to the next speaker. Thank you very much, Dmitry.
Yeah, thank you. Thank you.
Hello. Here's our next speaker. Please take over from now.
Can I go?
Yes, you can go.
Awesome. Thank you so much for the opportunity. Okay, good stuff. Let's see, share my screen. Good stuff. We've got, what is it now? So 27, how much time do I have?
40 minutes.
40 minutes. Oh, goodness. Okay, so that's 7 after then. Okay, we can do this. We got this. Okay, well, my friends, we are here. I appreciate you all being here. Obviously, very little time, so much to do. I appreciate your time. I appreciate you being here. What we're going to do is we're going to talk about Kotlin, obviously, and we don't have a lot of time. So I always show people this slide where they can find information about, first and foremost, who I am and where they can find me, and where you can find the code that you can follow along at your own leisure for your own reference, for your own edification. So go there, github.com, Josh Long, Beautiful-Kotlin. You'll find everything you need there. A little bit about myself. My name is Josh Long. I work on the Spring team. I'm a developer advocate on the Spring team. I'm a Kotlin GDE and a Java champion. And I'm on the Twitter. So if you should have questions, when ineluctably you have questions, don't hesitate to reach out to me. I'm on Twitter. My direct messages are, of course, wide open. And I am on email, so you can send me an email, whatever you like, for correspondence there. I work on the Spring team. I did some videos. I did a book called Cloud Native Java. I do a podcast every Friday called A Beautiful Podcast. I have a blog every Tuesday called This Week in Spring. I do a screencast every Wednesday called Spring Tips. And I have a new book called Reactive Spring. And so all of that is about me. And what we're going to talk about here, friends, is Kotlin and its application in the ecosystem, right? So what we're going to talk about is all these sort of interesting opportunities that Kotlin affords people like myself who work on the server side. But before we do that, let's just take a brief moment to talk about Kotlin and why I care about it. For me, it's a very interesting language that surprised me. Even though I've been a fan for many years, and even though I've been an actively involved user for many years, its rise surprised me. So in 2016, I think, when was the first Kotlin Conf? I don't know, but when we had the first Kotlin Conf, I think it was 2017, which meant that Hadi from the JetBrains team in 2016 had invited me to come speak at this. Now, I don't know if you know me or have that, or if you've managed to avoid making that mistake. But if you do know me, then you probably know that I travel, or at least I used to. This is, everything is different now. But in the old days, before the virus ravaged the planet, I used to be on planes a lot. And as a part of that, I would take any opportunity I could find to go home. I live in San Francisco in the United States. It's 3:30 in the morning here where I am right now. That's why it's dark outside. And in the United States, I live in San Francisco, and I thought, gosh, I can't wait to go home. So Hadi invited me to come speak at this conference in San Francisco. And I was like, yes, I want to do this. It'll give me a reason to fly home and sleep in my own bed for a few days. And I get to see my friends at this conference. I cannot wait. And I was so excited by this. Okay, so that's 2016. Unbeknownst to me, here comes Google I/O in 2017. And in that event, they announced that they're supporting Kotlin on Android. Huge change, right? Suddenly, there was an official, not an endorsement, but an embrace of this language. And that meant that this little tiny Kotlin Conf conference, which had almost no advertising or anything, was huge, right? More than 1,000 people in San Francisco. First year, very little budget for marketing and everything. Very, very big event. I was like, wow, this is crazy. This is a really big show for something that is, I thought, such a small little community. I was expecting just to be able to hang out with me and some of my friends from the Kotlin community, and that'd be fine. Turns out huge. And of course, that's because of Android. Android has this huge ecosystem, and they were already actively using Kotlin. There's a huge amount of people using Kotlin to build Android applications because it allowed them to write code that was, Java 30, basically, like the far-flung future of Java, while compiling back to Java 7, right, which is insane, right? Really, really interesting dynamic. And of course, it works well. So I like that. And then I started to think, gosh, what is it about this language that makes it so amazing? Because it's not like the syntax is entirely unique unto Kotlin. It's not like other languages don't have similar syntax or they don't have a great deal of that syntax, right? If not all of it, they might have a lot of it, right? So it's not like that isn't the case. And I started to think, what is it about Kotlin that makes it so amazing? And really, for me, it is its flexibility. It's the willingness of the people that work on the language to make it the best experience for every sort of different use case. And so this is when I really started to think about Kotlin beyond my comfort zone, right? I work on the Spring team. Spring is a server-side Java framework. I was super excited by that. I thought there's an opportunity there. Turns out that was not a weird thing to think, right? For me to start wondering about this, because the Kotlin team was actively working to promote all sorts of other applications of the language. And so one that really struck me as somebody who spent a lot of time doing native code before and who worked way too much in C and Objective-C, I was excited by the possibility of using Kotlin native. Now, for those of you who don't know, Kotlin native is a way to write code that compiles against an LLVM-based stack, right? So, downloads. What is this? CD downloads. Yeah. Okay. Sure. Go. And I was just very excited about this. I thought, well, that's really cool. I'm used to using Kotlin in Spring, and the Spring ecosystem has already grown. The Kotlin ecosystem has already grown inside of the Spring ecosystem. It's become very popular. And so I thought, well, this is going to be great. I'll just take advantage of this, and I tried it out. And you know what? I found out it's a really nice language. So for native applications. So to see what I mean, And again, we're not here to talk about native. This is not the thing I'm most qualified to talk about, but I just think it's really amazing that we can do this. So let's learn about Kotlin and let's see what we can do by applying the ideas in Kotlin to various domains, right? I could open up Android Studio. That's a very nice, compelling experience. And you just go to File, New, and create a new project, and it's Kotlin. That's it. It's your default experience out of the box these days for Android is now Kotlin. So I don't think that's a very surprising or interesting thing. I think it's more fun to look at this. But I was wondering, what should I show you? What could we show you besides the Spring stuff to make a point? So let's just start with a very simple program that'll help us introduce some basic syntax. So here we have our function. It's a top-level function. In Kotlin, you have functions. They don't have to be in classes. They're a top-level function, or if they're a function inside of a class, they're called a member function. As a result, we don't have to, there's very low ceremony. So what I want to do is I want to write a function that gives me a list of strings, okay? Now, again, I'm using Kotlin native. So this is not a JVM-based application. And I'm going to read information from a string. So, okay, already I've got kind of a prototype. I've got a thing that I'm going to be trying to compile. And where's my compiler? Come on. Rebuild project. Event log. No, whatever. Okay. Well, anyway, I need a function to read strings. So I'm going to say function read lines, and I'm going to give it a file name, and the name will be a string, and it'll return a list of strings. Okay. So here I've got a problem, and so I want to use a to-do. I could just return an empty list like this, or an empty list of string, right? But what I want to do is I want to, what is going on here? It's very confused. Hold on one second, friends. My ID is not being my friend. And if my ID isn't my friend, then whose friend is it? And let's see. Goodbye. Okay. To new project. Native 2. Native application. 11. Next. Good. Finish. Okay, take 2. This time surely will be better, right? Second time's the charm is, of course, what they don't say. Fingers crossed. This looks more promising. It's building something. It wasn't doing that the first time. You know what the issue is? I just gave this presentation for another GDG event just a couple hours ago. So I think there's a cached file on the file system. Okay, so main.kt, good. So there's my function. And here I'm going to create a function to read lines. So I'll say lines equals read lines, and I'll pass in a string. There we go. So it's saying I don't have this function, and it couldn't possibly know what I want. So it's just giving me the default, and that's fine. Now let's flesh it out and actually make this work. So this is a function that's going to read lines from what? A file system path, right? So I'm going to give it a path here. And of course, in order for that to work, I need to actually come up with a path. So I'll say path equals, and I want to get this. What I want is I want essentially this. I want desktop readings, right? I want my desktop file full of readings. The problem is this doesn't make any sense, right? So I need to actually replace it with my home directory. And so I need a variable called home, and I'm going to get that from my environment. And here we already get to see some of the power of Kotlin native. If I ask for the environment, I'm using POSIX getenv, right? The getenv function comes from the low-level POSIX API. This is, if you've ever used anything besides Java, you probably have seen POSIX in some way, right? All these languages, scripting languages, and even systems programming languages, almost everyone except for Java and .NET embrace these low-level functional functions inside of POSIX because they're just very common. So you might use Python or Perl or Ruby or whatever, or C, right? And they all have these, or Go, and they all let you talk to these POSIX functions. In Java, we sort of decided, well, we want to start from scratch and build everything nice and clean and have our own clean design. And it's worked to some extent, but the problem is that now, if you're a Java developer, you have no idea how these other functions work. And I've always just sort of thought that was a little silly, because every other language has these functions, and then Java has its own thing, right? So, okay, this is getenv. What this gives me friends, is a pointer. So I have a C pointer. So what I need to do is to turn that into a K string. But the problem is I can't do that because this pointer might be null. So what I need to do is I need to tell the compiler, hey, compiler, don't worry. I know it might be null. I'm okay with that. And you can do that a couple of ways. One is you can do a safe null dereference by saying question mark, period. And then you get a string. So a string like this, nullable string. That's fine. And if that is null, I could also provide a default value still. So now I'm saying, okay, do a safe dereference, and if it's null, then give me an empty string, right? So okay, there's my variable. I'm going to use string interpolation. So again, I'm using strings. I'm doing string interpolation. These are all things that are characteristic of a high-level language, and yet I'm able to do that in my Kotlin code. Okay, so now I've got my path, and I want to actually just implement this function. When I go down here, we already see our next interesting piece of functionality, right? If I go down there, you can see I've got a to-do macro. And that to-do macro it's just sitting there. And yet the function defines a return value of a list of string. And the first thing you might be wondering if you've ever used Java is, why does this happen? Why am I able to not return a value type, right? Like, imagine if I got rid of this, what happens here? It should fail, right? It should be, look, there's a red squiggly line down there. Can you see that? It's not happy. And yet for some reason, if I have this function in place, this large capital case function, it works. And to understand that, you need to appreciate one of the interesting bits of Kotlin, which is nothing, right? Not actually nothing, but I mean the type called nothing. Nothing tells Kotlin that this returns void, but it also says it doesn't return. So it's not just void, it's also void and it doesn't return. And that combination means that the Kotlin compiler sees that this isn't going to return, so it doesn't care that nothing happens here because it's never going to reach there, right? So you can do some very amazing things with this subtle difference. And there's just lots of examples of this in the language where they've just thought about ways to make writing code less of an exercise and more of a pleasure. Okay. So what am I going to do here? I'm trying to read a file in. So I'm going to read a file using fopen, which of course you've probably seen before in POSIX, right? That's another import from the platform POSIX API. And then I'm going to read in some lines. Now this is going to be, I'm going to read in the lines from that file and put it into a list of strings, okay? But I also need to read some data and accumulate that data in a buffer in native code. And that buffer is going to be storing native type. So I need to allocate that dynamically, okay? So I'm going to use memscoped, and I'm going to create a buffer length, okay? So the length is going to be, and you've done this before, even in Java, you have this kind of idiom where you do read while read line is not equal to -1, and you keep storing it, right? So I'm going to also dynamically allocate in native memory a buffer here, right? An array, and this is going to be an array of byte var and of length buffer length, right? So the reason I'm doing this inside of memscoped is because now I'm dynamically allocating memory, and something needs to clear that memory up. For this other stuff, Kotlin's going to do it for me. But for the stuff that actually uses low-level stuff, stuff that doesn't have the Kotlin runtime behind it, then I need to make sure that I clean up after myself with garbage collection or something like that, right? So this is going to do that for me. So now the pattern is pretty simple. I'm just going to keep looping while the data is there. I'll say next line equals, well, it's a string, it's a nullable string. It equals f gets buffer length and file, right? So I'm going to read data from the string, from the file, as much as I can into an array and into a string. And of course, I need to turn it into a string. So same as before, I'm turning it into a Kotlin string. So 2K string, safety reference, okay? Now I say if next line should equal null, or even nicer, since it's even though I'm doing low-level code, I still have this really high-level language, so I can do things like that. I can say, okay, break, right, if it's empty. And then finally, if it's not empty, I can add it to my lines list, right? So add this next line. Look at that, very, very trivial amount of code, right? Not a big deal, very easy to write, very easy to understand. Of course, you and I can see there's a problem here, right? First of all, I'm doing something that needs to finish. I need to actually close that file, right? So what I could do is I can use try finally, right? This is again, nice high-level language control flow that I don't have to, that I can also access from within my low-level programming, right? There we go. So I'm doing try and finally, and then finally I'll just return all of the lines. Okay, so there's my function. Very, very trivial. Let's run this. Let's compile it. And you can see that the Kotlin designers have spent a lot of time on making the language not just friendly, but also applicable, pragmatic. They went the extra effort to make it the best experience for Android, to make it the best experience for, oh, there it is. Hi, Kotlin. Hello, hi, salut, ni hao, etc. Right? So I've got a bunch of greetings in that file. So you can see that the language and the tools and the team have done a lot of work to make it a really pleasant experience for a lot of different use cases. And that is, I think, the thing to understand here. We're going to talk about server-side Spring today because I care about that, because I love that. But it's not the only thing. And so if ever there was an argument to learn a language, it's not just because it's a great way to do Spring. It's because they've really worked hard to make it a great way to do lots of things, right? There's no single ecosystem that will ever do everything you want. But Kotlin has really come close to trying, right? They're really getting close to that. So what we're going to do is we're going to build an application that uses Postgres, and it's going to use Kotlin. I'm going to start that Spring.io. Obviously, this is my second favorite place on the internet, right? My first favorite place on the internet, of course, is production. I love production. You should love production. You should go as early and often as possible. But if you haven't been to production, you can begin your journey here at start.spring.io. And what we're going to do is we're going to build an application using Kotlin, the language. We're going to create a service. We're going to use the default versions of Java here. Now, keep in mind, I'm not actually using Java. I'm just using it to compile. But even there, I encourage you to always use the very latest version that you can safely. Even though we have 3 selections down here, 15, 11, and 8, it looks like you've got 3 versions that you can use. The truth is you don't actually have 3 versions. You have 2 versions, friends, Java 11 and Java 15. Java 11 is the current supported version of Java. Java 15 is the current, Java 11 is the current long-term supported. Java 15 is the current supported version of Java. Anything else is a bad idea. Java 8 is no longer a supported version of Java. It's old, it's creakingly bad, it's slow, it's imperformant, it's just don't do it. It's technically an inferior version of Java. It's also morally an inferior version of Java. You will not want to use this. Just imagine the look of despair and sadness on your children's face when you tell them that you're still deploying production software on Java 8. They're not going to be impressed. Don't do it. Avoid it. Just avoid it. So we're going to use Java 11 or later. Okay, I'm going to hit generate.
Hey, Josh, your presentation is not visible.
Why?
Just stopped sharing.
Okay. Okay, better?
Yeah, great. Thank you.
Cheers. So we're going to hit, we got the new zip file there. I've selected all the defaults there. I think I'm happy with that. So we're going to open this up, this service, in my IDE. And again, I'm just going to use IntelliJ. Alrighty. So again, public static void main, not a big deal. What we're going to do is we're going to build a simple service that uses a regular API. So we're going to create an interface here. So I'm going to say customer service. And this service, this API, will have one method to return a collection of customer objects. Okay, so I need to create a customer object to map to a database table that I have. So I'll create a class, and I can create a class just like in Java. I can say private val ID int and private val name string, and that looks very Java-esque, doesn't it? I don't want to write Java code in this nice new language. I guess I could use the feature where I can create field and all that stuff in the constructor. That's a little bit better, right? And if I wanted to, I could do constructors still. But really, this is just a struct, right? I'm not doing anything interesting with it. So if I use this syntax, what this does is it gives me getters, because these are val, right? Val means read only. I could also do var. That means it's read and write. But I like val by default. The only thing is this syntax doesn't actually give me equals and hash code and all that stuff. To get all that, you need data in the beginning, okay? So that's already very convenient. I'm already ahead. And now what I want to do is I want to create a JDBC template version of this interface, right? So customer service. And notice that I'm using the colon operator to extend the interface as well as I would extend a class. It's the same syntax. That's another thing is nice about Kotlin. You have just one kind of syntax to do everything. So I'm going to use Spring's dependency injection mechanism here to inject a JDBC template, right? JDBC, and I'll just inject it into the constructor here. Constructor injection is very nice. Every time you use field injection, a unit test dies. So don't do that, right? So what we're going to do is we're going to say return this.jdbc.query, select all from reservations, okay? And here I have a JDBC template class. This class is 18 years old. It's been around forever. And these functions are very, very old as well. And you can see here that they have old signatures that make a lot of sense in the Java world, but don't always make a lot of sense in the Kotlin world. So for example, this one here takes a string and it returns a result set extractor. It accepts a result set extractor and it accepts a variadic array of strings. Well, of course, a variadic array of strings makes perfect sense in Java, where if you want to have a variadic array, you need to have it as the last parameter of the method. But in Kotlin, it's very natural to have a lambda as the last parameter, so that way you can write it outside of the closing parentheses of the function. So what I want is to have a version of this that lets me pass in parentheses, if I need pass in parameters, I mean, and also have a lambda outside of it, at the end of it, right? Well, this is where the extension functions come in, right? Extension functions. There you go. Do you see that? That's an extension function. That type, this function, doesn't exist on the Java class in Spring. It's been there for 18 years. These are functions that are added to the class retroactively by Kotlin. It's like playing a video game. When you start hitting control space, you get secret levels if you play the game with Kotlin. If you're using Java, you don't even get a chance to, right? So here are these extra functions that make the experience when working with Kotlin just more pleasant, just more nice, right? So I don't have to give up these nice APIs that have worked so well. They're still there, right? And I can do interesting things with them. So here we go. I'll say customer oh, sorry, it's not reservations. It'll be customers, right? So I'll say customer and then the rs.get int ID, rs.get string name. Okay. So this is my basic code. Now, of course, here we can clean up the code a little bit. We can actually get rid of the extra ceremony around the class because we know that it's just the function just invokes one expression and returns it. So I don't need to be very verbose about it. I can just do an inline expression like that, right? Much cleaner. Okay, so that's one way to write a service, right? And we can actually we can exercise that code like so. Class runner, private val CS customer service, and it'll be a Spring Bean, and it's going to be a bean that's going to be run when the application starts up. So ready event, class Java, fun ready, and I'm just going to say cs.all.forEach, and I'll print out the results, right? What's the issue with here? Oh, of course. Good. Okay, so this is my basic winner. Let's see if this works. Or if I need to create that database table. Oh, I need to also connect it. I'm talking to Postgres. So I can say Spring data source URL, JDBC, Postgres, QL, is it? Localhost, and then Spring data source username, orders, and then password, orders. Okay, what's the next issue? I always get this confused. Postgres. Take 3. And what's the issue here now, friends? Postgres, JDBC, Spring. Oh. Spring data source URL. What's the issue? Driver class not found. Okay, driver class. Go faster. Postgres QL. What is the issue? Oh, I need that. Take 5,000. JDBC. Okay, we're gonna just cheat here a little bit to get past this because we are certainly blocked for something I'm missing that is obvious. So copy and paste. I don't know what the difference is. Whatever, let's just do that. Honestly, what is going on? What did I choose? I chose customers. Okay, good. Now we're cooking. So the table customers doesn't exist. That's okay. So PSQL U orders create table customers as select all from reservation. Good. So now take 2 or take 10. Try it again. There we go. Whew, finally, right? There's the data. So that's fine. I like that approach. That works just fine. Very convenient, very consistent. And you can see that through extension functions, we can do more with old APIs that have served us for a long time. But I want to turn now to a Kotlin ecosystem-specific offering called Exposed. Now, Exposed works really nicely with Spring. And again, it just shows the pragmatism that you get by using this language in this ecosystem. So what I'm going to do is I'm going to add this to the class path, and I'm going to then describe the mapping to my SQL tables using this Exposed ORM. I have to have configuration, and I don't want configuration, but if I have to have it, I can have it as an object. Now, an object in Kotlin is a singleton. It's an object that will only exist once, right? So it's a special syntax, kind of like what we have in Scala, right? So I'm going to say integer ID dot auto increment, and then val name equals varchar name 255. Okay, and that's it, right? That's my basic metadata of the table. Now I can actually implement a new version of this service, just writing with Exposed, right? So I can say Exposed customer service, right? Customer service, and same as before, right? I can do this. So at service, and here I benefit from this nice language. I can say, okay, customers dot select all dot map, and I create a new object by using it. Now, it is an implicit parameter in the Lambda, right? I could write this as Java. I could say RS, and I would have to say RS. But I have this nice language, and the language gives me an implicit parameter called it, which I can use whenever there's just a single version of a parameter, right? So it customers.id and it customers.name. Now, all I've done here is I'm indexing into this object it. That's another thing that's nice about Kotlin. You get operator overloading. The other thing that's nice about this Exposed library is that it understands Spring's concept of transactions. So it's easy for me to integrate that. I don't have to do anything special. I just use Spring's regular transactions support. And again, this is a nice example where I'm doing something old, JDBC, and I'm using a nice new fluid API to do it. So that works just great, right? It's an improvement over old APIs. And it's also an integration of Kotlin ecosystem APIs into things that you may know from Java. Again, this is sort of the middle ground, right? This is sort of the pragmatic, I want to start with Kotlin, but I want to make my existing life easier. Where I think a lot of the power in the language really lives, though, is when you start to do DSLs, when you start to look at Kotlin APIs that were built with Kotlin in mind. Okay, so we're going to build a reactive web application that talks to R2DBC, talks to Postgres, and maybe we'll get to Gateway. Who knows? We don't care if we don't. It's okay. So what we're going to do here is we're going to build an application that uses some of these new APIs that are Kotlin first. And these APIs, I think, are very, very interesting, right? Because they make the work that we're doing just that much more pleasant, right? So DSL's application, whoops, bad, Kotlin. Okay, so RMRF DSLs, goodbye to that. Generate. Good. Okay. So in the Spring ecosystem, and in general, right, there's this move towards asynchronous non-blocking I/O, and that's typified by reactive APIs, especially in the Java ecosystem, right? So I'm going to build an application using some of these traditional APIs. So we'll build an HTTP endpoint here, and that endpoint is going to produce data. Well, of course, I could use the Java API, but look how much nicer it is when I use the Kotlin DSL to create an HTTP endpoint. I'm going to say call reservations. This is another domain type, another endpoint, right? And when that endpoint is invoked, I want to produce a response. And the response I'm going to produce by using my Spring Data repository. So reservation repository extends the reactive code repository, managing instances of type reservation. Now, I haven't created that class yet. So data class reservation, val ID int, val name string. Okay. And we'll say reservation int, right? There's my entire interface and my data type. Now I can say, I want to inject that here, RR reservation repository, and I say RR find by ID. I want to look for a particular one, right? Good. So it's that path variable. Okay. So I'm finding a single result and I'm returning it as the value. Now I have to tell this function what the type that I'm sending back is, because it's what it sees is that it's got a value that's been wrapped in an asynchronous type, kind of like a future, right? So I've got this type called a mono, which is a reactive stream type, okay? And so I'm wrapping that in. I'm wrapping the generic signature in that. And so I need to tell it what the generic type is. That's the super type token pattern. Well, we can go further. We can actually improve this quite a bit, because in Kotlin, first of all, we have pseudo-reified, kind of quasi-reified generics, right? So look at this. I can actually just use an extension function, and you can see that that extension function uses inline reified generic types. Nice, right? And so this just becomes very clean. Okay, but going a step further, you may know that in Kotlin, we have reactive APIs, and you can use those just as well. But wouldn't it be nice to be able to also take advantage of Kotlin's amazing support for coroutines? Well, you can do that now, right? We have coroutine support in the Kotlin ecosystem, and we have coroutine support in the Spring ecosystem that builds on top of all the reactive APIs. So this code that I just showed you here can become a coroutine example instead, right? So right now, this is a mono of reservation, right? It's a reactive type. And so here we go. Good. Right? It's a reactive type. And I'm going to turn it into a coroutine version. So instead of having to write code where I unpack the asynchronous value, instead I'm going to just use reservation. And in order to do that, I say I want to await the value, right? And once I've done that, I can just do body value and await. Pass that in. Now, even though it looks like it's imperative blocking code, behind the scenes, this function will return multiple times, basically. It'll return whenever there's an asynchronous action, the thread will stop. It'll create a continuation. That continuation will be saved for later as a callback for when the asynchronous thing happens, and it'll go through to the next line. So even though it looks like I'm writing step 1, step 2, step 3, it's actually step 1, asynchronous pause, suspend the function, and then callback, step 2, asynchronous pause, etc. It's just very, very simplifying code, but I'm still getting the benefits of reactive APIs. Okay, so this is already a big deal, right? This is totally different from what you can do in Java. Well, even this, the beans themselves are Java config, right? Can we do better? Well, yes. In Kotlin, in Java, in Spring, we have a beans DSL, where you can actually register beans functionally instead of using the bean annotation syntax. And this beans endpoint is just a function. So you can use a for loop or whatever, right? You can do all sorts of things. I can also look up other objects by their type like that, right? So I don't have to specify a type token or a class literal or whatever. I can just use the generic implied type. So let's run this. Run. So we've got coroutines. We've got a functional definition style for registration. We've got a very, very succinct code base. I've got data access. I've got a web endpoint. I've got coroutines. It's the most efficient, resource efficient, thread efficient code, and it's very lightweight. Oh, I just need one more thing. Those properties. Oh, those darn properties. Orders. Let's hope that this one goes faster. URL R2DBC Postgres localhost orders. Come on. Faster. Compile faster. Cool. So let's try it out. Localhost reservations and which was PSQLU orders. Reservation. This one. 2123. Oops. Wait. Reservations. Reservations. Fine. Okay. Oh, I have to do the identifier for the framework. Take 3. Come on. 13 seconds. Hopefully, my friends, you've seen what's possible. I hope you see that the Kotlin ecosystem is rich and vibrant and growing every day. And there we go. There's my coroutine-based code. Thank you so much for your time, everybody. Dziękuję. I appreciate it. I hope you have a wonderful day, that you stay safe and healthy. And of course, if you have questions, don't hesitate to find me on the internet, and I'll happily answer questions in the chat quietly. Thank you for your time.
Thank you very much for your talk and your time, Josh. And here we can go on the lunch break now. So we'll be back in about 40 minutes.
Okay, hello. After the break, we have here Karan, the mobile developer, who will talk about integrating Google Assistant for continuous integration. So, Karan, here's your screen, and the time is all yours.
Okay, so Jean Dubry, everyone joining from Poland, and good afternoon to all those from joining from other parts of the world. So first of all, thank you to GDG Poland, I think, for giving me this opportunity to speak today. Okay, so let me quickly introduce myself. My name is Karan, and I'm from the land of mystery and diversity called India. So primarily, I work as a mobile developer, but recently I've been dabbling around DevOps, AI, AR, and VR. And apart from being passionate about technology, I also like writing poems, traveling to different places around the world, and meeting new friends. So that is about me in a nutshell. So I'm sharing my screen right now, so just let me know once you're able to see it.
Yes, I am able to see them.
Yeah. So today's topic. So I think it's fairly simple, but let me tell you what exactly I'm going to talk about. So today's world. So let me begin by quoting Albert Einstein, and he said, in the times of difficulty, there is always an opportunity. So today we are all in difficult times. I think most of us are all at home, working from home. Social distancing has been the buzzword nowadays. Workspaces are slowly evolving, and we are now getting used to the so-called new normal. So this is what the world is today. So coming to the next slide, so let me take you a little behind time right now. So let's say maybe a couple of years back, there are certain things that you might be aware or you might be knowing, especially if you're from a software industry. So the first thing is about agile. So I know this term is something that many of us have been hearing for like a lot of years right now. But the fact is that agile development is winning. And why I say that is because agile is something that has given or proven to have better quality, improved the efficiency, and more so it is said to be more result oriented, where you do not actually have to wait for the end to see the end product at the frag end or like a big bang kind of an approach. This agile makes it very easy to see various phases of the product, like in terms of sprints. So that is why agile is something that is been winning over the years. So the second term or the second terminology that most of you might come across is about continuous integration. So continuous integration, as the name suggests, is basically putting all your assets, putting your project assets or everything, your code, into a central repository and doing a kind of automatic build, deployment, and testing in a one single environment in a continuous fashion. So that is how continuous integration basically came about. And continuous integration actually helps to make results visible also. So that is one of the advantages of continuous integration. And the third and the most important thing that I would like to touch upon in today's session is about voice first. So voice first technologies are something that I consider to be the next big thing. And the reason is something that is more natural. And many of you might agree that conversation nowadays is one of the best ways to solve a problem. So normally a conversation can be an easy, simple conversation, and that could help actually solve complex problems as well. And I feel that voice first technologies, I think, have improved accessibility over the years. Okay, so moving to the next slide or the next part. So we all love data, right? So we all love to understand how data has been processed or data has been represented. And data is all about collection of facts. So here's a quick fact about voice first in general. So Gartner is a very famous research organization that is there today, and Gartner predicts that 25% of digital workers would be using virtual employee assistants daily by 2021. And it also predicts that by 2023, 25% of all employee interactions with applications will be voice. This is something which is really big, and this is something that is going to affect the lives of each one of us. So data, according to data analysts, I think voice first is also something that has been now predicted to be the next one of the next big things. So coming to the next part, now as developers or as software professionals, there are certain problems that we have been facing for so many years right now, and these are some common problems. So one of them, I think, is for the first problem that we face is complexity. So right now there are so many different technologies that exist today. There are so many different systems which we integrate with, be it like Oracle, SAP, and the number of technology, the number of systems that we deal with on a day-to-day basis in our projects are quite a lot. And with each of these systems, of course, we have to have a different strategy. Especially in terms of this, in times of these, in this kind of an era, you do not work with you do not work independently more often. You now work in larger team sizes where your team is now located across different geographical locations, and it becomes very important for you to coordinate between different teams, and that is where you have a larger team size, an ever growing team size that comes into a picture. The last and the most important point is about the higher learning curve. So like I mentioned, with technologies coming, like each technology or each new language, you actually have to try to learn and upgrade yourself and try to fit into the scheme of things. So there's always a higher learning curve when you move into a new project. And all this is expected from developers. So as developers, what is expected from us is to write clean code, to write test cases, to identify defects as early as possible, and more important, to be proactive rather than reactive. And all this is against time. So time is something that is not going to wait for us, but then we have to actually make sure that all this is completed within the deadlines or within the product life cycle that we plan, and we have to ensure that the product gets released at a proper date. So this is the problems that exist and have been existing for quite some time. But what I'm going to talk about is how information can be made accessible on the go. For example, information is something. Now when I say data is about collection of facts, but information is actually how we understand those facts. So information is something that we all need access to. I think whether be it at home or office, or whether you're traveling or anywhere, information is something that we always seek access to. And from a developer's point of view, I think some of the common questions or some of the common information that we need is about, like, for example, in case of DevOps, I think the most common questions would be like, was whether the last build was successful, or how many test cases passed or failed, or whether what was the last commit that broke or what didn't. So that are some of the common questions that as DevOps or as a DevOps engineer or someone who is into DevOps would like to seek answers to. And this is something that we try to seek answers on a day-to-day basis. So that's why it's becoming more and more important for us to get answers to all these questions. Now, what are the challenges that actually exist today? So there are certain challenges that I would like to highlight that exist among software projects right now. The first challenge is about dependency and communication among members within cross-functional teams. So when I say cross-functional teams, it means basically teams basically involving different functional areas, whether it's a product team, a sales team, or a marketing team. Typically, in a kind of a technical team, you would have people of different roles. So you will have a visual designer, you will have a UX or a visual designer, you will have a developer, you will have a tester, and so on. So there will be different roles, but there's always a certain kind of dependency that exists between each one of them. For example, only once you get a design or an approved visual design from the designer, you would then actually start the implementation. Similarly, a tester would actually start testing once you have completed a particular module. So there's always a certain kind of dependency that exists. And as and when your team size grows, I think communication becomes very, very crucial, especially if you're working on a large project involving different people from different geographies. Communication is very crucial. Like even a slight miscommunication can actually end up building the wrong product. Time and cost is again one of the most important metrics or one of the most important challenges, I would say, that exist today. We often spend a lot of time developing like web portals or reporting based web portals, as we call it, to represent certain data, but the effort and the time we spend in this is quite large, and at the end of the day it stays as it is without we using it much. The third and the most important thing I feel is about feedback without manual intervention. So all of us are right now when we don't have access to to our physical systems at office like directly, we tend to seek feedback using different mechanisms. So like right now we tend to log into a particular system, or maybe log into a system, enter the URL. So it's all a manual way, but we would like to do it in a more automatic. So in the age of automation, I think everyone would love to have something, an automatic kind of a service that could help or get this specific information. The next point is about organizational culture and development methodology changes. So what do I mean by this? Basically is that in organizations typically that undergo a change in culture. For example, if a project is basically initially it was a waterfall, and then it's now moving to a agile kind of a methodology, this transition doesn't happen overnight, and it's not something that is easy to do, especially when you're transitioning to like an agile model. You have to actually plan it very well, so that you can, user training is again one of the most important parts of this kind of a change. So you need to ensure that this transition is smooth, and this is, I think, one of the challenges that exist today. And the last, and not the least, is about personalization. I think each one of us needs, like everyone wants a different experience. Everyone wants to have a different kind of an experience which is tailored to his needs. So that's why personalization and user experience is also becoming a challenge right now. So the proposed solution, so the solution I would like to propose today is about creating an interface, creating an interface which is more voice based, or I would say a voice based communication interface that uses the simple human language. And it would also leverage the existing CI framework. So let's say you have an organization where you have, or you're using an existing CI framework. So in this case, I'll be showing about Jenkins. But if you are using any kind of framework, so you would love to leverage that kind of framework to actually build, to actually monitor your builds and generate reports and much more. So that is what the solution is about. And of course, you would be also using the latest AI technology. So here I'll be talking about Dialogflow, and how I have used Dialogflow to create intense and create meaningful also conversations with an end user. So in this case, an agent. And all this would actually happen seamlessly without the need of a centralized web portal. So there is no need of having those enterprise web portals. All this can be done using simple and natural human language. So this is the architecture of the system. So let me go through the architecture. So the architecture of the system basically involves an end user. So the end user basically is our agent. So in this case, the agent basically, like, let's say I would call it an agent Jenkins, and this particular agent would be actually communicating with the Dialogflow system. So okay, so let me just wait till this slide opens up. Okay, just a moment. Okay, so by the time the slide loads up, so basically the architecture that I'll be talking about involves an end user. So there will be an agent, and that agent will be communicating with the Dialogflow system. So in this case, you will have the Dialogflow. Dialogflow basically is an end-to-end kind of a framework that helps to build conversational interfaces. So that is what Dialogflow offers. And using Dialogflow, you can actually define something called as intents. So intents basically, as the name suggests, specifies the intention of a conversation. So in this case, let's say I have an intent, like say I want to know the job status or the build status of my particular build. So that the build status actually becomes an intent. And using Dialogflow, we can actually capture or recognize this intent based on the user expression. and basically it
Sorry, guys. It seems that one of our speakers have internet connection problem. So maybe we'll start with the next session. Are you ready, Bartosz?
Yep.
Okay, so guys, I would like to introduce you Bartosz Polańczyk, who talk about microfrontends in mobile, not in the web, but mobile. So he will teach you how to build as highly scalable frontends for mobile experiences.
Yeah, so hello, I'm Bartosz Polańczyk. I work in Vodeno as a senior front-end engineer. And I have a pretty interesting story to tell. So this will be more of a case study than normal presentation, and I'll present you with challenges that we faced when we were trying to build a mobile app for banking, for cloud banking. So let me share my screen. Okay, so to put it simply, we are building a bank called, we are building a financial technology called Vodeno that is now consumed by a bank called Ion, and we are trying to build a plug-and-play architecture that can be reused by any possible bank that wants to, for example, use one of our solutions. And when we were thinking about building a mobile app, we had to find a solution for that. We had to find a solution that would suit us the best in terms of workflows, in terms of technology, and especially in terms of rolling changes, because as we are pretty innovative, the changes are rather often, so we have to account for that. So first thing first, a bit about our backend. I'm not a backend developer in Vodeno, but I want to tell you what we are trying to achieve. So our whole bank, our whole technology, banking technology, is hosted in cloud. It's probably one of the first European banks that are PSD2 compliant that do that. So apart from that, we are using blockchain for verifying the transaction state, etc. So it's pretty innovative. And what we wanted to achieve in frontend was to split down bank into smaller parts and correlate them with the backend. So we have separate teams for example, cards, for credits, etc. And each of those teams have their dedicated frontend and dedicated backend, and along with mobile devs. Thanks to that architecture, we are able to share components with external entities. For example, if you're a bank, you can come to us and say, you know, we don't have good solution for cards. We want to get it. We don't have good solution for, let's say, managing customer data in banking. We can do that for you, etc. So it's all about customized product offer, and it looks fine from the customer's perspective, but from our perspective, from technical perspective, it creates a lot of challenges that we had to overcome during the last year or so. So the core service is about multi-tenancy and white labeling. So we are selling you the ready product. We are releasing the app for you, but you don't have to worry about all the changes, because all the changes are actually rolling changes happening in WebView inside mobile app. So how to design a microfrontend to work as a WebView inside mobile apps so that it can be split down and it won't affect your experience in any way. So we have to think about 3 areas to talk about it. First thing first is common web code. So all the stuff that will be shared across all the microfrontends. So how to share it and how to write web efficiently so that the customer doesn't know that it's actually a web app running in WebView. So if any of you who are mobile developers probably know that WebView usually comes with a lot of performance issues, and we try to solve most of them, and I think we are successful in most of them. Another thing is how to version the app in a way so that we can replace the apps dynamically, but still maintain the versioning, so we exactly know what is running on each environment. Second part of the issue is mobile native experience. So how to transition from web to native in a way that it won't be felt by the customer, and how to keep all the interactions fully secure, because we are talking about finances, we are talking about people's money. So we can't just throw the data any kind of like direction. We have to think about how to keep it secure. And the last but not least is infrastructure and deployment. So how to glue all of those parts, each of those separate apps together into one mobile app, how to maintain different app versions for each of our potential B2B customers, the banks that will be using parts of our functionalities inside their own apps, how to make sure that all of it works together, runs together, loads together, and provides a nice experience for the user. So let's start with talking about common code in web. We'll delve deeper later, probably with some parts of the code if time allows us. So first thing first, we have to think about consistent looks. If we want to maintain consistent looks across whole stack, across whole teams, you have to create some kind of a base components library that will allow you to maintain the looks and will essentially mitigate any problems related to CSS or positioning, etc. So we essentially design a library called Vodeno UI components that allows us to create components without writing a single CSS line at all. One moment, sorry. It's well documented. It can be reused across all the channels that we have. So all the parts of our app. It also has a playground and an auto-sync docs and designs. So every time when we release a new version, you can check it out. You can check how those components look like, what was changed, and you can essentially play with it because our UX designers are updating those on more or less on a daily basis. Second thing is all of those parts of the code that are not related to looks, but are really important for the apps to work consistently. So any kind of common error handling, shared framework code, any kind of business operations that can be shared across domains, and of course, mobile communication. Because we are communicating with the mobile a lot, like when you are in mobile context, almost every request, essentially every request goes through mobile. We had to create a standardized way of maintaining this communication so that from front-end perspective, we don't have to worry about mobile aspect, and from mobile perspective, they don't have to worry about web aspect of the code. And the final thing, whatever we couldn't standardize, we just wrote the docs for it. So we have a lot of documentation for how to develop the code, how to maintain some common practices, how to introduce common practices to your repo, etc. Of course, it's all evolving because you can't maintain it consistently across so many channels, but we are still striving to do so, and I think we are pretty good at it. So let's start with a mobile aspect. So my goal is to start with those parts that are more common, and then we will delve deeper into the part that is the most important for me. So the web aspect, the micro-frontend aspect. So let's start with mobile. So we are talking about finances. We can't allow ourselves to have insecure operations in any way. Because of that, all of the secure operations have to happen directly in the mobile. So things like entering your PIN, entering your secure code for your app, onboarding, etc. They have to be native because in mobile context, we can maintain this security much easier, mostly thanks to external providers, etc. So all of the secure operations, they don't happen in web. They can be initiated from web, and you can get a result from web, but the operation itself is always happening in the mobile. Web part is able to transparently communicate with mobile. It can parse the result, but it can't perform the operation itself. Another thing is seamless context switching. So imagine that you are doing something in the mobile, and then you run the web view, and you load the JS code into web view. The problem is you will have some loading times. Because of that, we are currently experimenting with caching and off-screen rendering. And as a front-end developer, one of my biggest challenges in Vodeno that I'm really proud of was to optimize our web part, our micro-frontends, to run as soon as possible and as fast as possible. And I'll talk about it a bit later. Last thing when thinking about mobile that is overlooked when working with web views many times is actually web compatibility. So because in web view, you're essentially using headless Safari or headless Chrome, you have to think about feature set of those web view browsers. And because of that, you have to keep in mind, for example, rendering differences, support for different functionalities, etc. And because of that, UI components is a great solution. You don't have to think about, for example, the sidebar rendering differently on web or on iOS or Android, because web components under the hood, they can actually tell, then they can actually mitigate that. So when developer is using this component, he or she is just using it directly. Okay, and now a bit about building the front end for the cloud. So we're building micro frontends that correlate to microservices. First thing first, let's introduce some common concepts. First concept that is pretty relevant to us is something we call channel. Channel is a single part of the app responsible for single things, so more or less like one microservice. In this case, it can be credits, cards, finances, settings, something we call Betamax or Butler that can suggest you the best credits offers, etc. for you. Each channel can be developed by a different team, and that's exactly the case in Vodeno. So we have a lot of teams. Sometimes you migrate from one team to another just to have some refresher, but usually the teams do not overlap. So you have people that are specialized in particular parts of the app. Each channel is actually equally important and treated in the same way. So when it is loaded, apart from some channels that are loaded first for performance reasons, all of the channels are exactly the same. They are loaded in exactly the same way, in parallel as much as possible in JS world, and they are then exposed in the same way. And all of the available channels are pre-configured based on the customer data. So, for example, when you are a B2B customer, when you are what we call SME, small, medium enterprise customer, you usually use different apps. You want your app to be served in a different way. So based on customer data, our orchestrator that I'll talk about more a bit later, facilitates that data and is able to load particular part, let's say, chunk of channels that you need. So you never load the channels that you don't need. You always have only channels that you actually need in your customer context. So the common integration base, our orchestrator, is called Vodeno Platform. And this is the glue that glues all the channels together. It's very simple yet smart orchestrator. It almost doesn't have any kind of front-end code. It's pure JS that glues all this stuff together. It has a lot of wrappers around native mobile communication, and it is de facto the unit that allows to the part of the code that allows for interchannel communication. So it creates a kind of code that allows you to communicate between channels. Thanks to that, we can easily deploy each channel. So you can deploy one channel without deploying whole app. You can deploy the orchestrator without deploying most of the channels to some extent. And you can version your changes. So single SPA gives you ability of loading everything later. Microfrontends gives you microfrontend framework that we use allow you to load everything later. So in order to solve that, we actually have some clever versioning mechanism. Okay, let's start with Vodeno UI components. So this is prepared with in close collaboration with our UX designers. It eliminates most of the issues with writing HTML, CSS directly, which means that if at some point in future we decide to migrate to full mobile, or I don't know, just like replace one part of the app with mobile, you can just do it because there is no HTML, there is no CSS, there are only components. So if at some point in time we create the same library, but implemented using, for example, React Native, it's not a problem at all because it's just plug and play. It's much easier to transition to native thanks to that. And apart from that, it's written in TypeScript, so we already have possibility of using pretty clever type checking, etc. And under the hood, it uses styled components. And thanks to that, we can easily exchange the styles, and we can provide the app with colors that, for example, particular B2B customer, particular bank using part of our app wants. About security first. So because of those restrictive banking finance standards that we have to meet, we use native for safe context, as I mentioned before. Web is not safe for specific cases as user tokens or whatever. So the only thing that web knows about is something called OPEC token, which is essentially just a token that allows us for communicating with web, because in mobile context, it's mobile that actually handles all the authorization, etc. In order to mitigate problems coming from communicating with mobile, we use something we called a bridge, JS bridge, that is used to communicate between layers, and it's standardized across systems. So we don't have to worry whether we are now developing something for iOS or for Android. The only place when we have to worry about it is when we present some custom functionalities, like, let's say, pay with Google Wallet, pay with Apple Wallet. That's the only place in the code when we actually check if we are in iOS or Android context. Apart from that, that's not important. All of this is written in a way that it allows for asynchronous communication. So we use promises or callbacks for some functionalities, older usually. And that allows us to just wait for the response and perform any other operation in the background. And under the hood, we actually wrap native script injections. So what happens when you communicate with mobile is mobile tries to understand your request, and if it has any code that correlates to whatever you want to achieve, it will parse your code and try to return a response. And the messages can consist on any arbitrary data, so that's pretty cool. And it actually, all of it happens via browser window. So all of the responses, etc., they are attached to browser window by native scripts. Okay, let's go further. So mobile framework bridge, it's generally platform agnostic and built with secure in mind. Apart from like common methods, it consists of additional methods that allow us to tell whether we are in bridge context or in iOS, Android. So now the thing that I didn't tell you before, our app is, apart from being displayed in web view, it's actually running as a web app as well, with some set of limited functionalities because of the security. But most of the stuff can be done in web as well, and it's actually one code base. That's pretty cool. You don't have to worry as a developer whether you're writing for mobile or native, apart from like container sizes, etc. But that's only cosmetic things. And it's mostly done because we have a set of methods for a mobile framework bridge, for JS Bridge, that tell you whether you're in mobile context or not. So every time when you're developing something and you have to check whether this should be run on mobile, you just have one method that on web will always return false, and on mobile will return proper value, so like true or additional method for checking if it's iOS and Android. And it's available in every context in the web. So whatever you're developing, you don't have to worry whether it's web view, web, or any other context for the app. Now let's delve deeper in shared utils and business logic, because as you can imagine, in banking, we have a lot of common entities that are traveling all around the systems, like, for example, IBAN, which is one of the identifiers in banking, etc. So we had to find a way of sharing that code across whole stack, sharing the code across all the microfrontends out there. First thing first, we are using React. That choice was mostly chosen because of, at that point in time, React was more mature solution for building such architectures. It was easier to start with, etc. And we didn't have to think about so many things. But more on that a bit later when I will be talking about our customized Create React app. Then we have business utils. Business utils are essentially mostly framework-less set of JS utils for example, handling financial data, how to process currencies, how to format card numbers, how to, and things like common error handling. So how to, for example, handle the error that happens from the backend in a consistent way. We are using Axios to communicate with the backend. And Axios is replaced with special mobile polyfill in mobile context. So because of that, we want to have a common error handling for all the contexts. And we have this in business utils. So you don't have to think about how to handle particular error. You just have to think how to react to particular error without worrying about internals. Then we have React utils that are purely created to exchange components. So if you have some component that should be exchanged between those domains, you can put it in React utils. Examples can be some locally helpers, etc. Framework-specific utils to handle some React stuff, like we have some stuff for error borders, error handling in React level, etc. And then you have a set of wrappers and context providers for different stuff that should be injected to the whole app. And both of the libraries are well tested and versioned. So that's pretty cool because you can make sure that that you use exactly the version you want. About the well-tested part, we are using our CI pipelines. We are using GitLab on a daily basis. And apart from that, we are using a tool that is called SonarQube. And SonarQube is an amazing tool that facilitates code quality checks. So essentially what it does is it connects to your CI, and every time when you try to release your app, it will check for all the possible checks, like if your coverage is okay, if you don't have any code smells, etc., and it will inform you if you didn't meet a particular threshold that you should meet. When we cannot standardize something, we still try to write a documentation about it, write a tutorial about it. So first thing first, we have a pretty extensive ESLint configs. We are in the process of standardizing them on a, let's say, company level, but we have a common base for those. So that way we can make sure that all the apps more or less look the same. So for example, when one day you decide, or your manager decides that you are needed in another project, you just jump in, and there is a high chance that in terms of how does the code look, it will be exactly the same. There are some, of course, nuances, etc., because our bank was built by a lot of people in pretty excessive time, but still, most of the code will look the same because we are striving to keep it as consistent as possible. And part of that is happening thanks to standardized CI pipelines. So all of our projects have the same CI template. So they have to go through the same steps every time when you are merging your merge request or pull request in GitHub world. You have to go through whole CI pipeline that checks your code quality, checks your ESLint smells, checks your test coverage, checks your NPM deprecation warnings, etc. So when you are able to merge, it's mostly meaning that you're really close to having like a properly developed app. And apart from that, we have a lot of tutorials and guidelines whenever you need them, whenever you can't do something directly in the code. About context switching. So as I mentioned, we sometimes go to mobile, wait for the data, for example, inputting PIN, and then we go back to the web to get this information. So it's pretty important to have really fast context switching. We achieve that by preloading in mobile as much as possible and being ready as soon as JS is parsed, even before React is ready. So if some of you work with React, you probably think it's really fast. It's actually not when you have to think about load times. Because we are reloading mobile sometimes, a lot of times, because of the context that we are providing to the user, we had to minimize the time that React takes to load. So whenever we can load something before React is even started, we do that. And we actually shaved off a lot of time thanks to that. Apart from that, we are pre-caching a lot of data in a clever way, for example, by loading the data in proper order or loading the data in batches in the browser. And we have a caching mechanism that is currently tested, but we don't have it on production yet. About the differences. So in particular, we had problems with regexpress because we had some clever mechanisms to clean up the data that is sending back and forth from our web view. It occurred that Safari doesn't support negative look aheads, and because of that, that was the point in time when we realized we actually have to think about having consistent support on all the browsers. So right now we are testing our apps first we are testing them in desktop browsers, then we are testing them on mobile, and then we have to push them along all the environments when they are tested using simulators, real mobile devices, etc., before they land on production. And now for something completely different that is actually my domain of interest, which is microfrontends. So let's first compare microfrontends to conventional approach. So in terms of microfrontends, it's more or less like microservices. You have domains. Each domain is simple yet smart. On the contrary, you have monoliths in conventional frontends. Then in microfrontends, you have small apps that are taking care of single domain, whereas in traditional approach, you have big apps that usually integrate all the features and have some clever lazy loading and routing. Code splitting in microfrontends is happening on build and repository level. So each of those small apps are actually residing in a different repository, sometimes along the backend, but usually just in the same project, but in a separate repository. And as in conventional approach, it's usually just chunks on a build level. Lazy loading is still possible with Microfrontends. We do that inside the app, so we have like 2 levels of optimization. First is just chunking the app, and second is chunking routes inside the app, so they are lazy loaded. Thanks to that, we have separate teams working on separate projects. We don't interact with each other a lot. We still perform our merge request reviews just to keep be in the loop, know that what happens in different teams. But apart from that, I don't have to worry that, for example, because of some other dev in other team, I'll have some merge conflicts that I'll have to solve or wait until he or she solves it. That's actually pretty cool. And now a bit about this darker side of Microfrontends. So first thing is interchannel communication. You have to facilitate this communication in a special way. You can't just create some simple file with like post message or whatever. You have to think about the fact that they can be loaded in different moments, etc. And then you have steep learning curve at the beginning, because that's a completely different approach than conventional one. And there are actually no solutions that are like completely feasible to all the cases that you can meet around the web. And there are a lot of frameworks that you have to choose from. We actually chose this one, Single SPA. So Single SPA is a framework agnostic framework for building microfrontends. It does have bindings for React, Vue, and Angular, but you can write, like you can easily connect any framework, even jQuery or whatever, to it that you just want. So it uses lazy loading. So the idea is that you have a route you have a route listener or route condition that activates at a particular time when you navigate through your app. And when it's activated, it lazy loads your code. You can preload it, pre-cache it if you want, but generally the best case is it will be loaded just before you navigate to a new route or after you navigate to a new route, depending on the case. It exposes a set of lifecycle hooks that allow you to granularly control whatever is happening in your app. And it does not give you a straight way of loading and gluing everything together. You have to think about it. They have a lot of tutorials, that's true, but I don't like their docs, if I can be honest. They are a bit tedious, a bit complicated to start with. But it's a pretty solid framework in terms of being well tested. We never had any serious issues with that in terms of their code, and they were actually improving from version to version a lot. So you have 3 lifecycle methods to start. Bootstrap is the method that is run once at the beginning when you register your app, and this is the place in code when you can register whatever should be prepared before the app starts. Then you have mount and unmount that are called consecutively, or not really consecutively. Mount is called when you enter the registered matching route, and unmount is called when you leave that route. And they're essentially used to prepare and clean up the app, and they can be called many times. So whenever something should be called once, it should be in Bootstrap. Whenever something should be initiated every time you enter a particular app, it should be done in mount. So for example, fetching user data, that seems like something more feasible to mount and unmount. About managing the app. So you register the app using register application method, and it accepts a few parameters. So first, pretty simple, name of the apps. Active when is actually more or less determinant function that tells the app when this particular app should be activated. So this can be just a simple route match. This can be any other event that is happening in your code, as long as as you are able to return Boolean for that. This function can be used to tell whether your app shouldn't be loaded or not. App is app itself. So this is app code provided as a parsed JS, and then you have additional props that can be used to inject particular code into the app. So for example, some common properties, common services, etc. We are actually slowly migrating our code to use custom props more, because it's pretty cool. It allows you to granular control and for easily sharing a lot of code between the apps. Properties are set once on at the app activation, but they are passed as they are as a reference. So you can pass, for example, the service that will be reused across whole stack. And application param, as I mentioned, can be an application param can be function as well. And so, for example, if you want to have lazy loading, some pre-caching mechanisms, etc., you can implement it as long as you return a promise with resolved app code. That will be okay. Single spine practice is generally a pretty cool solution, but it still comes with some downsides, because the same can be said about microservices in backend. So first thing first, despite the fact that it's platform agnostic, even single SPA authors, they suggest to just use one framework because it's much more efficient, it's easier to create common code, etc. So we chose React because it was easier for us to modify, create React app and reuse it across the stack. For boilerplate code, it's really simple to start. You just need those 3 methods, and you just need to read them inside whatever you have here in the app. But all in all, it's just easy to start, and then it just grows and grows. And there are a lot of paths to take. So you can decide to use pretty cool feature of import maps versus some kind of Babel Webpack transpilation. For like gluing everything together. You can go with apps that are loaded on particular endpoints, or you can use parcels that you'll manually, and then you can keep everything in one repo using the Lerna, or you can keep it in separate repositories. So those are things that are up to you, possibly for the best, but maybe they could be standardized in a bit better way. And the same goes for bootstrapping. So to start with, you just have 3 methods, but then you can extend them, add some functionalities inside them, etc. But still, I think it's worth trying whenever you have big organization with a lot of domains, and whenever you want to have a separate development of each of those domains. Let's talk about channels. So each channel, as I mentioned, is a core building block for the functionality. Each channel corresponds to a particular domain. So it's maintained by a different team, it resides in a different GitLab repository, and it has its own CI pipeline, but in reality, this is just the same pipeline template. And it uses common components. So essentially, it uses some components that are from the global context. So you can already think or ask yourselves how to actually make it small if it reuses components, but more on that in a moment. And channels are loaded according to single SPA rules, but they provide their own versioning mechanism, and they extend default lifecycle methods. So essentially, first, you load a special file that is called channel hub that presents you the version of the app, and then based on this version, which actually follows Semver version, you load a second file that is already versioned. So let's say that you have cards app, and cards are currently in version 1.1. You first go to a super small file that has like 5 kilobytes or even smaller that tells you, hi, the newest version of cards is in version 1.1. Go to this particular resource and download it. So that's how we support versioning. So essentially, if you want to run older version, the only thing you have to do is to replace channel hub with older version, because all of the build versions will be there already. That's more or less how you can describe it in Graph. So you have user data that is loaded by Vodeno platform. Then you filter channel config using those rules. So you decide which channels should be loaded. And then you load all of the channels and prepare a common message bus for them that we call intents. About loading channels. So the scenario goes like that. First, you get this is scenario for single channel. So we already know which channels should be loaded for this user. First, we present entry with version info. As I mentioned, this is called channel hub. Then we use this version to find channel entry point. And what you do at that point, you just load a string. You load pure string that is essentially a JS file. Then you parse it asynchronously in Frontend. You attach it to your browser window. And then when it's finally parsed, you start loading that. So based on route mapping, you check if it's already needed. And if it's needed, it's already bootstrapped. But we usually don't need all of the channels to start the app, only the dashboard ones. And after it's loaded, of course, we launch all of the lifecycle methods using single span. In order to achieve that, we have a custom create React app build pipeline, which essentially adds those two channel entries, channel hub and channel entry, instead of having like index.js or whatever Webpack would do by default. And it actually duplicates the libraries. So whenever we put something in package.json in a peer dependencies, it will get removed from production build, and it will assume that those libraries are available in window context in a particular environment. So thanks to that, our apps are really small. If we don't duplicate libraries without need, our libraries can be, I don't know, a couple hundred kilobytes big, apart from one that actually performs all the chunking, providing, etc., that makes sure that we inject all of the libraries only once. So you have one instance of UI components, you have one instance of business and React utils, etc. And this is actually a custom fork, which is right now a fixed version. We update it from time to time. It might be problematic long term, so right now we are considering to switch to one of the libraries that allow you to use the latest Create React app without ejecting it, and update built on top of that. So Krakow or React Rewired or similar libraries. And now the star of the show is the orchestrator, the platform that allows you to glue all of this code together. This is actually where all of the custom stuff related to Create React app and single SPA Microfrontends live. So it's framework agnostic orchestrator. It doesn't have React apart from displaying some simple stuff about like chats for client, etc. But it doesn't have any real templating, let's say, real front-end UI front-end. It has the config for all the channels, and it decides which channels should be loaded or available. Apart from that, it creates a common ground for communicating between channels, and this is the place where the libraries reside. So it allows for this deduplication because this is the provider for the libraries for all the context. And it's built in almost the same way as other channels. We still use our custom Create React app here, for example, for deduplication, but it doesn't have real React. And it's a bit like a standardized orchestrator, you can say. It's not actually a critical part of the app in terms of having its own logic. It just takes care of, for example, logging in, logging out, and session control in web context. So the lifecycle of platform goes as that. First, you get customer data. And if you're in mobile, you get it directly from mobile. So it's super fast. Thanks to that, you don't see any kind of preloaders when getting this data. But in web context, it's usually just traditional API call to get the basic data. And then we determine things like language and channels that should be loaded based on customer context, based on customer segment, for example. And then for each channel, we check the hub version. We perform redirection if needed. For example, if you entered the app from deep linking context from push notification, and then we prepare the main app that happens usually later. So it's more or less platform-centric logic. So what platform actually does is, first thing, logging in, logging out. This concerns only web. So in mobile, it's mobile that does it. In web, we have custom login, logout page. We use some really fancy cookie stuff out there, HTTP cookies, etc., and some OPEC tokens to make sure that it actually works in web the same way as in mobile. Then we have session control, so things that you can know from other banks. For example, mBank, when you don't do anything with your app, it will just log out whenever there is no direct interaction with the screen. And deep linking, so essentially whenever you get push notifications, that thing that we are implementing right now, whenever you have push notification that, for example, tells you, oh, this card has some problems, you can click on it and it will redirect you to a particular app. And apart from that, some support code, tracking and handling, and things that should be instantiated only once. So intents are our way of communicating. So intent is essentially a message that tells you, I want to do this stuff right now. So it's a transparent way of communicating with platform and channels. It's generic. It's not targeted at a particular channel. It only tells you that you want to do something. So you can, maybe there is a possibility that there's no recipient right now for this message, but it will appear in a moment. And we can do it thanks to RxJS. We can push whatever message we want out there and then subscribe to it in another context. A hub is something that is shared across all the channels, and this is the thing that actually allows you to send intents. So it's a class that is being extended every time when new channel is getting added, and it has all the means that allow you for sharing user data locally, intent handlers, etc. And it also tells you when particular channel should be activated. So what about the size? So the problem is that you want to keep it as small as possible. And we can achieve it thanks to this customized Webpack pipelines. But apart from that, we are trying to keep each of the channels as small as possible. So there are a few approaches to that. First is having this Webpack custom pipelines that we have. But another one is we actually use the fact that in JS, every import is a singleton. So we can have imports used in a standardized way in the apps, but they are, and we don't have to worry whether this is a real import from your local node modules when you're working on the project, or in production is just pure dependency that was cut out of the project and used from the window, because it's the same for the developer. So you don't have to worry whether you are working with the local library or general library. The only problem is that you have to remember about versioning. Okay. So the last thing, just 3 slides about common problems, and I'm done. So first thing first, how to switch between the channels, how to make sure that you don't see widescreen when switching when another channel is loaded. What we do, we actually hold the previous channel for as long as needed and wait.
No, I'm sorry, but we're running out of time. We have to wrap up everything right now.
Okay, I have just I just have 2 more slides about common issues, so we can skip those. Okay, so thanks for having this opportunity to talk about the system. If any of you is interested, feel free to contact Vodeno. We are constantly looking for passionate people to build our infrastructure with. So if you felt that it's something for you, feel free to contact us. And yeah, that's all.
Okay, thank you. That was very interesting. And here we can go to our next presenter. Here is Facundo Giuliani. He will be talking about Jamstack. Here you can take over right now.
Sure. Can you hear me?
Yes, we can hear you.
Okay. Well, thank you for the opportunity. My name is Facundo. Today we will talk about the Jamstack. We are going a little bit back to the roots of the web development and web design. I'm a software engineer from Buenos Aires, Argentina. I work as a lead web developer at multitracks.com, a company from the United States, a music company. I'm an Auth0 ambassador. Auth0 is a platform that offers authentication and security solutions for your application, and GitKraken ambassador, which is a graphic user interface for to handle Git. The talk is not related to those 2 products. If you want to talk about them, we can chat in these channels. My web is fgiuliani.com. My Twitter handle is Facundo Zurdo, and my GitHub page is fgiuliani. So let's start from the beginning. A long time ago in a galaxy far, far away, this is the only reference that I will use related to Star Wars. But yeah, there was many years ago, there was this guy, Tim Berners-Lee, a British scientist, that at the beginning of the 90s, he created what we know today as the web. I mean, the World Wide Web was created by him. This was the first web page creator in the history. If you go to the URL that is in the bottom, you can visit it. I mean, it still exists. It was an HTML document with text and hyperlinks to other text documents with no style at all, no interaction more than that. But well, I mean, it was a good first approach, sharing documents through a network between different computers, it's a good step. But the humankind and the human being always want more and more. So this was not enough, and we wanted to, let's say, add style or add colors or I don't know, change the format of these documents. So we wanted to create beautiful pages like this one, and to do that, CSS was developed, Cascade Style Sheet. It's a system that adding to the markup style, like the font, the format, the color, the text alignment. So now we were able to make our HTML document richer. But what we also wanted to do is to add some interaction or to add some animation to our pages. I don't know, things that have movement, or if I click in a place, I got an action. And to do that, we needed a new programming language. A new programming language was created. Brendan H. created JavaScript, what we know as JavaScript nowadays. It was a simple programming language, not too complex to other programming languages that existed at that moment and were used for desktop applications, for instance, because the goal of JavaScript was not to create a super complex algorithm or application. It was to give interaction and movement to our pages. So with the creation of JavaScript, we were able to make pages like this one. Space Jammy is the movie from the 90s, and the page is still alive. You can go to spacejam.com and visit it. But with HTML documents, adding style with CSS and adding action or interaction with JavaScript, we were creating like rich websites. But besides that, they had movement. These websites were known as static web pages. And why is that? It's because they were web pages that were delivered to the user exactly as they were stored. I mean, if we have a page that is an HTML file, a CSS file, and a JavaScript file, it doesn't change depending on the customer that or the user that is browsing our site. We will always deliver these static assets to all the users browsing our application or our site. So that's why they are called static web pages. But as you know, or you can imagine, we wanted to add more behavior to the pages or generating different content depending on the user that was browsing the page. So that's where the idea of dynamic web pages came up. A dynamic web page is where some of the content is generated dynamically and when needed. What it means is that we have a browser, a user browsing our site. He makes an HTTP request, and our web server will generate a dynamic document. Well, it's not a dynamic document. It's an HTML document as static as the ones that we were seeing before, but the generation of this HTML document is dynamic. I mean, the web server grabs files, static files, CSS, JavaScript, or HTML templates, and with some calculus or some operations and grabbing information from different sources, like for instance databases, the web server is able to generate a brand new page for the user that is browsing our site. So in this scenario, we were using other kinds of tools, which is these programming languages. They are called server-side languages. Many of them are used nowadays, like Python or Java or PHP. They are different programming languages that enable us to create dynamic pages for our users. But this type of dynamic pages, like for instance the eBay portal, I mean, you were able to browse the eBay portal, purchase products, purchase services, and it was depending on the interactions with the user that was browsing the page. This type of dynamic pages were known and are known as server-side rendering, because the HTML content is generated by the web server. And why are we saying this? Because with the years, new technologies appear and Ajax appear. Ajax is a group of technologies and techniques that are used to make asynchronous requests to the web server to get information, and with that information generate dynamically HTML content inside a web page without having to reload the entire page. So this is where JavaScript got more complicated, because we needed more operations and more features to be able to do that. But using JavaScript, being able to call to web servers or APIs, do some operations and receive data again, and with that data generating a dynamic HTML inside a page without having to reload that page. And with the new features that we were adding to JavaScript, new tools, new frameworks, and new libraries started to appear, like jQuery or Ember or Backbone. And a new concept or a new idea appeared, and was that, why do I need to ask for a new web page to the web server whenever I want to do a new operation? Or why don't we use Ajax like in a deeper way, and we generate the complete web page or web application? At that time, they started to talk about web applications, because we are not talking anymore about static assets or portfolios or I don't know, things that they didn't need any kind of behavior. We're talking about applications. You can do anything now in the web. I mean, you can have a control panel, you can have a database and manage that. And what they were asking is, why don't we use Ajax and JavaScript to generate the complete application inside the web page, but using the client browser and the client processing? So that's where Angular, Vue.js, or React or frameworks like those appear. And a new concept was delivered, the single page application, which is a web application that interacts with the user, dynamically rewriting the current page with new data from the server. So what we are doing here is, we have a web page that we load, and when we loaded it for the first time with JavaScript, we will operate and generate dynamical content inside that page without having to request for new pages for the web server. This technique is called client-side rendering, where the HTML content is rendered directly in the browser using JavaScript. Let's recap these different techniques that we mentioned and see their pros and cons. For instance, the client-side rendering has as pros that we have a richer interaction, because we don't have to request a new page to the server whenever we want to do anything. After the initial page load, where we loaded all the HTML documents, the CSS files, and the JavaScript files, the rendering of the page is faster because it's done in the client side. We will have a lower load in the server because we are not generating dynamically HTML pages in the web server. We are just requesting like a structure of a web page to the web server, and we are generating the application and the page in the client side, in the browser. And another advantage is that we will be able to reuse user interface components. So for instance, I want to update only one part of my web page and not refresh the entire page. We can do that with Ajax, with JavaScript, and we don't have to do another full page load. But some cons, for instance, are the slower initial page load. That is because we have to load the HTML content, the CSS content, and the JavaScript content with all the libraries, with all the frameworks, just to start operating with our page. And maybe the loading of all this JavaScript code is quite slow, and we have to wait until that is ready to display the web application and it to be ready to be used. Another concept that I didn't mention before is the SEO, which is the search engine optimization. The search engines that we know as Google, for instance, they use crawlers and robots that analyze and parse our websites and its content. And depending on the content and the meta tags that we use and some information that we add to our sites is how better results of search our pages will have. The thing is, if we generate the complete application in the client side using JavaScript, we won't have any code to parse or any code to analyze from the for the search engine robots or search engine crawlers. Now, Google, for instance, it supports JavaScript and this kind of rendering, but it's not as performance as the server-side rendering. And one last concept is that we will depend on many external libraries. Again, Vue.js, Angular, React, they are JavaScript libraries that we depend on. We need them to work correctly, and we have to create some code, sometimes opinionated, depending on these libraries to create our applications. On the other hand, the server-side rendering has some other pros because the initial page load is faster because we don't have to wait until the JavaScript files are ready to use the page. We will have a better SEO and social media optimization, the same that we mentioned before. The pages are more secure because we have more code in the server side, not visible for the user. If we add code in JavaScript, you can inspect the JavaScript file in your browser, but if we use code in the server, you won't be able to see it. And we will have a lower load in the device of the user. I mean, the computer or the mobile phone will need less operations to make. Then we have some other cons, which are we will have busier web servers because for each request that we will make, the web server will have to make operations and generate our web page. The slow page rendering overall is slow because the same. I mean, we have to request a page. For instance, I live in Argentina and I want to see a page that is stored in a server in Australia. We have to make our request travel to Australia, get the page, render the page, and return the HTML document, and it will be slow. We have to do a full page reload after it route change. And last, the page is viewable sooner, as we mentioned before, but it's not interactive. So maybe we don't wait for the JavaScript files to be loaded, but we will display a page to a user that maybe the user will click in some places and no behavior will be executed because the JavaScript file didn't load at first. So considering these conditions of the client-side rendering and server-side rendering, a group of guys went one step forward or backward, and they wanted to create beautiful sites like this one we saw before. Well, this is not the case. Well, this is not the case, of course, but you got the idea. I mean, they wanted to create sites like these ones and getting the advantages of static websites, which are a lot. If we consider static web pages, they are static assets that are living in a web server, and we don't need any dynamic generation of markup, neither in the client side or the server side. It is faster, it is cheaper because we don't need expensive servers with platforms and software to generate the pages. It's easier to maintain because we are just leaving static assets in a server, and that's all. They are more secure because there's no code being executed. I mean, if you request a static asset, there's no code being executed. You are requesting a file as it is stored in the web server. So as someone said one day, there's no code more secure than no code. So in this case, if we don't have code, that's the most secure idea that we can handle. They are easier to scale because you don't need more potential in your server. You just need more space in the disk, and they are stable because they are already generated files. And having all these benefits of the static web pages in mind, they came up with this concept, the Jamstack. What is the Jamstack? The formal definition is that it's a new way of building websites and apps that delivers better performance, higher security, lower cost of scaling, and better developer experience. If we stop in the name a little bit, we will see that the Jam comes from the J from JavaScript, the A from APIs, and the M from markup. But okay, that is the formal definition, but how do we achieve this cheaper sites, more secure sites, and with better performance? So there are a couple of principles, well, 3 principles that the Jamstack needs to follow. We need to be generating cacheable static assets at build time whenever is possible. So it is not that we will create the static assets and pages manually, one by one, but we will have solutions using different programming languages like JavaScript, for instance, or Go or Ruby, and creating applications that when they are built and compiled, we are generating static assets instead of generating dynamic pages that are generated on the fly. The other principle is that these static assets should be deployed to CDNs. CDNs are content delivery networks, and they are networks of servers that they are called nodes that are positioned in different geographical places. And when you request a file, a static asset, to these CDNs, you will get the file server from the closest node where you are. So the assets that you deploy to these CDNs are deployed and they are replicated in all the nodes. So for instance, I'm in Argentina and I create a site and I deploy it to a CDN. The page will be, these static assets will be distributed in all the nodes of the CDN. And if a guy in Australia wants to browse to my site, maybe he has a closer node to get the static assets and not having to request to a server in Argentina and the request traveling all that distance and taking all that time. And another principle is that we should use client-side JavaScript to call third-party APIs and serverless functions for dynamic interaction, and data. We don't have to worry about server-side rendering. We shouldn't have any web server with server-side rendering. We just need static assets with JavaScript code, and the JavaScript code will be the one that we'll call third-party APIs or APIs that we created ourselves to do all the dynamic part of our website and generate the dynamic content of our website. Or maybe serverless functions, which are functions, well, that is server-side code, but we don't host that code in servers that we have to maintain. We have platforms that allow you to create serverless function, and you just have to worry about the code of your application and the functions that you want to create. You don't have to maintain any kind of server, any kind of load balancer, any kind of caching platform. This will be handled all by the company that is offering the serverless function service. So with these principles, we're arriving to the way the Jamstack works, which is we have a build system with a content integration and content distribution system, and this system will generate static assets whenever we build our solution. But how is this done? I mean, this is not done manually. We will have all the code of our application living in a repository, for instance, a GitHub repository. And whenever we make a change to that repository, this build system will be automatically executed. So for instance, whenever you create a pull request or you push a commit to your repository and change some files in your application, this build will be automatically executed, generating static assets and delivering these static assets to the CDN where we will offer our application. And if we want to use dynamic content, we will have APIs available to be used. So to do that, we will use different tools that were created in the last years, because these static assets have to be generated in a certain way and getting data and content from certain sources. So the first tool that we will talk about is the static site generator, which is a software that produces and deploys a static website using data sources and templates. What does it mean? Is that we will have different data sources like a database, APIs, third-party APIs, HTML templates, templates done in other programming languages, or maybe content management systems where we load or we create content related to the entities that we will handle in our application. This static site generator will grab all the data sources, will build the solution or execute the project, and will generate our website, which will be static assets. And these static assets will be deployed in the CDNs or the CDN where we want to our page to live. We have different types of static site generators depending on the language that you want to use. For instance, Next.js or Gatsby are static site generators that uses React, the framework React. Nox.js uses Vue.js. Jekyll uses Ruby, for instance. And depending on the programming language that you want to use, you will you have many static site generators available to evaluate and to select. These static site generators will again, using all the data sources, they will generate static assets. But what is important is that they will generate atomic deployment. What is that? Is that when the static site generator executes the project and compiles the code of our application, we will analyze all the possible errors that we will have. If we have errors, well, you won't be able to generate the static assets. But if you don't have errors, we will generate all the static assets that we need for a website. At that time, we will deploy the complete web application to the CDN. I mean, we have to wait for all the static assets to be ready to deploy to the CDN. We can't do a partial deploy of our application. And that is because we want to have some security that everything will work and we don't have different version of our files. So the atomic deploys is an important part of the Jamstack too. As we said, these static site generators use different data sources. One of them are CMSs, which are content management systems. They are applications or set of related programs that are used to create and manage digital content. You may have heard of them. You may know some content management system like WordPress, Joomla, Drupal. They are cool platforms that offer a backend part where the user can create content and, I don't know, add articles or entities or wherever the content you need for your website. And on the other hand, we have a front-end part, a presentation layer, where we expose that content, formatting it as an HTML document. The problem of these platforms is that you are tied to their opinionated way of generating the HTML content. So for instance, if you create content using the WordPress backend, you are tied to the WordPress presentation layer for our site. So you have to use PHP and you have to render the HTML of your site using WordPress. You don't have any alternative. So this other idea came up with the Jamstack, that what happens if you need, or if you want only the backend part, you want to create the content for your site, but you don't want any presentation layer, any fixed presentation layer. You want to create the presentation layer as you want, using the language that you want and the format and the style that you want. And that's where the headless CMSs appear. They are a headless CMS is a CMS where the content repository is separated or decoupled from the presentation layer. So in this case, we will be able to use a platform. I don't know, that maybe we will host in a server, or we will use a web platform, existing web platform, to create the content for our website, but we won't have any presentation layer tied to it. So we have thousands of alternatives, not thousands, but there are a lot, really a lot of headless CMSs to select. They offer different types of storing our information. For instance, some of them keep a database and they expose the content that we create using APIs that we can consume using the static site generators. And the APIs return JSON objects that we can use in our applications. Or, for instance, other headless CMSs store the content that we create as markdown files, markdown documents in the repository where our application lives. That depends on how you want to store your information or how you want to use it. And another factor that we have to evaluate when selecting or evaluating headless CMSs is the cost, of course. They offer different layers that, depending on the platform, you have a free first tier of service, and then if you make your site bigger and bigger and you need to grow on how you are creating the content, maybe you have to pay more. Well, that's something that you have to evaluate at the moment you are creating your site. But the point is that you will be able, and you will have a platform available to create content not tied to any presentation layer. And the last component of the Jamstack that we will mention is services that allow you to build, to deploy, and to host your site. These services are platforms that allows you to automatically execute the static site generator whenever the code is changed in your repository, in your application repository. And the services execute the static site generator. They generate the static assets. They deploy the static assets to CDNs that they maintain. I mean, they are the CDNs are property of them. We have different options for that, but all of them follow the same idea. You have a static site generator that we execute. We have static assets. The static assets are automatically deployed to the CDNs, and they are hosted and available there to be browsed, and your website is alive. This is because we don't want to do any manual task whenever we have to deploy our site. That's only, I mean, if you see the workflow is super simple. The programmer codes the changes or add some changes to the web application. When those changes are added, automatically we are generating a version of the website with static assets that are deployed to CDNs to make our site already available for any person that want to browse the site. And that's the cool part. I mean, with tools that where created in the last years, we are going back to a concept, an old concept, which is the static web pages. And as we mentioned before, you have other, if you want to generate dynamic content in your page, or if you want to do operations, you have a lot of third-party APIs that are already created and are available for you to use, and you don't have to worry about creating anything from the ground. For instance, if you want to create your own code, you don't have to worry about the maintenance of the server. You can use AWS Lambda or Google Cloud Function, for instance. If you want to create a form in a page, you have FormSpree, Netlify form. If you want to create a database that exposes an API, you have FaunaDB. If you want to manage the authentication and identity of the users that browse your page because you want to only allow the access to certain content to certain users, you can handle that using, for instance, a platform as Auth0, which is a very cool platform with multi-login, and you don't have to worry about anything. I mean, they offer you the login page and the interaction with your application to handle the authentication of the users and the authorization. I mean, the different roles, and you don't have to create an entire security platform for your application. You have search engines like Algolia, for instance, or e-commerce platforms. You don't need to create an e-commerce from the ground. You have a platform already built and created that you can use. And what I want to stop here, because you can't create the platforms or the services by yourself, but you have other companies that create these services, and it's their point. I mean, they are specialists in what they do, so they care about that. And what I mean, if you want to consume a service, you want to consume it, or you want the service that is created by the best people doing that. So maybe you can create, for instance, an authentication platform, but it won't be as good as a platform created by a company that the only goal of the company is creating an authentication platform and the best authentication platform. You will choose which is the best authentication platform, of course, or the best comments platform, for instance. But the point is that they focus on that, and they create products focusing on that and not in many things. And you don't have to worry about these aspects, and you can spend your time creating the rich content that makes your web application different from the other ones. So that's the point of using third-party APIs. So to finish the presentation, we will consider some pros of the Jamstack. As we mentioned, some of them are related to the static assets and the static web pages. We will have better performance, more security. They are easier to scale. We will have better SEO because they are static pages. The servers will be cheaper because these CDNs that are optimized to serve static assets are cheaper than maintaining a web server with a software platform to generate dynamic content. We will have better caching because caching static assets is always better and is always more reliable than caching a server-side rendered page. And what is also good is that we will have a better developer experience because we are using new tools and new workflows to generate static sites. But we will have some problems. I mean, as we are using a lot of third-party services, we will have a different cost to evaluate. For instance, the CDNs that we will use or the platform to deploy the site, or any API that we are using at build time, or the headless CMSs, and we will have to evaluate the cost of the different alternatives and trying to, I mean, to make the best effort there. We will have external dependencies for the same. I mean, we are depending on platforms created by other companies. The atomic build or the atomic deploy that we mentioned before, if your site gets bigger and bigger and you keep adding pages to our site, the build time will increase, and that's something that we have to consider. And the last point is that maybe we will have these CMSs, but we have to see how's the best way to make that easier to use for the content editors, because maybe it's easier from a developer point of view, but we need to make it user-friendly for our editors to create the content. So again, the Jamstack is a new approach, a new paradigm that we can use to create our new web applications or to refactor our existing web applications. And maybe it's not the best solution for all the problems in the world, but it's a good idea to follow or to try and to see if we can improve our websites and our web applications, or make new web applications more performance, more secure, cheaper, and with a better way to scale them. So thank you very much for this opportunity. These are my social networks, so let's keep in touch. And well, again, thank you very much.
Thank you, Facundo. That was a great presentation. It's amazing to see how far things have gotten. And thank you for your time.
Thank you.
Please welcome our next guest, Horacio.
Hello.
Hello. You can take over from now.
Okay, great. I am trying to share my screen. Wait a second. It's going to work. Yeah, it's going to work. And let's try to switch into presentation mode. So thank you very much. I am really happy to be there today for this Devfest Poland. I would have loved to be there physically, as everybody, I guess, but this year is rather special. So let's try to do a dynamic remote presentation. Let me begin by introducing myself and introducing the company I work for. My name is Horacio Gonzalez. As you can maybe hear, I am a Spaniard living in France, so my English accent combines the worst traits of Spanish and French. Sorry in advance about that. I am rather involved in the local developer communities. I also organize a Devfest, Devfest Debut du Monde, and I am Google developer expert in web technology and Flutter. In my daily job, I work at developer relations at OVH Cloud. I don't know if you know OVH Cloud. I would like to think that you know we are one of the global leaders in the cloud and hosting. Yeah, we are smaller maybe than our friends from the Silicon Valley, but we are the top European one in the game. We are a French company. I will talk later about that. And we have data centers and customers all around the world. We have office all around Europe, in Poland, in England, in Spain, in Italy, in Germany. And we have a strong link to Poland because our founder, Octave Klawa, is Polish and his family comes from Poland. And we have a data center in Warsaw and an office in Wrocław. So this talk, why I submit this talk? Yeah, because I submitted because I was angry. I was angry because I have been talking about web components for 7 years now. I began with the first public beta of Polymer, and I began to build things with it. I put things into production with Polymer in 2014. I was one of the first one, and I talk a lot about it. Hey, web components are wonderful. They are a revolution. They are going to change the way how we develop web applications. They are great. And I have been doing that year after year. You are going to be able to build your web application brick by brick. You are going to be able to share your code. And then last year, in a talk, somebody asked at the end, hey, guy, so it is 2019 now. What is your revolution? On even worse, several months later, another one, a real troll in real life. Hey, dude, your web component revolution is a bit like Betamax. You remember, they are maybe better technically, but nobody used them, so they are going to lose. In fact, you have already lost. And I really felt that I thought about that. Were they right? I was wrong. And I decided to do a talk to explain why this vision is rather simplist and it is very far from the truth. So right now, if I were there in the room with you, I will ask you, how many people know web components? And I guess that half of you would lift the hand. For the others, let me explain in 3 minutes. What are web components? Web components are a web standard, a W3C standard, implemented in all modern browsers, Firefox, Safari, Edge, Chrome, and with polyfill for older browsers. And they allow you to create your own HTML tags, encapsulating the behavior and the look. And then you can take those tags and use them everywhere, in any framework, or even without any framework. Why? Because they are a standard and because your browser knows this standard and implements it. They are based on 3 pillars. First one, custom elements, is the part of the standard that allows you to define a new HTML tag and tie it to a JavaScript class. Shadow DOM is the part of the standard that encapsulates the CSS, allowing you to define the style of your component inside the component, and that style doesn't bleed out to the outside, and it shields the component from outside the styles. And template, it allows you to define the look of your component in the DOM tree without instantiating until you instantiate the component. Okay, so many concepts. What you need to remember, you are creating your own HTML tags, and you are using them like you use any HTML tags. They have attributes and properties, they have methods, and they emit events. And all that are plain old standard HTML, CSS, attributes, properties, methods, and events. So you deal with them like you deal with a div, a p, or a span tag. So Betamax, VHS, hey, what are you talking about, old man? Yeah, I begin to get old. If you don't remember that, let me do a crash course in the 80s. At the beginning, in the 60s, TV was everywhere and everybody loved the TV. And people wanted to keep their shows forever. So the first one to give a solution was Sony with the VTR, video tape recorder. It allows you to record half an hour of television into a magnetic tape. It was bulky, it wasn't very reliable, but it existed, and people were able to store their favorite shows. We were in the 60s. In the 70s, Sony created the first VCR, video cassette recorder, the Sony U-Matic, with a U-Matic cassette. Hey, it was a real revolution. No more tapes that you could break or lose around. No, everything was encapsulated inside a cassette, and they worked really well. Okay, for half an hour or 1 hour of recording, but it was already nice. And then 2 companies released the next generation, 2 wannabe standards. First one was Betamax by Sony. The other one was VHS by JVC. They were cassettes, but the format was different. And they began a format war. The market wasn't big enough to having all movies released in 2 different competing formats. If you want to know more about this bloody war, there is even a Wikipedia page. Betamax on paper was better. It had better recorders, better resolution, better sound, better image, but it lost. It lost, and VHS won the market. Why? Well, there was many articles in journals and even in books about why did Betamax lose. In fact, one thing is, in this kind of markets, there is only place for one standard. For example, when the DVD arrived, the Super VHS format was replaced in several years. But why did it fail? Everybody thought Betamax was superior. The press, the public. But it was much more expensive. Not only the cassette, but the VCR, the video cassette recorder. It cost several $100s more, and people wanted to have something affordable. And also Betamax had better quality, but only 1 hour recording time. VHS had 2 hour recording time, enough for a movie. But the thing that really was against Betamax is that Sony didn't put it as a standard, didn't license it. And JVC, the first thing they did was to license the format. They made a standard out of it. And so you had other makers, Panasonic, RCA, that did VHS, VCR, and cassettes. So you had a lot of choices to buy your VCR and to buy your cassette, and only one for the Betamax. So, are the web components the Betamax of web development? They are a perceived superior alternative, but it is going to fail? Well, for me, it is almost the opposite. They are the VHS. Why? First, the compatibility. If today you are a React developer, you are going to do React components, and they are going to work really nice. But what about when tomorrow in your next project, they are going to ask you to do Angular? Well, you won't be able to use any of your React components. With web components, you write them once, and you then use them in React, in Angular, in Vue, or even without any framework. If you have been web developing for 7 years, you remember the AngularJS to Angular switch several years ago. Everybody loved AngularJS, the first version. Everybody has done lots and lots of code, and then Google said, hey, people, we have a new version. It's going to be called different. It's going to be called Angular. Okay. It's going to use another language, TypeScript. Okay. And everything else also changed. You won't have directives, you will have components, and you will have that, but you will have this one. And okay, you take your old application, you put them in the trash bin, and you begin anew. It's the same thing, almost. Well, it was like that. It isn't even a caricature. Lots and lots of companies put all the base code in the trash bin and begin anew with Angular. But not even that. As I told you, maybe your next project in your company or in the company you are doing consulting for will use another framework. And what are you going to do? You are going to code again and again the same components in different frameworks. Yeah, I have the React version. It doesn't work in Vue. Oh, I'm going to do the Vue version. Rewriting and putting your code in the trash bin. You aren't sharing your code. And that is a problem, because if open source movement has shown us something, is that sharing is really the best way to having superior product. Why are you spending time coding again and again the same business component in different framework? With web components, you could use Angular or React or Vue for your web application, for the navigation, for things like that. But if you code all your business logic in web components, you are going to be able to reuse them in any project, in any framework, in a clean, standard way. So yeah, web components are indeed a revolution, but they aren't a noisy revolution. They aren't saying, hey, you stop doing React now, Angular is dead now. No, they are offering new possibilities to those developers to be able to code things that they will be able to reuse. It's a silent revolution. It's a silent revolution, but it is there in sites you use every day. When you embed a tweet, Twitter embedding is a web component. When you use GitHub, lots and lots of brick are web components, but they are inside this application, silent, simply working. The component architecture also was another subset of web components. Nowadays, all frameworks have a component approach. They aren't doing the sharing part yet, but the component architecture is already a big step up in the web. So web components, as I told you, are now part of the web platform, are a standard. And not even that, because they are everywhere. As I told you, they are even in the space. In fact, several months ago, SpaceX launched the Falcon, the first human-piloted rocket from SpaceX. And the user interface of the Falcon was mainly web application running on Chrome. And those web applications were using web components. Yeah, why? Because they are a standard, because they aren't tied to any framework. So yeah, web components are even in the space today. But okay, so web components are great. So why are there are so many competing libraries? It doesn't a problem. It doesn't show that the standard is a mess. Well, again, not really. The web component standard is a low-level standard. They are the foundations. And it's a good thing that, because they allow you to use the standard in many different ways, adapted to many different situations. The standard, they are the basic bricks of your building. It defines some APIs, how to define elements, how to encapsulate the DOM, but they don't force you to code in a way or another. And the libraries are helpers that give you higher level primitives that make you able to code web components in a quicker, in a faster way, when you are using something compatible with the library. Libraries are opinionated. The standard is a foundation. So you can have the best of two worlds, a library suited to your needs and a standard allowing you to write your components or your library in a different way if needed. Every library is aimed to one kind of use, one kind of coder. Hey, this one is made for people used to React. This one has some elements taken for Angular, and that's nice because Angular developers, we find libraries like Polymer or Little Element easier to learn than Stencil, and React developers will prefer maybe a Stencil because it is more similar to what they are used to. And that's nice. All these libraries share the same base. So all these libraries allow you to create web components that are compatible with the standard, compatible with all of them. And this foundation is fast and efficient. So the libraries, they aren't a bug, they are features. They happen by design. I am going to talk about several libraries that for me are great examples of what you can do with web components. The first one is Stencil. It's the library powering Ionic framework. Stencil, it isn't a sample library. It's more of a tool chain. It allows you to create your web components and compiles them to a vanilla web components native one without any external library. So you take your stencil component, you use the stencil compiler, and then you have web components without any dependency, small, fast, efficient. It's a mature technology. It powers Ionic since Ionic 4, so the new Ionic 5 too, and it allows them to build all the Ionic framework, but it isn't tied to Ionic. You can use a stencil for your own project, as many open source projects do today. And it's a good example because Ionic, they really lived the AngularJS problem. I told you, they wrote the first version of Ionic in AngularJS, and then they had to put that in the trash bin when Angular arrived. And they spent 2 years doing the second version on Angular. But, when they released the second version, Angular wasn't as popular as AngularJS. Only 1 out of 3 developers did Angular. So the wonderful framework wasn't usable at all for React or Vue developers. So they decided to put the code again in the trash bin and code a new version. And this time they decided, hey, we don't want to do it every 2 years. We want to build a new version that works with any framework, present or future. And in order to do that, we need to do something standard. So they decided to create their Ionic 4 based on web components. And they looked at all the libraries and no one had all the features they wanted. So they coded their own library, Stencil. And it really worked. It worked very well for them, but now it works really well for the global web component community. It has very interesting features, asynchronous rendering pipeline. It is written in TypeScript. The rendering is done with JS6. They have daisy loading. They have server-side rendering, component pre-rendering. Server-side rendering, as I told you, is one of the best features, and it is fully featured out of the box. But the most important thing, it builds all that over the standard, over the web platform. It doesn't change the native DOM event with stencil events. No, it fires normal events. It uses attributes and properties. So this allows it to be as close as the platform as possible, taking advantages of every inch of performance in the browser. It works with the web, not against the web like other frameworks. Another library is Polymer. It's an old player. It was the player that began the game. Well, it has evolved. Last time, 2 years ago, Polymer 3, it was a nice evolution, yeah. But what about today? Well, there are many applications that use Polymer components, and they work, and they will continue to work. But what about the Polymer project? Well, it's complicated because the library is deprecated, Polymer library, but the project is still alive. I mean, it deserves some explanation. Let's go look at the Polymer history. At the beginning, Polymer was built when browsers hadn't the same capabilities that today. There was no web component support in browser. There was almost no modern framework. It was the jQuery time. So many of the innovation that the framework has created weren't there. So they had to build everything from scratch. And today, many of the things that are hard code in the Polymer library are already a standard in the platform. The state of art has evolved. And they aren't suited to the current war anymore. So the components works again, but it's a bit of a pity to code new things on it. So what the Polymer people did, they learned from their lessons. They released a last version of Polymer library, Polymer 3, and they decided to build the next thing. So, Polymer, as we know, it's dead. But the Polymer project is indeed alive. And I have spent 6 years coding Polymer components. It wasn't bad for me? No, not at all. I have several catalogs full of web components that still work in any web application I want to do today. And slowly, when I have time, when I create a new one or when I modify one, I switch then to a new library, but they still continue to work. And that's the beauty of web components. I can do a migration at my own pace without having to put any code in the trash bin. I can keep using my Polymer components, but for my new one, I use a better, more modern alternative. And the project Polymer is alive. It is in the library. And they have created the one that for me is my current favorite, Lit Element. Lit Element is a new, this is the spiritual hair of Polymer. It's a very different beast. It's a modern web components library. It's very light, very efficient, and very close to the platform. It's based on a small library called Lit HTML. It's a library that allows you to create quickly and efficiently HTML templates using a little known feature of JavaScript called tagged templates. I don't know if you know them. You know maybe the backcode strings in JavaScript where you can interpolate JavaScript variables. But do you know that if you put a name like here behind the backcode, it's called a tagged template in JavaScript. And it means that instead of simply processing the string, they are going to call this function, giving the string the values to interpolate, and then you can do anything you want in this function. It's an interesting function because HTML, Lit HTML allows you to create HTML templates in an efficient way. HTML backcode with JavaScript data, and it generates the DOM, but a template object that you can store, cache, and quickly, efficiently deal with. So, sorry about that. Templates are lazily rendered. I have a problem with my screen. I don't know if you can see me. I cannot see you. Wait a second. Trying to get back control of my screen. It's the problem of live performing. Sorry about that. Yeah, I am there. So you could say, hey, look at that. It's almost like GS6. Not? Well, not at all. Because that is fully JavaScript standard. You don't need any pre-processing, any build process to do that. No, you import the lit HTML library, and that is normal working JavaScript code. You need not build, not pre-processing, not bundling, not post-processing. You are working with the standard. And that is a bit different. So that's a lit element web component. As you can see, we import the lit element and we create a...
Excuse me, Horacio.
Sorry?
We actually lost your presentation.
Oh,
are you still
I'm
sharing
going
the screen?
to try to share it again.
Yes, please.
Can you see my image? Can you see anything?
Yes, we can still see and hear you.
Okay, sorry about that.
No worries.
The problems of live presentation. So let's try to share again. Please, Chrome, do you let me share? Are you seeing my presentation now? Not yet? Yes. Here we are. So trying to click on share. Wait a second, please. Sorry about that. My computer had a glitch, and that's a trying to get my computer to answer. So as you can see, while we are there, at the end you are defining a new custom tag, custom greetings. Loading, sorry. Well, the idea is, why it come back, the idea is you are creating a web component using standard JavaScript. No preprocessing, no building is really needed. In any modern browser, why it is allowing me to wait, it's still loading.
Hey, Horacio. Yeah, I think there is a little bit of problem with the network connection.
Trying to get it back online.
Horacio, are you there?
Google slide. So you are able to see me?
Yes, we can hear you so far.
Okay, and you can see my webcam?
For the time being, it is
You can see my
frozen.
webcam?
Oh, now we can, yes.
Yes. Okay, let's try to see how I can share my screen. How can I do that here? I cannot do that on phone. Wait, sorry about that.
No worries.
It seems on the phone I cannot. Trying to, I have reboot my computer. It should be going back. Sorry, it's the.
No worries. If you want, you can continue the presentation while we wait for it to be back online for the last 5 minutes.
I am entering the studio again on the other
Yeah, I am in the backstage, and I think I can. Yeah.
Mm-hmm. Mm.
Okay, I am there. And now, what about my presentation? Okay, after a reboot, it works better. Putting the presentation again in the Google slide. Sharing screen. Let's try. Here it's still loading. And I am sharing my entire screen. This time it will be better, quicker. And
Hey, Horacio, you still there?
And
Horacio, can you hear me?
and does it work? No, it doesn't.
Horacio, can you hear me? Horacio, can you hear me?
I am trying to get a solution, but I cannot share from the iPad. I cannot share from the phone.
No
and
worries.
The computer isn't loading my presentation. It seems it's got freezed.
No worries. Because there's only a couple minutes left, why don't you just share with us the final minutes of your presentation as a wrap up? Maybe just talk to us about it.
I am trying once again. Sorry. trying to do something different. Another.
Horacio, can you hear me?
Yeah, I can still hear you.
Okay, perfect. Yeah, I think there's a network issue. So because we only have a few minutes left, why don't you just you don't have to tell us. Why don't you just talk to us about the last slides of your presentation?
Yeah, I
That'd
have
be
a
easier.
big network issue. I think I am going. Not funny. Sorry about that. It's
No
something
worries.
should work, and it works well in my tablet and my phone, but they have nowhere to share the things over there.
Mm-hmm.
So, there's a quick reboot on a computer.
Okay.
If you want to, if you need to begin the new presentation, no problem. I understand.
Yeah, we're gonna move forward. Apologies about that.
No, it's apologies myself. It's really sorry.
Oh, no worries, no worries. It happens all the time. But thank you so much, Horacio, for the presentation that you did present to us. It was lovely, truly. So thank you. Thank you.
Sorry about that.
No worries. All right. Apologies for the technical issues, everyone. So up next, we have Tantoluwa Alabi, who will be presenting Styles Like Magic. Tantoluwa, hello, great to meet you.
Hi, nice to meet you too. Hello everyone, my name is Tantoluwa Alabi. Okay, I'm from Nigeria, which is in the West Africa. So I'm a front-end developer, and I'm the current lead of Shikode Africa, University of Lagos. And Shikode Africa is a community, women-centered community that empower ladies who are interested in tech. So I'm going to share my screen now. Okay. Okay, so I'm going to start now. So highlight of my magic. I call them magical because they make animation simple, short, and feasible. You know, we have many plugins for animations like anime.js, you have anime.css, and then you also have libraries that can make your work easier, and it comes out really nice, but they can be unnecessary heavy, and they can make they can load it slowly, and it may not come up well. It takes up space and slows productivity and all like that. So with few lines of CSS, probably like 5, I would show you a touch of my magic in animations. So there are a few terms you need to know when you want to start CSS animations. Basically, CSS is really powerful, and it can actually do a lot of things. Although CSS can really make people cry because code doesn't work and stuff like that. But then at the same time, it's really effective and it performs magic. So first, we talk of animation duration, and then it's a property that specifies how long the animation cycle should take. Since it's animated, it's up to you to decide what time. Duration is normally it's a time, yeah, and it's measured in seconds. So it can range from any desired second you allocate to it. And then, okay, the next one, animation name. So this property is used to specify one or more names of animation defined by keyframes. You need to name your animation. So yeah. So the next one is animation timing function, and it specifies the speed curve of the animation. And then there are like many other properties that are under it, like ease out, which can ease out, then ease in, then linear. Linear makes it start from left and then right. I'm going to show you a demo, so I've done like explain everything. So okay, the next one, you have animation iteration count, and it specifies the number of times an animation should be played, maybe decimally or whatever you choose. Then you also have animation delay. It defines when the animation should start. And then keyframes, you have keyframes, and it's a drawing that defines the starting and ending point of any smooth transition. Okay, so I'm going to open my code pen and then explain a few stuff. This is the demo of what I used animation for. So this is basically stars in a black background and then they're twinkling. So here's my code I used. I just used like simple divs and I went to the CSS. So first and foremost, I started with animation name. I gave it an animation name of Twinkle. I don't know how smart this is. Yeah, I gave it an animation name of Twinkle because this is how I'm going to use the keyframe to control it. Without the animation name, the animation can't work because I'll have to link it. Sorry, I have to link it down to specify the instruction there. Then you have the animation duration. That's like more like the time, how you want it. If I increase, sorry, let me. Okay. I'm sorry. So this is it, and I want to. Yeah. So this is the animation duration. If I increase it to like 3 seconds, and then I know that okay, this is what I. Yeah, this is what I changed, and it's slower. So it depends on you. You can either make it the higher you increase the time, the slower it becomes, and the less time you give, the faster it becomes. So yeah. Then I mentioned animation timing function. It determines the speed of the call. There are many other properties. You have linear, ease out, ease in, depending. I tried one with linear. I made the animation timing function linear, and then it's like it starts and ends. That's what linear is. It starts and then it ends. So okay. Then I have animation delay. Animation delay defines when the animation will start. So I'm going to add a delay here. I'm sorry about that. Okay. Okay. So it's whenever you add the property of animation delay, it slows down the animation. So it's up to you to put how many seconds you want it to be slower before it starts. So okay, I'll add it here. Animation delay of 3 seconds. So the one that is stagnant here has a delay 3 seconds. before it starts displaying the properties. So moving on, there is it's called keyframes. Yeah, keyframes. With the reference of the animation name, that's when you can now apply keyframes to the object and animate it. So any property you want, you are free to add it. I basically made the scale, this how it's blinking and coming on. It's a scale. I gave the scale of 0.5, and the opacity, how it isn't fading off. So if I give it opacity of 1, so immediately immediately it comes up, it fades. Then the next one is iteration count. Okay. I'm sorry, just a minute. So about iteration count is how many times you want it to bounce. So iteration count specifies the number of times an animation should be played. And in this, I gave the duration of 8 seconds. So the time allotted to it to be for 8 seconds. And then it counts for 5 seconds. So then it bounces up and down. Keyframes, you can also use percentages to style it. You have your 0, you have 0%, that's like the beginning, 50% middle, and then 100%. Oh, that's the down part. Yeah. So here's the demo, and I dropped the code snippet here. And the link. I read it. Yeah, done. Thank you.
Yeah, we can still hear you. I think your mic's off though.
Is my mic on?
Yes, now it is.
Okay.
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 Perfect.
So I said I'm done. Yeah.
Tantoluwa, I think you stopped presenting by accident.
I've unmuted, right? Yes, I have.
Yes.
Okay. So I wanted to show you a few plugins that people use, and it makes their work really nice, but it can it's heavy and it makes sites load slower. Okay. just add water. So it's like a library, and also all you need to do is just to insert and all like that. But it's still like normal. It works like Bootstrap, but it requires you to plug in and all like that. So these few lines are like really they save more time, and they are easier to use compared to plugins that you just copy. I'm not saying they are not good. They are actually good. They make your work faster and all like that. But then at the same time, they can actually slow it. But it won't, it's also good for you to know how to write your CSS, and it's with pop-up wall. So yeah, I'm going to drop the link of my slide and also the demo links that's like linked to my code pen. Yes. Yeah. Sorry. My network.
Hey there. You said you're done with the presentation, or I'm sorry. I think it cut out for me. Hello, Tantoluwa, can you hear me? Oh. All right. Why don't you guys give us some minutes?
Hey, Tantoluwa.
Yeah, hi, I'm sorry, my network. Let me try connecting again. Hi.
Yeah. Hi.
I'm sorry about my network. So yeah, I'll start sharing my screen now. Okay. So yeah, I believe you can see my screen now.
Yeah, we can. So if you want to say more, then all stage is yours.
Okay. So mm, yeah, under the animation timing function, you can also use a Bezier curve for it, and that's sorry, a minute. A Bezier curve, yeah, and it's uses the x and y coordinates, and you can convert both the linear is in or come up with yours. It's the Bezier function. So the number the values it takes in 0 to 1, and that's all about that. Then about the transform, I showed in the demo. I'll say it's up to you, because transform also has different properties. You have the scale, you have none, translate x, translate y. So it's depends. Google is out there and all like that, and you can always check it out and all. Yeah. So there are many other terms you can also learn, but those are like the basic ones that you should actually know, so that you'll be able to understand whenever you see like an code written with CSS. Yeah. So you can also have transition property, and give it something with smooth effects, and you can actually use it on a button too, just a normal floating button that you have to install extensions and all like that. You can use it basically on a button. Okay, I think I'm going to show something. Okay, come on. One. Oh.
Hey, Tanto, I think we lost your screen there.
Oh, okay. Oh, that's true. I'm so sorry.
No worries.
A moment, please. A moment, please.
Mm-hmm.
Okay. Okay, can you see my screen now? Yes.
Yes, we can.
Yeah, so I was talking of a simple button. So I want to show it. So I'll just look for button. So yeah, okay, and I want to give it a over property. So just with how many lines? It comes out like this, and it's like magic. And you can play with it. You can give it, increase the transition duration if you want, but this is what I was talking about, the transition property, and it spreads really nice. Yeah. So okay. So for this stars and all like that, I used to clip out, so you can always check it out and all like that. So I think that is all. Wow. Oh God.
Was that the end of your presentation, or because it seems we lost the? If you're free to finish, if you're done.
Okay, I'm almost done. So let me just show the thank you page.
Okay.
Thank you. You can always reach me on Twitter at heritagealabi1. Thank you for having me, Patrick.
Great. Thank you so much, Tantoluwa. Have a great day.
You too.
So, hey everyone. So our next speaker today is going to be Dean Schuster. Hey Dean, what's up?
Hi, how are you?
Good, you?
You can hear me okay?
Yes, we can hear you perfectly.
Yay. All right, great.
Yeah. So today you'll be doing the topic of science, psychology, and secrets of great UI.
Indeed. I'm going to go ahead and share my screen.
Awesome.
Let's see if this works. Okay, now let's see here.
All right.
Now you should be seeing a big Devfest Poland. Is that correct?
Yeah, that's correct.
Good. And you can see me?
Yes, we can see you.
Yay. Okay, we did it. I'm ready to go if you are.
Yes, we are. The floor is all yours, Dean.
Wonderful. Thank you so much for having me, first of all. It is still morning here in the United States, in South Carolina. It's a beautiful day, and I'm super excited about the stuff I have to offer for you today. It's going to be really good, and I hope you are inspired by it. First, we're going to be talking about the science. psychology and secrets of stellar UI. So it's going to be, I think, a lot of fun. This is one of my favorite subjects. But before we get into the specifics, all of the great tips and tricks, let's go back in time just a little bit. Because right now, we are in a golden age of computing, of information, of content, of tools. And this has all been made possible by engineers. Now, computing itself is still pretty young, right? I mean, this shot of a mainframe, this is not that long ago. In living memory, engineers developed this. They built our modern world. Everything that we do today in terms of software and interaction had to be invented by people. The screen interactions, the theories of usage, everything had to be made. All of the code, all of the languages, from nothing. And engineers did all of this. And early on, they decided they had to understand this new science of interacting with computers, of doing things virtually or on a screen. This was all very new. And so they called these new disciplines HCI, or human-computer interaction. It's also called human factors, or usability engineering. And notice that engineering is on that term, usability engineering. And as time went by, the rules for interfaces became better, more thorough, more codified. And we get something like the Macintosh User Interface Guidelines. Now, the Mac and Apple were some of the first people to popularize this notion that interface work is for more than just engineers or developers. It's also for people who are creative or right-brained or designers or writers as well, people in the humanities. And this was a new thing. As the world of computing began to mature, we get to see more expansion of roles. And in the mid-90s, of course, Netscape comes along, the World Wide Web, and everything really changes because now, in order to make digital products delivered online, we can't just be alone as developers or engineers anymore. We need more people. And suddenly we're working with really different people, like creative people, marketing people, writers, all these people we've never worked with before. And the web today is totally maturing. We expect it to be super powerful, to allow us to do anything. We expect it to be easy to use. The lines between apps and sites is completely blurring. This is true on all devices. And more and more people are interacting with more and more complex systems. Our devices, of course, rule the day. Now, I think developers have lost a little bit here in the conversation because as the computing world has matured, engineers aren't dominating user-centered conversations anymore like they did in the beginning because they invented it. Right? Developers now have lost this sense of human factors, of usability engineering, of the history of their discipline, right? And now this thing has risen, this thing called user experience or UX. It's risen as a discipline. Part of that is just natural specialization. As an industry gets bigger, we specialize and do specific things. And now there's a whole set of people who do nothing but think about user experience of digital products, right? Unheard of. And now you have to work side by side with these people. And they're the people talking about the things that engineers used to talk about: human-computer interaction, usability. So today, what we're going to do is we're going to talk about what they know and what was invented or discovered by engineers so long ago: the science, the psychology, and the secrets of great UI, right? We're going to get ourselves back into the user experience conversation. We're going back to UI school, right? And I'm going to prove a few things to you today that are very exciting. The first thing is that UI is measurable and scientific. It's understandable. It's objective. It's predictable, quantifiable. It's even mathematical. UI rules exist across technology. People do not change. Technology changes. The way people behave, the way they think, the way they see will never change. Later, when we're all working on holograms, people will still be the same and they'll still behave the same way, which means the way they interact with interfaces is something we can study and know right now. UI is also something that you, as a developer and engineer, can understand and can do. No question about this. It is documented. You can read about it. It's not even a secret, as we'll find out in a minute. And it's definitely not just for creative people and is not just for UX professionals. So let's start. The first thing I want to say is that UI is not subjective, right? We all know what we like when it comes to artistic things. We have our own opinions. We think that any kind of art is just a matter of opinion. Beauty is in the eye of the beholder. But this is not true of UI, right? We've been conditioned to think that user interfaces are things that are made pretty after they've been built, after they've been developed. This is not true. UI is not something you do after function has been defined and built. It should be happening together. It's not just something created by creative people. Now, first, a little bit of thought about terms. We hear a lot about user experience or UX. We hear a lot about user interface or UI. And I really want you to think of it as an iceberg, right? An iceberg has a little bit above the surface of the water and a lot below the surface of the water. Well, user experience is like that big part of the iceberg that's below the water. It's all of the thinking, the planning, the strategy, the requirements that go into any digital product. It's how we're going to experience it. The UI is just the part we see. It's just the part that we interact with. In America, we have this saying, and the saying goes like this: you can't put lipstick on a pig. That means you can't make a horrible, terrible thing beautiful. It's always going to be a horrible, terrible thing with lipstick on it. So imagine you create some wonderful digital product. It's got all the bells and whistles and it's convoluted. And in order to make it presentable, you put a nice red bow on it. You make it pretty. Well, that still doesn't change its fundamental nature. If it's confusing, if it's not right, if it's terrible, it will always be that way, no matter what it looks like, right? So poor experience is something that happens regardless of visuals, regardless of artistic ability or presentation. So let's look at this site, right? This is ugly. This is terrible. This is a real site from the Yale University School of Art here in America. Now, they've made this site purposefully terrible. They want it to be bad. But it helps us understand something, because when we look at this, we instantly think, this is terrible. But there's reasons why it's terrible. There's reasons. Similarly, if we look at a site like this, which looks immediately easier to use, simpler, and more approachable, there's reasons why this is true. It's not just art, right? So let's unpack that a little bit, and we're going to come back to that example and show you why it works. First thing I want to convey is that our minds and our bodies are very limited. We'd like to think of ourselves as advanced human machines, and in a certain sense, we are. We do amazing things all the time, but really, we're very limited. We're very, very bad at things like seeing, remembering, and understanding. And that affects how we build things, or it should affect how we build things. But first, our eyesight. I'm wearing reading glasses today. Our eyesight is poor. The older I get, the more I realize my eyesight is not very good. But human eyesight in general is not very good. We're well adapted to see things in front of us, but we're not so well adapted for accuracy, right? So peripheral vision, this is the vision to your left and right, the things in the corner of your eye. We're not very good at seeing things to our left and to our right. In fact, our vision peripherally is terrible. It's terrible. We can see movement. That's fine, but not detail. In fact, all we see is a little bit of an area right in front of us, 10 to 30 degrees. That we see with detail, what we're looking directly at. Everything else is essentially blurry to us. So let's look at, imagine we're standing in a street, we're looking at a car coming at us. This is not actually what our eyes see. Our eyes see something more like this. We are looking directly at the car and we see it. But everything else around us is not actually clear. We think we see it because our brain is remembering all those pieces that go into the puzzle of our vision, and it's interpreting for us. It's putting it together for us in our brains. Our eyes do not see it. Our brain is interpreting. That's very important to understand when you're making digital products. Imagine you're doing something simple like shopping, and you're just looking at shoes. You know, I love to buy shoes, and so I don't see all of these shoes all at once. I see the one thing that I'm looking directly at. Nothing else is very clear to me. Okay, how important is that? Imagine a form. We do these things all the time too. And we go ahead and we click the submit button, right? Now we get an error because we didn't do something right. And we see there's a little red error outline there. But our eyes don't see this clearly. If our eyes are focused on the button, we're really not seeing the rest of the form anymore very well. And we may miss an error if it's not prominent enough. This is why standards have evolved to show errors as extremely big, bold, powerful, loud, because our eyes aren't very good at seeing them. So imagine now if we see this as we really do, even if it's just not quite right, that red is calling out to us. We might see it. And standards have developed around form error handling to handle how human eyes see things. It's not because someone thinks it's pretty. It's because it actually works and has been tested. Let's think of our minds as well. I'd like to think I'm a smart guy. I'd like to think that you all are smart. You're developers, you're brilliant. We all are. But the human mind in general isn't very great at things. So our memory is not very good. You know, we remember an event or experience really as something our brain interprets. We don't really remember it perfectly. We never do. In fact, in America, in our court system, this is why one eyewitness to an event is never enough. You must have at least two, because the human memory is unreliable. So let's think about something simple like short-term memory. We can only hold a few things in our brains at once. I want you to look at an image that I put up just for a few seconds. Just take a few seconds and look at all of these particular logos here and try to remember them. Try to see if you can get all 10. Well, even though I've given you a little bit of time here, when they're gone, not many of us will be able to remember them all. In fact, I would wager none of us can remember them all. We probably only can remember just a few. That's because our short-term memory and our ability to process is really not very good. We're not going to remember all of these images. Also, there are no words with them. There is nothing to really help us. Think of a voice interface. When we do simple voice commands, we don't do many voice commands. We do one, just one at a time. Earlier today, I asked Siri, what time is it in Poland? And Siri answered. And then I can ask something else. I don't ask 3 things at once. Siri doesn't tell me 3 things at once. My mind actually can't handle it. 1 at a time. That's very little. And there's a law about this, about limited capacity of the human mind. It's called Miller's Law. Our working memory limits the things we can handle to just a few. So it just means that excessive choice causes confusion. That's a real problem for user interfaces, isn't it? But think about our brains and the fact that we can handle user interfaces. Why is that? Or why is it that long lists are things that we can remember, right? The English alphabet contains 26 characters. And we learn this as a little child. 3-year-old child can say their ABCs. That's 26 things, not 3, not 4, not 5. How do we do it? Very simply, very simply. We sing it. A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, and Z. We sing it. Now, I'm going to show you a few examples of complex interfaces, and I ask you one question. When was the last time your users sang your interface? This is an intranet that we actually had to redesign. This is the original before we touched it. It is a mess of options and things. This is very common for intranets. I mean, we're not even into software yet. This is just a site. It's a massive collection of links. It's just awful. Endless options. There's no way to find anything. Look at this drop down. It's got a zillion things in it. How can you process it all? There's too much. So when we redesigned it, this is the exact same information you're about to see. Exact same. And now it looks like this. We've limited options. We've grouped them. We've prioritized them. And we've simplified the presentation. And tested it with users. This tests remarkably well now. So there are reasons why this works and the other doesn't. And also reasons why that example I showed you earlier works. We want to reduce the burden on our short-term memory. So look at this part of the site. There's a lot of links here. Well, how do we make it easier? We put them in simple, categorized columns. We gave them simple headings. It's no longer 17 or 18 things. It's 4. Much, much easier, right, for the human mind to get. And there are other things that our mind does interestingly. And one of them has to do with something called the serial position effect. We can think and remember of items in a list at the beginning of the list and at the end of the list much better than anything in the middle. So imagine there's 5 things. Let's give them a label. We are going to remember the first and the last. It's just the way our brains work. The same is true for voice lists, by the way. We remember the alpha and the omega, the beginning and the end. If you know that, you can do things with your interface to fix it and make it better. Let's come back to this screen again. Let's look at our primary navigation. We know from analytics and user testing that the 2 most important main options for this site are patients and visitors and find a doctor. So where did we put them? Beginning and the end. The things that people see most readily. This is tested extensively and it always works, always. The same is true for voice commands. When you are given a series of long voice commands or on an audio attendant, you cannot remember them all. You might remember the first one. You probably remember the last one, but nothing in between, you're certain about. That brings us to von Restorff effect. You're more likely to remember items from a complex series if they're similar, if they're highlighted, if they stand out. You remember the thing that's different. So when you look at this series of English verbs, one jumps out at you right away. drive. You see it right away. You can't help but see it. That's because it sticks in your mind. It obeys the von Restorff effect. That's why hyperlinks look the way they do, because they're marked differently from other words on the screen. They stand out. Another thing we're concerned about is cognitive overload, just taxing our brains too much. Let's look at a site that I went to recently to decide which TV channels I can get. And so as I looked to see what channels I could get, and hopefully you're seeing this scroll and you're not getting too much lag, but this site scrolls forever and ever and ever. It's an incredible amount. I cannot process all of this. I imagine technically I could look and find what I want. Whew, very difficult, very difficult. Too much. This screen is this big, it's huge, right? That's why long sets of characters are so hard for us to see and read and recopy very well, like software keys or passwords. We just can't do it. It's too hard. We have to keep looking back and forth. So we do things like put dashes between small sets of numbers. A little easier. Maybe if we highlight them, easier still. We have to make things easier for humans because we're terrible at things. We'll look at things like remote video conferencing software. You usually have to type in a password sometimes, and sometimes these passwords are 9 or 10 characters and you have to retype them. You have to look at it several times to be sure you got it right. It's just a small set of characters and you have to do that. That's why if you simply put some dashes between numbers, it's so much easier for the human brain to get. These are the effects we're talking about. And they have to do with grids as well. Now, we get into grids a lot as developers. We use them all the time. And they present problems, tons of data, difficult to digest. So what do? Now, here we've done some things. We've alternated the rows. We've added a header row. We've highlighted the most important row, the most important column, rather. This helps a lot. We've given it some space. Good, good, good. But there's still scrolling problems. If we scroll this list, our heading goes away, and our brains can't remember what the columns are supposed to be, even if we see this a lot. So one little thing we do is we fix that top header row so that it's always there. That helps our brains just see what it is. It's amazing how little things like this help our terrible brains. Okay, now, those are some senses of what we're like in our very nature. But there are also some things to learn about how we behave. Good design is based on well-tested, documented models of human behavior. We know all about these laws, and they're excellent to know because they're tested so well. But before I do that, I want to encourage you a little bit about understanding these laws of interface and human behavior by telling a quick story about the Rolling Stones. Now, this is a famous musical group from America. They're internationally known, and they're made up of musicians who, particularly when they were new and in their heyday, making all their music, could not actually read music or write it. They just had inherent talent. They were just musical people, untaught. They didn't go to school. Keith Richards, he's the rhythm guitarist. Now, this guy, he wrote almost every song. And he also pioneered new ways to play the guitar with open G tuning. He can't read music. He can't write it. He's just always been able to do it. He's an artist. He gets it intuitively. He was always musical. But he's not the only person who can play music, can he? Because music is kind of like math and science. It is a language. It has rules. You don't have to be an artist to understand it, to read it, to write it, to play it, or to enjoy it. It's for right-brained creative people and left-brained quantitative people. So what does this mean for us, for the screens we make? Let's look at some laws, mathematically proven laws. The first one is Fitts law. It tells us how size and distance in an interface affect how we use it. All right, here's the equation. This is the real deal, okay? This equation basically says the faster and easier you can find something has to do with how big and how close it is, right? The bigger and closer something is, the quicker and easier you get to it. Total equation, totally provable. This equation has helped make interfaces for years. So imagine you have objects on the screen, some big, some small, right? Well, this big one is close, easy to get to. That little red one, a little farther away, take you some more time, and you got to kind of manipulate to get it. It's harder, takes longer. Right? Size and distance affect accuracy. This is why in an interface, when we make really, really important buttons, they are large, they are close to where we know someone's looking. That's it. But here's the fun thing. The equation says that W, the bigger the width, the bigger a thing is, the easier and faster you get to it. What if the width of a thing was essentially infinite? If something is infinitely big, you can always get to it fastest and easiest. Now imagine any OS, Windows, Mac, Linux, whatever. You've got a visual OS, you've got stuff all around the sides of the screen. That's because when you take your cursor and you scroll, when you hit the side of the screen, you stop. No matter how much you keep moving, your cursor stops. Essentially, that means that the things on the edge of the screen are infinitely big. You can scroll forever and you will still be exactly where you are. And that means getting to the edge of the screen is fast and super easy. That's why elements on the screen are on the edges. They obey Fitts law. That's why it works that way. And it is a mathematical reason for existence, not primarily a design reason. Let's look at Hicks' law. The volume of choices affects how long it takes to choose. We've already talked a little bit about how our brains work here, but there's a real mathematical law to it. This is the law of simplification. Do less as much as you can. And here's the math. Fewer options mean faster decisions. And this is essential for digital products, right? In America, we call it the KISS law, the KISS law. Keep it simple, stupid. That's the law. Now, imagine you go to a restaurant and you look at a menu and it's got a lot of options. No problem, but you can't choose quickly. You can't order a pizza quickly from this restaurant. If you had two choices, pepperoni, cheese, very fast, lots of choices, slow. That's why most complex software, and this is by far, this is older software, not very complex. It can get worse than this. This is why it just takes so long to do things if you're untrained. And even if you're trained, it can be a problem. Of course, Google saw this issue, and when they launched, they were very simple. And this principle works for interfaces like this, a simple survey interface. First of all, things are big and easy, right? They're obeying Fitts law, and they're obeying Hicks law because there's few things to do. And by doing both of these things, this is a very easy interface that tests beautifully with young people, old people, good dexterity, bad dexterity. Okay, a few more things before we're done. There are some grouping secrets that are really important to interfaces because when we make interfaces, we've got to put things places. And the way we group them and space them really matters. And there's laws about this too. And this is part of something called Gestalt theory, patterns. Humans are very good at recognizing patterns. So let's take advantage of that. You could probably see the pattern in this screen right now. You could read Gestalt even though it's not part of something that's a simple word yet. It's just a jumble of words. And now we see that pattern. We're good at this, so let's use it. A first law we're going to look at is the law of proximity. When things are near each other, our brain groups them. Imagine we have a bunch of stars. They're all over the place. We just see a bunch of stars. Same amount of stars. If we group them like this, we see 3 rows. We can't help but see it. Our brains do it for us. We can't help it. It's automatic. If we separate it into groups, we see 2 groups. Our brains do it automatically. Same with columns. This is why software like client-server software is so hard to use for so long. It was jumbled, it was tight, and if everything is close, nothing is close. These designers tried to put things in boxes and tried to make it work, but mostly it didn't, and you just have to be trained. So proximity helps us put similar things together. And when we put the same things together, in this case in a box, they feel like they belong together. They're easier to understand. This is also true of words on a screen. This is an equidistance problem. The title is just as close to the thing above as the thing below. So where does it belong? Now, we're coders. We know it's a title, but it's lazy coding if you coded HTML like this. It's hard for people to tell what belongs to what. If you just moved the title closer to the content it's about, boom, instantly better. People see it faster, it tests better, and they do tasks better immediately. That's the law of proximity. It also works for very complex interfaces. We're going to keep graphs away from grids. We're going to separate them with space. Even the grids have very different types of darker header rows or darker singular columns. We're doing everything we can to group things so you can see them readily and see them as one thing. If everything was just in a blank white grid, you'd essentially be looking at Excel. And if you have to do that all day long, it's very difficult on a person. So we want to design to help them. A few more things. There's something called the continuity principle. The human eye follows paths and curves of a design, and it sees a pattern. So we don't see a bunch of circles here. We see a line. We see a pattern. That's very powerful, because if we can put that into our interfaces, we can help people know what's next. So if we look at something like 3 squares, X, X, check, our brains are moving us. We can't help but see it's going somewhere. It's going to a place. That's why step-by-step processes work so well with the human mind. We automatically view a series of things as a natural progression, going from one place to another, a beginning to an end, and it helps us understand where we are in space. That's just clarity in terms of this principle. We see shapes and patterns, so let's use that. Well, there's another nice little thing called the law of closure. It's a bit of an illusion, and it's one of the most powerful laws we've got for mobile. Basically, it means that the human mind sees shapes even when they're not there. So imagine this image. Well, it's an image of 4 triangles, and we probably see the triangles, but we definitely see the square. There is no square. It's an implied negative space shape that our brains instantly see. Very good. Our brains are good at seeing patterns. So how do we use that in mobile? Well, closure in mobile apps is the most powerful interface item I think there is. Because if you look at these mobile screens, you'll see at the bottom, before you scroll, there's a hint of more to come. There's a shape that you see that has started. And your brain instantly says, that's a shape. It's like the other shapes. It keeps going. And you just know to go look for it. That's why we hint at things at breakpoints and scroll lines to help people understand that there is more and that they keep looking and there's other things to do. It is the dominant interface paradigm for mobile devices. And a couple more. There's a pattern called connection or union. When we unify certain areas of a design, it becomes a new thing, right? So imagine we're looking at some squares. It's 28 squares. There's a bunch of squares or a big block of squares. But if I highlighted just a couple of the squares, just 6 of them, those 6 become a new thing, a special thing, a thing that stands out. And we use this all the time in software and in web. If you're going to a bank, this is why your login area is now in a box separated as a unique thing. Your brain highlights it, sets it apart, and even better, it's become so well understood and used, it's now a mental model. We understand what it is. And this is all built on these principles of design. That's a lot. And it is really only the beginning of all of these rules or all these items that teach us about UI or about our brains or about our behavior. There's so much more. I just want to encourage you with this talk that great UI is something you can know. You don't have to be a creative person. You don't have to be a designer. You don't have to be a UX professional to understand this, to be able to talk about it, to be able to deal with the concepts. I mean, UI is just not a mystery. It's not special knowledge. It's not even secret. This is stuff that's easily Googleable. You can Google this easy. You can read about it, and you can study it. So here's a few links. Now, I'm going to make my slides available to the conference, so you don't have to necessarily remember this. But these are great links that go into detail on all the things I've talked about today. They're fascinating and they're fun, and I really encourage you to spend time with them. And here are a few books to read. Designing with the Mind in Mind. Design of Everyday Things by Don Norman. He is the man who coined the term user experience and visual thinking. But if you had to pick one thing, just one, Designing with the Mind in Mind. It is written for people like us who are developers. It's written for quantifiable thinkers. It's a great resource for you. It's got so much good stuff. It's amazing. And if you learn these things, it doesn't mean you're going to become a great artist or a great UX designer or a visualist. You don't need to be. It will make you a stronger developer, no question. It'll make you a better teammate. You're the person who understands what everyone around you is doing and why they're doing it, and you can contribute to the conversation. You become like a superpower developer just by knowing this stuff. You will also gain serious respect from people who are not used to dealing with developers or engineers who know this. They will want to talk to you. They will want you on their team. And another fun thing is you're going to be able to see bad UI and say, that's bad, and I know why that's bad. You're not grouping things correctly. You're giving me too much to think about. Our brains aren't good for this. You'll have real reasons. They're not subjective. They're objective. They're mathematical. Now imagine this. Most developers I know that are making great digital products, they believe that their work and their products will be so much easier to make if the non-technical people around them, writers, designers, UX professionals, leaders, managers, if they understood even the basics of coding or development, it'd be so much easier to talk to them. So much easier to have good conversations that are productive. Totally true. But the reverse is also true. Making great digital products would be so much easier if engineers and developers understood the basic design and usability laws and rules. And now I've shown you a little bit of them, and now you know that you can research them and know them as well. And you can totally do this. And I encourage you to, and I hope you have fun doing it, because it's really great stuff. Thank you so much for listening. My name, again, is Dean. I'm with TrueMatter. I'm a partner of a UX firm here in the States. We've got a great blog that includes all sorts of stuff like this for you. It's not something that sells you anything. It's just great articles that help you understand UX rules. And if you want to talk with me about any of this stuff or ask questions about some of these rules, you can find me on Twitter or Instagram or email me. I'd love that. Otherwise, I'm all done. And thank you so much for listening. I appreciate it.
Thank you so much, Dean. That was a great presentation. Truly, truly enjoyed it.
Thank you.
I guess let's wait for a little bit to see if the chat has any questions before we finish up.
Great. And again, I'm happy to answer any question offline. I'm easy to find.
Yes. Serhat Tas is saying great presentation. He also enjoyed it, it seems.
Cool.
Same with Andrei Kovalchuk. He really enjoyed your talk.
Thank you.
So, looks like there's not be any questions.
Okay. I'm going to stop sharing my screen.
Go for it.
And there we go. Should be back to normal.
Yep. Let me pop this off.
Yay. Okay. Well, it was great to see everyone. And
Yes.
thank you for sharing a little bit from South Carolina and USA today.
Yes, thank you so much. Have a great day, Dean.
Bye.
Bye.
Okay. Thank everyone for coming here. It's time to wrap it up. So I will start by most important things. So, if you're based in Poland and want the goodie bag, be sure to finish our post-event survey. We'll be posting you the goodie bags by the patch commands. So there's a limit, of course, but I hope everyone who enjoyed and was here will be able to get their one. I would like very, very much to thank our team, because without them, it wouldn't be possible. You were really great. I enjoyed working with you. And if you want to join the next Devfest and be one of those magnificent people, just look after GDG in your town. So thanks again to our Ultimate Sports on GFT, the great company that is really enjoying working with communities. It is really important to them to be visible in the communities, share their knowledge, support it. So if you will find the job description that fits you in their career page, be sure to post it, take the part in the interview, because it's worth it. It's a great company. And of course, we would like to thank Droids on Roids and JetBrace as our sponsors. You really help us, guys, and really enjoyed working with you. We'd also like to thank our media partners, Sigfold, JustJan IT for developers, Android Compa and Programmista for sharing information about this event, and our community partners, Kaggle Days, Let's with GCP User Group Poland, Wrocław Java User Group, Logcat, and Warszawa IT Meetup. We really like to work with communities, so if you are part of some community that is doing something around IT in general, share and reach out to us. So thank you again very much. Stay safe in this time. And I hope I will see you all in the next Devfest. Bye.